Cloud computing is easily one of the most sought after domains when you talk about technological world. And when you talk about cloud computing, you cannot shy away without mentioning Amazon Web Services, that is AWS. AWS is one of the most preferred public cloud service providers, and from a career perspective, it offers some of the most in-demand cloud certifications. That is why Great Learning brings you this AWS tutorial for beginners, which would act as a complete course for you to get started and also get your hands dirty with some of the most core concepts that AWS has to offer to you. So let us quickly go ahead and take a look at the agenda or offerings of today's session. So we would start off this session by discussing some of the fundamentals of cloud computing, like what it is and why is it so popular, what are some of its service and deployment models. Then we would go ahead and understand what AWS is and what are the career opportunities and options it gives us. Next, we would discuss AWS global infrastructure and how it works. Then we would get into some of its core service domains. We would first understand what are the compute domains or compute services that AWS offers to us. What are the AWS storages that we have, or what are the types of services that AWS storage supports? What are some of the core networking services that AWS has to offer to us? And going ahead, we would understand what are the DevOps services that you can implement on top of AWS Cloud Platform. Next, we would talk about machine learning services that AWS supports. And then again, we would get into AWS Core Services, where we would understand how security services work on AWS. What are some of the popular monitoring services that AWS supports? What are some of the database services that AWS has to offer to us? And finally, we would discuss some of the career questions or career opportunities that AWS has or offers, and some of the common questions that people seek answers to. So we would answer those questions and then wrap up this session. So that the agenda is clear now, let us quickly go ahead and take a look at the first topic of discussion. To understand cloud computing and its fundamentals, first, we need to actually go ahead and understand how cloud computing came into picture. Why cloud computing, right? So let me just go ahead and give you a scenario. When I say scenario, let us try and understand what were the things, or how did cloud application, or rather application hosting worked before cloud computing came into picture, right? So when I'm talking about this era or this time frame where we were not so familiar with cloud computing, I want to discuss how businesses used to work in these days, right? So this is a general example. Do not take it as a hard line. I'm sure everybody has also, there would be quite a few people here who would have lived in this era and would have known business much better than me. So I'm not challenging anybody's point of view, but these were some common offerings or some of the common observations that people had during this era. So the era that I'm trying to mention, or the time frame, time duration period that I'm trying to refer to, is somewhere around early 2000s, right? When cloud computing was there, but it wasn't that well accepted because it wasn't known to many people yet. And there were different ways in which businesses used to happen. And since I'm talking about businesses, I'm more or less referring to the fact or to the businesses that mostly concern application hosting, data hosting, websites, and all those things. I'm talking about more technical sort of businesses here. So let us try and take a look at few basic examples or few basic pointers, right? So what you see on the screen is, in order to start business. So again, I'm referring to the time around 2002-ish, 2005-ish, right? Some 15 years, 18 years from now, if we go backwards. So in those days, in order to start this kind of a business, right, you had to actually go ahead and set up infrastructure. That is the primary need of any business, if we talk about. So in those days, in order to host a website, an application, you actually had to have a proper infrastructure set up in place first. So this infrastructure needed you to have servers, right, on top of which you would host your applications. But then back then, servers were not available at a cheap price. You had to invest a lot of money. And as I've mentioned, servers were very costly. So there was a problem here, right? People with money could think about setting up such businesses. To give you an example, if you talk about Google, if you talk about Amazon Web Services, now these are the companies that have been there in the market for a very long time. And companies like these, if they want to take new initiatives, they can. But let's assume somebody has to start from scratch. Now, in that case, money might become a constraint here, right? Somebody might have an idea, but money is the reason that this person is not able to start this particular business, right? So that was one problem. And even for people who have money, right? I mean, you just cannot go ahead and say that, okay, pay money and just start working, right? You'd always think how you can have optimum use of your monetary resources or any resources that you have. So when you talk about this time, servers, as I've mentioned, were costly, right? So you had to put in a lot of money there. And there was another thing that you had to worry about. This was about the manpower. Because since you were buying your own server, and as I've mentioned, you had to put in a lot of money, that meant you also needed people who could maintain and monitor these resources for you. So yes, back then too, we could set up infrastructures, we could have people to maintain and monitor these businesses for us. But then there were problems with this approach. Let's try and understand what were the problems here. So when you talk about the challenges or the problems, as I've already mentioned, you had to invest heavily to set it up in first place, right? And get resources to actually manage this setup. So apart from the investment part or the money part, there were other problems here as well, right? So when I talk about the resources that I have, so if we go back to that time, right, we did not have these many people who were well adept with technology. We did not have internet like we have these days, right? So that you can just go ahead and Google whatever you want and get knowledge on it and at least get started with it, right? Back then, setting up your own website was a difficult task because you were not sure whether people would use it, right? So there were limited resources as well who could do these kind of things for you. So that meant they also charged you a lot of money. And not just the money, there was a lot of planning that was involved here. Since you had to buy these servers, set up infrastructure, have people to maintain and monitor them, in order to optimize these things, people used to plan it. We still plan it with cloud computing as well. But back then the planning was to a bigger level. And there was a reason for it. The third point you see on the screen is scalability, right? I mean, when you talk about these kind of businesses, these applications, you're never sure, right? I mean, how much data you would be handling, how much traffic you would be accepting or expecting, right? So what that means is basically, since you are not sure about how much traffic you are expecting, what that does is it makes you plan these things, right? You would assume that, okay, this is the amount of resources that I might need to handle this kind of traffic. But there are two scenarios here. One, what if not that many people show up? What if not that much data is being used, resources are being used? So you're underutilizing your resources. But since you're paying for those upfront, you're losing that money. Let's assume that you've planned it well and you have had people that are meeting the needs that you were expecting to host, right? But what if it goes off board? What if you have more traffic? In that case, there's again problem, right? I mean, you have to scale up now. So again, your planning is not working. So you would need people again, resources again who could scale this up. Back then it was not easy, right? I mean, you could not just go ahead and say that, okay, scale it up. My need is this much. Give me the next plan. No, you had to set everything up again. And again, that required you to invest a lot of time, a lot of money and a lot of resources. So again, there were problems here as well. So when you talk about setting up businesses back then, it wasn't an easy process. And it wasn't something that anybody who wanted to do it could just go ahead and do it, right? So what this meant was, even if you did go through all this pain, you had very little time to focus on your business, right? If I invest all of my time doing mundane activities that are not fruitful, my business is not going to do good. I would rather focus on my business decisions and let somebody else take care of these things, right? So these were the problems that came into picture when you talk about time where cloud computing wasn't this prevalent. So this is where cloud computing actually came into picture and people started realizing that cloud computing could solve these problems. Let's try and understand how cloud computing helped here and what it is exactly. So whenever I think of cloud computing, the first thing that comes to my mind is electricity, right? I'm saying right, I'm sure you people are not getting what I'm trying to come to at. Let me explain you this point a little more. So guys, we all use electricity at our homes, right? Again, this won't be an appropriate word. We do not consume electricity directly, but we all use telephones, we all use mobile phones, we use our tube lights, we have our refrigerators, TV sets that keep running, our laptops which keep running, right? So they consume electricity. What we do is at the end of the month, somebody gives us a bill. When I say somebody, our electricity boards. I used to live in Maharashtra. I was born and brought up there. Maharashtra is a state in India. Okay. So we had this board called as MSEB, Maharashtra State Electricity Board. So they used to send us a bill, and we used to pay the bill for the units of electricity that we've consumed. Now I'm based in Bengaluru. So Bescom sends me the bill. If I'm not wrong, Bescom is the name in Bengaluru. It is a city in Karnataka, India again. So the point I'm trying to make here is the electricity board takes care of what electricity I'm consuming, how much am I consuming it, and how much should I pay for it, right? Also, they manage the process of delivering this electricity to my home. I do not have to worry about outages and issues. If there's an issue, they solve it. I can reach out to them through a call, but I actually do not have to actually go ahead and look into these things into minute details, right? My concern is I consume electricity. If I consume more, I'll be charged for more units of electricity I consume, and I'll be paying more, right? I do not have to worry about the underlying process. That is the point I'm trying to make. So when you talk about cloud computing, it is very similar to this process, but in the process of application hosting and not electricity. So here what happens is, I would be having my cloud service providers who would be providing these resources to me. They would be maintaining and monitoring these resources, helping me in the configuration part and the migration part. What I do is at the end of the day, when I host my application on these platforms, I assist or I look into how it's working. At the end of the month, or at the end of my tenure, the amount of resources and for the time duration I've consumed those resources, I would be charged only for that duration. So that is what cloud computing does for me in a nutshell. Okay. And as you can see on the screen, it says you pay for what you use and somebody else manages these services for you, right? So let's get back a little deeper into cloud computing. Let's try and understand what happened exactly. So as I've already mentioned that if you talk about companies like Google, Amazon, then Microsoft, these are big companies, right? They have been there in the market for a very long time. And these are the big players, big fishes, who've been in this pond, the technology services pond, for a very long time. So they have a lot of money, right? They have a lot of data that they manage every day, and they understand the importance of data because it's making calls these days. And they've realized these things. They had realized these things way before we all did. And that is why they were always ahead when you talk about providing technology to people, meeting people's needs, consumers' needs. So if you go to early 2000s, some of these platforms realized that why keep cloud computing to us, right? Because they had these stack of servers with them, which they used to have the data. So they realized that there were so many people out there who could actually make use of their servers which were running idle, right? Not all of the servers were being used. So why not instead give these servers for others to use? But since they're costly, nobody will buy it. So they thought, why not let them rent these these resources, right? So if they could rent these, we won't have to charge them a lot. We would own our servers and they would also get to use those servers, right? Or those resources in general terms, which are based obviously on those servers. So this is how the process of giving services, right, to people was made available in the form of cloud computing. But why do we call it cloud computing? Well, cloud computing again is a concept, right? And the reason we call it as cloud computing is because you can think of these servers residing on a space that is imaginary for you, something that you cannot touch or see. What this means is you're sitting in a particular part of the world where you can access these resources by sitting at your home, by sitting at your workplace. All you have to do is you need to have a good internet connection. You should be signed up to these platforms and you can access their resources from there. The reason again we are calling this as a cloud platform is since you're accessing these resources from your system. For example, I'm I can access my cloud services from my laptop from my home, which I'm doing right now. So, but my resources might not be here where I'm living right now, not in this area, not in the city. They might be in some other part of the world, someplace I do not know. But the feel that I get right now is I'm using those resources here at my place. When I type a mail, what do I say? I say that I just typed a mail on my laptop and I sent it to you, right? But even to the person I'm sending it to, it's not actually a physical thing that is lying with him. It is residing on some server, right? So since this space is imaginary to me, just like a cloud, we call it cloud computing. Okay. So basically what it means is you can access these resources, but they would be residing at some data center to which you do not have an access to. It could be close to you, but it may not be as well. You just access it through your internet. We'd understand cloud computing a little more. I'm just trying to give you a picture as in how cloud computing came into picture here, how it helped solve the actual problem that we were trying to discuss. So going back to that point, one, you could rent these resources, right? You would be paying these resources only for the time duration you wanted to use them for. Scalability issue was solved here because these resources could scale up and scale down to meet your needs. And this could happen in a very less time without you having to invest any or a lot of money in excess, right? So if you could upscale, you would be paying only for the upscale part that you've done and only from that time duration when you've upscaled, and from going ahead, you'd be paying for that resource accordingly. So there were no hidden charges here. That was one plus point. And since these cloud platforms manage these things for you, you do not have to worry about resources taking care of these issues, right? So all the problems that we discussed there, majority of those were solved here. And this is how cloud computing helped. So I guess a general idea about how cloud computing came into picture is clear to you people. Let us go ahead and try and understand what exactly is cloud computing, right? So I've pretty much made it clear, but let's quickly understand cloud computing in a nutshell, and then we can move further. So when you talk about cloud computing, in simple words, as the screen and my slide deck says, it enables on-demand services like computation, storage, networking, etc. When I say etc., those can be your databases, machine learning services, IoT services, security services, and a number of other services that cloud platforms have to offer to you. So in simple words, it provides these on-demand services. That means if you have a demand for a particular kind of resource, that would be provided to you. Now these resources can be accessed through the internet, and the user is not required to maintain, manage, or monitor these resources. Again, there are monitoring services that these platforms offer to you. How much control do you want over it? That is something that you and your vendor can come to terms with. But if you require complete management, even that is available when you talk about these platforms. So what are the features of cloud computing? To start with, one, it is highly scalable, right? When I say scalable, it basically scales to your need. You can have resources that can just scale in seconds, in mere seconds, to be very practical. And since there is so much freedom here, you can upscale and also downscale. It's not always that you've taken a resource and you feel that, okay, now I have to pay for it no matter what the cost. That is not the case. Let's assume that you are underutilizing the resources. You can actually go ahead and scale down as well if there's room for that, right? If you are already using the minimal size of a resource, then that could be difficult, but you get the overall point here. Pay-as-you-go model. I've already discussed this point, but let me quickly throw some light on it, right? So when you talk about cloud computing, one, there are so many ways in which these cloud platforms try to make your resources cheaper for you. They give you discounts to start with. They have various other ways in which you can keep track of all the payment that you do, right? And when you say pay-as-you-go, if you talk about platforms like Amazon Web Services or Azure, they charge you on per minute basis for most of their services. So when I say per minute basis, so if you fire up a particular resource and if you're using that resource for like say 15 minutes, so you'll be charged only for those 15 minutes and not more. No sooner you release that resource, you won't be charged for it. So that is what pay as you go model is. You pay for what you use. Highly flexible. So as I've already mentioned, services or platforms like Amazon Web Services With Amazon Web Services, there are like 200 plus services. So you can understand the amount of options that you have when you talk about this platform. Now, if you talk about other platforms like Azure, GCP, they too have like 60 plus, 120 plus services. So there too you have a lot of options that you can choose from, chop from, right? And when you talk about flexibility, it's not just about these service options that you have, right? There are quite a few other parameters that we consider here. Scalability is one, pricing is one, right? All these combined together, even security, the point that you see next on the screen, right? So even security is something that gives you quite a few options. And since there are so many choices that you can make, this makes cloud computing highly or truly flexible. Okay, so let us go ahead and understand security and disaster recovery. So security is something that we'll discuss a lot, and disaster recovery as well. Disaster recovery is something that we'll be discussing very soon. Not worry about that. As we move into the further bits of this session, we would be talking about disaster recovery as well in detail. Security is something that we'll be discussing a little later, but that its time will also come. To give you a general idea, cloud platforms like Amazon Web Services, they give you shared security model where you and your vendor decide what access you get and what all can you control, right? Accordingly, they also have quite a few things that they control. So when you talk about security, all these things are taken care of, and your platforms ensure that your cloud platforms rather ensure that security is taken care of with utmost importance. There were times when people actually doubted cloud security, and it was understandable. Cloud computing was new back then. If you go like to early 2010s, there were outages and people had lost their data, but that has changed a lot in like last 5 years, 6 years. It has been very up to the mark, and you rarely see your data getting lost. And the reason for that is there have been so many principles and so many filters or activities that have been involved, which ensure that your data is secure here when you talk about cloud computing or cloud computing platforms. So disaster recovery, again, disaster recovery is something that lets you have your data in case of disasters or worst case situations as well. What are those and how do they work? We'll explore those as we move further, but let's not discuss that right away. But in general, these are the features that your cloud platform has to offer to you. It is highly scalable, offers pay-as-you-go model. It is very flexible, and it gives you high amount of security and disaster recovery as well. So let us go ahead and try and understand some other pointers as well. So now let us go ahead and understand different cloud service models to start with. Okay. So when we say cloud service models are a way in which cloud service is given to you from your vendor, or the way in which you consume this cloud service, right? I know right now it's not making a lot of sense. Let me just quickly show you few things. We'll discuss this, and probably what I'm trying to say here, I'll reiterate that, and that would start making sense to you people. So guys, when you talk about cloud service models, to be frank, recently there have been more service models that have come into picture, and that is something that is bound to happen. But if you talk about general terms, these are the standard service models that have been there in the market for a long time. And that is why we'll be discussing these major ones. These major ones are infrastructure as a service, platform as a service, and software as a service. Let us try and understand them one by one. So when you say infrastructure as a service, so as I just mentioned, when you talk about cloud service models, it is a way in which your vendors provide you cloud services, right? So here infrastructure is provided to you as a service. Let me give you another example, or let me give you one example here to start with. So when you talk about infrastructure as a service, what you do is you go to your vendor and you tell your vendor that, okay, give me a virtual machine. Okay. I want to take care of what security group it will lie in, what network it would lie under, right? What kind of storage I want on top of it, right? And what kind of application I want to run on top of it. I'll take care of all those things, right? From security, networking to all the configuration part. All I want is, I want infrastructure that I can scale up and down to my needs, right? So in this case, Your cloud service provider is giving you infrastructure. You can scale up, scale down to meet your needs. To give you one example, if you talk about AWS, you are provided with a service called as Amazon EC2, Elastic Cloud Compute, Elastic Compute Cloud. Call it either way, it's correct. So basically when you talk about EC2, it is an infrastructure as a service where you launch your virtual machines. Okay. So here you get to configure all the details. What network do you want to put under this service to be put under? What are the IAM policies or what are the security policies? Who gets to access these resources? You can actually detach your storage from here. You can increase the size of the storage or the volume that is attached, right? So you can control all these pointers, all these factors here. So here you're basically being provided an infrastructure, something that you can configure to meet your needs, right? But then again, the requirements of a business could be different. Let's assume that I have an application that is ready with me, or I have a piece of code that is ready with me. But right now I do not have resources where I can run this code. But I do not want to also go ahead and set up my infrastructure from the scratch. I just need a platform where I can put forth my data, my application, my code, and I can build my application there and start working with it, right? So here you need a platform. And when your cloud service provider gives you service in this form, it's called as platform as a service, right? So this is the second service model that we are going to discuss. To give you another example, you have your applications that you build, right? Again, treat this as a general example. Don't get into the details of it. Here, what you do is on your mobile phones, at times, basically you run applications, right? Where do you download those applications from? From your Play Store. So Play Store is a good example of a platform, right? Where you can actually go ahead and put forth your applications as well, right? So this is where you have a platform. Now, when you talk about a cloud platform, there are more options that you have here. As I've mentioned, the configuration part is taken care by a cloud provider here. So when you say, give me a Python environment, I have my code, I just want to put it there. So your cloud service provider will launch an instance for you. On top of that, create atmosphere where you have your Python notebooks, Python environment created for you. All you do is you put your code there and it will, you can start working on it and start running it, right? So that is called as giving you service in the form of platform. Now, again, there could be a situation where you just want to consume a software. To give you another example here, I would say, let's assume that you want to send an email. In order to send an email, it's not going to be like that you will build an application, share it with your friend or a concerned party, then ask them or tell them how to use it, then type a mail and send it to that person. No, right? You won't do that. Instead, you would just fire up your Gmail, open it, write a message and send it to your friend. You do not have to worry about what if Gmail goes down, what coding platform it is based on. That's not your concern, right? Your concern here right now is to send an email. And here you can do that by using your website, Gmail, right? Or using your application that you have in your phone. So guys, when a software is given to you in the form of service, a website is given to you in the form of a service, it's called as software as a service, right? Here the complete software is given to you in the form of a service. Your other example would be your Facebook, right? It's a website which you log into, you post your images. You do not have to worry about security and all those things. Your Facebook manages that. Yes, we are concerned about our data, right? That is a different thing. We'll discuss that some other time. But meanwhile, I believe that gives you an idea as in what software as a service is. To give you a more popular term here, Salesforce is something you can think of as software as a service. So guys, this was about different cloud service models. I hope it is clear to you people. If not, I have this diagram here. Let's try to discuss this from this point of view. Now, since this session is for great learning, I did happen to go through a session from one of the mentors at Great Learning, or one of the pioneers of teaching standards here at Great Learning. So, Mr. Nirmalya, he is someone who's very good with cloud computing and has been in this domain for a very long time. So he did have this example that you see on the screen. He probably explained it a little differently. So I'm gonna try and adapt to what he's done and probably explain that because I liked what he did in that session. So let's try and understand what cloud service models are from this perspective. As I've mentioned here, if you talk about IaaS, your vendor manages your virtualization, servers, storage, and networking, right? So they give you these services. On top of that, you can decide what operating system you want, right? Windows, Mac, whatever it is. What middleware do you want to use? Runtime, applications, and data you control, right? If you talk about platform as a service, you control only data and applications. As I mentioned, you can move your applications or code and start running it there. If you talk about SaaS, you just maintain your data. I just send files through Gmail, right? So I'm maintaining my data. I'm not concerned about who is managing or monitoring my application, right? Not my concern. So this is what SaaS is. Just like having a pizza, right? I mean, if you basically decide to cook the pizza on your own, you'll go to the market, buy some ingredients and start cooking your pizza, right? So you do everything from scratch here. Let's assume you order home delivery. So you get the delivery, somebody else makes it for you. All you do is probably you open the stuff that is there, put it in your own plates and start eating them. So you do not have a lot of dependency on others. Somebody else is doing it for you. But let's assume you go to a hotel, right? Even from giving you the pizza, making it for you, serving it on your table, right? Even the cutlery and the table belongs to the hotel. All you do is you just go there and eat the stuff, right? Just like software as a service, you're just consuming the software. So I believe these service models are clear to you people. We've spent a lot of time. The reason we did that was because these service models are important and they'll help you understand cloud computing a little more. Okay. So the picture is clear here. Let us go ahead and understand the next topic. Cloud deployment models. Now this is a way in which your cloud services are deployed. Okay. Let's take a look at the pointers quickly because that would give you a clear idea. Just like we did for service models, right? Let's understand deployment models as well. So when you talk about cloud deployment models, there are quite a few models that it has to offer to you. You have your public, you have private, you have your hybrid and community. Okay, let me give you a use case or let me talk about these things on surface with examples. That would give you a lot more sense into what these topics are, right? So when you talk about a public cloud, right? Amazon Web Services is a public cloud, right? So here, what you do is basically you put forth your resources on a certain data center, right? So in this case, the data center is publicly available. There's a possibility that I'm using this data center to host my applications. There could be a possibility that the person who stays, right now I stay in a 3-story building. So the person, I stay on the second floor. So the person who stays on the first floor might also be using the same cloud, right? That I'm using. There could be a high possibility that that person's data is also lying on my data center, which I'm using. So basically I'm using a similar set of services that resides close to the one that my owner or my person who lives below my house is also using, right? On the first floor. So this is what public cloud is, guys. You are sharing your resources with somebody else. So when I say sharing your resources, it's not like you and that person is using the same spoon. There are walls here. So, your data is very secure. Do not worry. It's not like you are sitting with someone and kind of working on your confidential data and that person is getting to do what he wants to or she wants to with that data. There are proper security principles here, but the only thing is your data resides on or could reside on a platform where somebody else is also using it. So this is what public cloud is. Let us go ahead and understand private cloud. So we could be in a situation where our data is very critical to us. We do not want anybody else to use or have access to this data, right? So in that case, it is wiser to opt private cloud. Now, in a private cloud, your data resides at a place which is not used by anybody else. Companies like Dell, HP are some popular names that provide you private clouds. So you might say that, why should I have a private cloud, right? So is it not like just having my own infrastructure, on-premise architecture, where I buy my servers, right? So when you talk about private cloud, here too, you're renting the resources. But since you are having a cloud or a data center for your personal usage, you would be obviously charged more than your public cloud. But here your security is taken care at a deeper level. So when I say security is taken care at a deeper level, that means you're not sharing your space with anyone. So you have that more safety in your mind, right? So that is what private cloud is. But let's assume that it's not always one shoe fits all situation, right? There could be a situation where there would be certain resources that you feel are not very important, and actually when you put it on private cloud, you're paying a lot of money for it, right? The other situation could be there could be little amount of data with you that is important to you, and it has to reside aloof or in a private cloud, right? So you are in a pickle, right? Whether to use a public cloud or a private cloud. So for these people, you have your hybrid cloud. So as the name suggests, it gives you benefits of both public and private. So some of your resources can reside on public cloud, some can reside on private cloud, and they can communicate with each other to ensure that your data is lying in both places. So the data that resides in your public cloud or not in your private cloud is something that is important to you, but is something that you can do without with as well. So that is your data that lies on your public cloud. But assume that there's some data critical situation where your data has to reside in a security place, then you use the private cloud here. So the amalgamation or combination of your public and private cloud, it gives you your hybrid cloud. And then we are left with community cloud. So we are done with public, we are done with private, we are done with hybrid. Now you might wonder, what is community cloud, right? So guys, again, this is just an analogy. Do not dig deeper into it. Let's assume that Great Learning has like 20 offices across India. This is just an example, okay? So in this case, all of these people could be using common data, common repositories, right? That are common to the business. So why not have a community cloud that connects all these people? Just like right now, since we are in this corona pandemic situation, COVID-19 situation, a lot of people are working on vaccines, medications, right? Which people can use. So have been quite a few companies that have come together, shared information, right? So why not use a community cloud in this situation? It would let you have your common resources residing at one place. So that is what community cloud is in a nutshell. And these are what cloud deployment models are. I assume the core fundamentals when you talk about the service models and deployment models is clear to you people. Let us now go ahead and understand some other pointers. So guys, when you talk about cloud computing, there are quite a few misconceptions that people have. Let me try and get rid of those one by one. Okay. So when you talk about cloud computing myths, what people assume is cloud computing would cost you your jobs. No, in fact, I think it is the other way around. Now, when you talk about anything new that comes in the market, people are normally afraid of it, right? Popular people in the world, someone like Galileo was not let to live, right? Because he had invented something. And this has happened with quite a few popular people. So when you talk about cloud computing, people too are or were afraid, as in, since cloud computing is coming up, everything is going on cloud, would we be needed to do the work, right? So that's not true. When you talk about cloud computing, even if the data is moving on cloud, your applications are moving on cloud, you'd be needing people who can do those things on top of cloud. If not you, at least these service models would need them, right? These service providers rather. So in turn, what we've seen is there has been a huge investment in cloud computing and need for companies to actually hire people who are skilled in cloud computing. So it's the other way around. Cloud is actually creating a lot of opportunities. People who are skilled in cloud computing and quite a few other things can actually work on top of cloud platforms. Cloud is for techies alone. Now, I won't disagree with this pointer totally. Yes, for people having technical knowledge, cloud computing does help. However, let's assume I have a business, right? Hosting it on top of cloud is helping me. Why would I not do that? Do I always need to have technical acumen to do that? No. One, somebody else can do that for me, right? And help me with that. The other thing is, there are quite a few things that you can do on top of cloud where you do not need technical knowledge. So is it only for techies? No, not totally. Let's go ahead and understand other myths. So cloud computing is not safe. Okay, so having these kind of doubts is legitimate. When you have a lot of data, information critical data, you might be threatened to think whether cloud is secure or not. But if you talk about cloud computing, there are quite a few things that it offers, right? I mean, from security's perspective, all these cloud platforms have so many security measures, right from deciding who gets to access what, right from putting up firewalls, blocking your data, going into some other network. Again, having encryption, ensuring that the data that is put on your network is encrypted and decrypted at right resources, right? Having inspectors or management tools that let you keep track of all the resources that you're using. So is cloud safe or not? Well, if you say it's not safe, I might have to say that you're wrong, because these days cloud platforms ensure security at a level where even your on-premise architectures at times find it difficult to match that level of security. So are cloud platforms secure? Definitely they are very secure. Cloud is just for virtualization. Now this again is a myth. Yes, when you talk about virtualization, what you do is you create resources, or you have resources, use resources which are not actually residing on your system. Cloud computing lets you do that, but cloud computing is just not virtualization. When you say virtualization, think of it as a subset of cloud computing. There are a lot of other things that you can do using cloud computing. So guys, this was about different myths that cloud computing has to offer to us. Let us go ahead and take a look at some other pointers. So this was about the fundamentals that cloud computing has to offer to us. Let us go ahead and take a look at some of the popular cloud service providers. Who are these providers that provide cloud computing services, right? So on screen, you just see 4 names. Are these the only cloud service providers in the market? No. In recent times, there have been quite a few other platforms that have come up in picture, and they are doing fairly well. But the ones that you see on the screen, by the name itself, you might have already guessed that these are the important ones. Now, when you talk about Amazon Web Services, it is the market leader, as I've already mentioned in the introduction part. So it has the highest market share, and it is one of the most sought after skills. Very close to it is a Microsoft product called as Microsoft Azure. It too provides services just like Amazon Web Services. But since Amazon Web Services started very early compared to Microsoft Azure, Amazon Web Services has more offerings for you. Microsoft Azure again is catching up very well, but in near future there could be a situation where we see these two going neck and neck. For now, that is not the picture. And again, then you have Google Cloud Platform and IBM. Now these two are fairly good platforms and doing very good at the world level, but they also have a lot of catching up to do when you talk about the other two that you see on the screen. So these are the popular cloud service providers that are there in the market. Let us go ahead and take a look at the next topic that we have in hand. What is Amazon Web Services, or what is AWS? So let's try and understand this platform. So again, when you talk about AWS, it too is a cloud computing service provider. So the definition of cloud computing and what AWS does is pretty similar, right? It is a cloud service provider that enables you on-demand services like computation, storage, networking, and many other services which can be accessed through the internet, and the user is not required to manage and monitor these resources. So from the definition, it is pretty clear that what cloud computing is, what AWS is, right? And even the features are similar to what we discussed. Gives you secure model, gives you availability and disaster recovery, gives you pay-as-you-go model. It is highly scalable, flexible, and cost-effective. So guys, when we talk about these services, some of these services, we'll be discussing these pointers in detail there. So let's not spend too much time understanding these. To give you an overview, again, AWS is very cost-effective, pay-as-you-go model, charges you on per minute basis. It used to charge you on per hour basis, but it followed suit with Microsoft Azure, and now it is charging you on per minute basis. Highly scalable, gives you quite a few services that let you do that. Very secure, various security services that we'll see going ahead. Highly available, and disaster recovery is something that it offers as well. Okay. And it is very flexible too. So guys, let us go ahead and take a look at the next pointer. That is AWS Careers. Okay. So after Careers, we'll get into the global architecture part. That is where I'll be talking about disaster recovery and availability part. Okay. So let's try and understand Careers. When you talk about Careers, what opportunities AWS has to offer to you. So when you talk about AWS Careers, there are quite a few things that AWS or you might want to consider about. So to give you another pointers, what you see on the screen on the left hand side is a statistical data or some facts that I've actually gathered from LinkedIn. Now LinkedIn, as we all know, is a very popular professional networking site, right? It also does quite a few surveys, understanding what job trends are, what skills is the market looking for. And as you can see, when you take a look at the skills that says top 10 hard skills, cloud computing ranks second here, and it is below blockchain. Now blockchain again is a very high level topic, something that is very new in the market. Yes, it has been there for a while now as well, but it has come into prominence in recent times, and that is why it is one of the most sought after skills. Now, if you take a look at cloud computing, it has actually overtaken analytical reasoning, artificial intelligence, right? When you talk about top hard skills that hirers or employers are actually looking for. So that tells you how popular cloud computing is. And there are other graphs as well. I do not have it on my deck right now. But if you talk about the top 10 most valued skills, both Amazon Web Services and Microsoft Azure make the top 10 list. So that tells you how popular these platforms are and how popular AWS and cloud computing is, and is why it is going to stay in the market. Now, if you talk about salary again, PayScale again is a website that lets you collect data on these things. So the statistics show that an average cloud engineer salary in India is around 7 to 9 lakhs. That is when they're starting with cloud computing. With a year or two's experience, you'd be making this much money. That tells you how highly paying this job is. So again, I'm not quoting this number as a brick written value. I mean, there could be ups and downs in it. Nowadays, people have started hiring these resources from campuses as well. So as a fresher, you obviously won't be paid very high, but in a year or two's, if you have like a year or two's experience here, what that does is that gives you a very good chance of boosting your salary to a good number. And to be very frank, 7 to 9 lakhs in India, from a starter perspective, is a decent, more than decent number. Now, if you talk about numbers in US dollars, right, that is a relevant currency that many people follow. So in USDs, cloud computing is something that gives you on an average $120,000 a year. So that again is a very good amount. I mean, this is more than quite a few other high value professionals or skills that are there in the market. And if you're getting paid more than them, that tells you how popular cloud computing is getting, and you're secure when you talk about having a career in this domain. This salary can go as high as $250,000 as well, right? So that tells you it depends upon the skills that you have and how good you implement. And if you do that, you'll be getting a career in cloud computing and AWS in particular. Okay. So let's try and understand what are the career opportunities when you talk about Amazon Web Services. The numbers are out of the way. The stats are out of the way. What are the roles that you can achieve when you talk about AWS? So when you talk about cloud computing and AWS in particular, the amount of job roles or possibilities that you can actually chase is huge. I mean, you can be a developer, you can be an admin, you can be a marketing person, you can be an ML engineer, you can be a data engineer, right? A networking specialist, a security specialist. All of you have a career here when you talk about cloud computing. It's just that you need relevant amount of experience. But the problem with this approach is you are never certain, right? I mean, how should I pursue? What background should I have to get into these roles? Now, there have been quite a few surveys that I've been involved in, and there have been a lot of data that I've come across And people normally ask me these questions. Normally I have my sessions as well where people ask me this question. What role should I opt for? What preparation should I do, right? I have this background. Can I make a career here? I have this background. Can I get into this domain? So the reason people have this confusion is there could be a possibility that a lot of people are working somewhere and they do not know what role meets their needs best. To solve this problem, what Amazon Web Services has done is they've introduced role-based certification. That means they have classified some important roles, and for that they have their certifications, and accordingly your certification would be graded and the curriculum for that certification would be in that role, so that you have a clearer picture as in what role should you opt for. Let us go ahead and understand these role-based certifications. To keep it simple, guys, when you talk about cloud computing, you can be a cloud architect, a cloud developer, or an admin. These are the most preferred roles. Let's try and understand these roles one by one. Once we've understood them, then we'll go ahead and understand the AWS certifications that are there. Okay. So when you talk about application building, right, there are major things that you do. First one is you need to know what application you're trying to build. You need to have a blueprint of your application. So when you build a house, you have an architect, right, who designs your house for you. When you talk about a cloud platform, when you're trying to host applications, you would be needing somebody who knows how to build or design these applications, how to design these migrations, right? There could be a possibility that I have my application which resides somewhere else and I want to move it to cloud. Right? So there should be an architect who knows whether it is feasible or not. If yes, how should you bring this through? So people who create these cloud architecture blueprints are called as cloud architects. What do they have to know? It is important they have understanding of the cloud platform that they're working on or they would be using. They should be having knowledge about multi-tier architectures, how they work, what all can you do with these architectures, right? And you should also be knowledgeable enough to have understanding of your platform very well, because if you move something there, you should know how to monitor, manage and set up those infrastructures there. Then you would be involved in cost control strategies as well. You should be able to take calls. What would be the easiest or cheapest way for you to move your application to cloud at an optimal budget or optimal value, right? So this is what an architect does in general. He designs or creates blueprints of your architectures. Now that I have the blueprint, the next thing is I need to build an application, right? So who builds these applications? These are cloud architects. What does a cloud architect do? Or sorry, cloud developers. Forgive me for that. So these are your cloud developers who build your application. So as the name suggests, these people are involved in developing your cloud applications. What do they have to know? They should be skilled in programming language, at least one. So they should have an understanding of how to code for a particular application, how to build it from scratch. They need to have understanding of SDLC, that is software development lifecycle. If you do not know how to build an application, what processes it goes through, even on top of cloud, you would be struggling. You should have in detail understanding of how DevOps works. Now DevOps is an approach where basically developers and operations team come together and they integrate the process of building an application, testing it and deploying it. So you need to have an understanding of DevOps practices as well. So these were about 3 popular cloud roles. So what these certifications or what these cloud platforms have done is they've actually gone ahead and put forth their certifications in these 3 major roles. So we've discussed only 2 till time. I'm sorry for that. We've discussed our architect role. We've discussed our developer role. Let us go ahead and understand the admin role as well. So when you say the admin role, basically these are the people who are responsible for configuring, managing and monitoring your cloud solutions. That means these are the people who basically act as an admin on your cloud platform. So their job is to ensure that your application is up and running and there are no problems with it. So they are mostly involved in the monitoring process here. So they should have knowledge as an admin, what an administrator has to do. They should understand system operations and virtualization because they are also involved in these activities. Again, since we are moving our applications from an on-premise infrastructure to cloud, there could be a possibility of that as well. So in that case, as an admin too, you need to understand how migration and monitoring of resources works. So this was about the cloud admin role. Let us go ahead and take a look at the popular AWS certifications that AWS offers to you. So as I've just mentioned, they have classified the certifications into more role-based approach. So in this role-based approach, what happens is basically you have three major certifications that we've discussed. You can be a developer, you can be an architect, or even an admin, right? So you can see that on the screen. These two certifications are given in stepping stones format. What do I mean by a stepping stone format? So basically, firstly, you'd be needing to have some understanding of cloud computing. So when you take a certification, you need to prove that you have that acumen, that knowledge. For that, you need to take your cloud practitioner certification. 6 months of fundamental knowledge of AWS and cloud computing should be good enough for you to actually go ahead and take this exam. Okay. Now let's assume that you are a practitioner. You've been working in the cloud domain. You worked there for a year. You know AWS. You can opt for the first level certifications, the associate level certifications. Here you can pursue your associate level certification in solutions architect role offered by AWS, AWS certified SysOps administrator, or the admin role, operations role. You have the developer role called as AWS certified DevOps or developer role when you talk about an associate level certification. Now, let's assume that you have you have the certification, the associate level, and you want to advance further. So with a couple more years of experience, you can actually go ahead and opt for your specialty certifications or professional certifications. So when you say your professional certification, for architect, the easiest path or the closest path is being solutions architect professional. So here you'll be tested on your advanced skills when you talk about solution architecting. Okay. For system administrators and developers, the role merges into one common professional level certification. It's called as your DevOps engineer certification, right? So guys, these are the role-based certifications that AWS has to offer to you. But are these the only certifications that you need to look into? These days, people are in need of having certifications in other domains as well, right? You'd want to have some specialty which you want to pursue. Let's assume that you are more into Alexa skill building, right? In that case, you can opt for Alexa skill builder certification. Let's assume that you are into data analytics. So there's a certification for data analytics, which lets you master in all the data analysis and machine learning services like AWS has to offer to you. Those services can be your AWS machine learning, Amazon Poly, and a number of other services that are there in the market. Next, you have your AWS Advanced Networking certification, where you can have a specialty in the networking domain. Similarly, you have your security services, right? Or security certification. You have your database specialty certification as well. So guys, these are some of the certifications that are there in the market, okay, that AWS has to offer to you. If you talk about it from the popularity perspective, Amazon Web Services Solutions Architect certifications are the most in demand certifications. But again, what do you want to pursue and what skills do you have? You can choose one for your needs. Do you need a background to prepare for these certifications? If you want to be a developer, having knowledge of programming language will help. As an admin, you should have understanding of what administrators do. Solutions architect is one of the roles where you do not have to have knowledge of programming or stuff like that. But networking fundamentals, Linux fundamentals, these are very common. Understanding Bash and all those things. So when I started with cloud computing, I realized that if I had knowledge about Linux and Bash right from the start, I would have been much better positioned to understand cloud computing on top of AWS. So make sure that you learn these little things at least on day-to-day know-how basis. And then you can actually go ahead and chase these certifications. Spend like 3 to 4 months preparing for them, and you should be good enough to actually go ahead and crack one of these. If you might have questions like pricing, the regions where I can take these exams, the currency in which I pay the amounts. Well, to answer some of your questions, this certification costs you around $160. It's valid for 2 years. With AWS, you have quite a few options. when it comes to doing payment and all those things. To refer or to get to know more about these things, do visit the AWS official page, and you'll be having more information on these pointers. So till this point, we have been talking about cloud computing careers, and we've discussed different AWS certifications that Amazon Web Services offers to us. So we've discussed what role-based certifications are and what are the specialty certifications. Let us now go ahead and understand some concepts, or let us try and understand AWS conceptually a little. So the next topic of discussion that we have on our plate is AWS global infrastructure. Now, when we talk about Amazon Web Services, we know that it is the global leader when we talk about the public cloud market, and it is evident from the infrastructure it has. To talk about the numbers, it serves in more than 240 plus countries. So that tells you about the reach of Amazon Web Services when you talk about its infrastructure. So let us go ahead and explore this infrastructure a little more. Let us try and understand how does AWS provide its services in different regions. So if we are to talk about AWS and its global infrastructure, there are few terms that we need to understand. Those are AWS regions and availability zones. And there's third term that we need to understand, that is local zones. But it is a minimal part that we need to understand out of local zones. So we'd be specifically focusing on what regions are, what availability zones are, okay, and also local zones to some extent. So let us try and understand this global infrastructure that Amazon Web Services has to offer to us, or to everyone who wants to use this cloud platform. So already, as I've mentioned, that it is one of the global leaders, right? And we've already discussed what cloud computing is. So it is nothing but an offering which is available on demand, and it can be accessed through your laptop using internet, right? So you're residing in a particular part of the world, you can actually access these resources by sitting in that part of the region, right? So this is possible because AWS has its data centers in different locations of the world. Okay. So, since it has its data centers in different locations, it can actually reach out to people that are based in those regions. Okay. So talking about its infrastructure globally. So as I've already mentioned, it serves in more than 240 plus countries, right? Let me give you a quick sneak peek into what AWS has to offer to us from the global infrastructure perspective. So if we are to look into global infrastructure of AWS, now this website or this page will give you quite a few numbers, right? So as you can see, there are like 24 launched regions where AWS operates. So, and in those 24 regions, there are 3 more that have been announced. That means it would extend its reach to like 3 more new regions. And it has 76 availability zones. Now do not worry, I'll give you the exact difference between what a region is, what availability zones are, but just take a look at these numbers, right? 216 points of presence. So as you can see, this tells you that where AWS resources are serving, what are the different regions where it has its data centers, right? So there was this interesting slide, I cannot find it somewhere, where you had all the details about the different countries where AWS serves. But if I'm not wrong, it is like 240 plus countries. Here you see on the screen, it is there. It says like 245 countries and territories where AWS provides its services. So these are the countries where it's active, and you can actually access AWS resources from there. Okay. So we've taken a look at certain numbers, right? So if I go back to my presentation, I had availability zones and regions there, right? So let me use this slide only, or the screen only, to talk about those pointers. Let's try and understand what regions are, what availability zones are, right? So when you talk about regions, so these are geographical regions where AWS has its data centers. To give you an example, now since I'm based in India, let me give you an example from India. In India, we have a region in Mumbai. Mumbai is a city in Maharashtra, India. Okay. So if I scroll down, you can see the active regions here. So this is the map, and this is where India is located. So you can see that there's a region in Mumbai, and there are 3 availability zones. We would understand what availability zones are. Do not worry about that. But sticking to the region thing. So region Mumbai is one region where its data centers are located, right? Now there are other regions here as well. Bahrain is one, right? If I come here, you can see that this is the government cloud. Let's not talk about that. Canada Central has a region, right? Ohio is one. So Oregon is one. Then if you come here, again, this is the government cloud. So specifically to serve government authorities, these clouds are meant for that. Northern California, you have one. Sao Paulo, right? So these are different regions. Now these can be states or these can be cities. That depends how the nomenclature in those countries work, right? In India, say for example, Mumbai is a big city, right? So we have like a region here in Mumbai where the data centers of AWS or Amazon Web Services exist. So when I say an AWS region, think of it as a geographical region. But since it is the place where you have AWS data centers based, they call it as an AWS region where you have proper data centers located. Data centers are places where you can put forth your data, right? These are the data centers where all your cloud applications would reside or rest. So when I say a region, the reason we can actually put our data here is it is so diversely located, right? Now let's assume that I have my business that is working in USA. So it would be wiser for me to host my applications in a data center that is in USA. Why? One of the reasons could be because probably I'm trying to cater the audience that is there in USA, right? Now let's assume that my business is doing well. Even though I'm based in India, my business is doing well in USA. And now people in India are also trying to get access to all the resources that are there or whatever I'm trying to do there, right? In India, people also want those things to work for them. So they are accessing all the resources that are based in the data center that is located in USA, right? For them, it's just a website or an application, something that is accessible from different parts of the world. Okay, so the point that I was trying to make here is, let's assume that the business is based in USA, okay? But now there's demand for the business in India as well, and people are trying to access those resources from India. But since the data center is based in USA, it could be an issue where people are facing latency, right, for accessing this data. In that case, you can have your data replicated in Indian data center as well, so that the audience in India can actually access that data quicker. So this is what the benefit cloud gives you. Since the data centers are located in different parts of the world, you can actually be residing in one part of the world and make sure that your resources lie in another region or wherever your business is working. So this is the benefit of global infrastructure that AWS has to offer to you. So this was one part about the regions. Region is nothing but a geographical location where the data center of AWS exists. To explain this further, let's try and understand availability zones. What are those? Now, as you can see on my screen, if I click on Mumbai region, I see that there are 3 availability zones. So what does this imply? Now, when I talk about an availability zone, it is nothing but a data center that is located in that particular region. With AWS, you can have multiple data centers in one region. Each of this data center is called as availability zone. Now, in this case, Mumbai has 3 availability zones. Okay, so what this does is this gives the businesses freedom to actually go ahead and replicate their data in different availability zones. So this is an intra-region replication of data. That means multiple data centers in Mumbai or any other region that I choose which has multiple availability zones. You can actually replicate your data from in more than one availability zone. So what that means is if one of my data center goes down, my data would be available in the other region, in the other availability zone as well. So now these availability zones are normally located at a safer distance. If I'm not wrong, it's like 25 to 60 kilometers is the difference between these availability zones. So that means if one of the availability zones has a problem, there is a high chance that the other availability zone is still functioning smoothly. So you can actually have a replication of your data in the other region. What this also ensures is, let's assume that my data is located like 60 kilometers away from each other in a replicated format. That would mean if one of the availability zones in Mumbai goes down, the other would be available, right? And there's a high possibility that it is up and functioning. So if the users are trying to access data and if one of the regions is down, the other region that is close to it would be quickly available and there would be very less latency here. So you are saving your time, right? And efforts as well. Now, to give you another example, let's assume that this availability zone concept is not very suitable for you. You assume that that 60-kilometer distance is not enough, right? You might say that what if a city like Mumbai experiences an earthquake, tsunami, right? Since it is located close to the sea. Let's assume it experiences tsunami or earthquake. So in that case, there's a high possibility that I might lose out my data on both the availability zones. In that case, AWS gives you freedom to replicate your data in different regions as well. So you can have inter-region replication of data. Say for example, you might replicate your data in Mumbai. There's one copy here and the other one could be here in Bahrain, right? So now since these are located these are very far from each other, both places experiencing same calamity is a very different case or very rare possibility. Something like Corona is something that is spreading worldwide, but I don't think that is affecting data centers in any way. So that is why mostly these data centers are located at a location which are at a safer distance, and your data would always be safe, right? So this is what availability zones enable. These are multiple data centers, or a data center is called as availability zone. And what this means is your data would be always available on these data centers. And if you replicate them, you can always disaster recover your data, whatever is gone in one of the regions, right? So this is what the aim of this global infrastructure is, to ensure that whatever data that we replicate at different places, it is safe. And you always have replicated copies of your data to ensure that you do not lose out on important data or information, right? So this was about availability zones. Now there's one more thing, right? Since you are trying to replicate your data, you are trying to move your data from one region to the other. If your data is located in two different regions which are very far away from each other, or let's assume that you want to move your data from one region to the other, which is located at a greater distance. So in that case, replicating your data would be a difficult task. The other thing would be communicating through a network would also be a challenging task because the distance is too much, right? In that case, you have local zones that are located between these two regions, and your data migration becomes easier. Your data movement becomes easier. Okay. So that is why local zones are meant for, or that is what local zones are meant for. Now, what do you need to understand here? Let me put forth another example. Now, since we are talking about global infrastructure, global regions, right? Let me discuss the problems that we normally face and the issues that are there. Let me also compare it with other cloud platforms as well, because we can then end this discussion of availability, data caching, data replication in this bit only. Okay. So there's another important point that I wanted to talk about. That is, when you talk about AWS, now in one single region, you have multiple availability zones. But if you talk about Microsoft Azure, for a very long time, now Microsoft Azure again is a cloud platform. We've discussed that. So when you talk about its global infrastructure, for a very long time, they did not have the concept of availability zones. Now they have, but in limited regions only. So what that meant was, it only had regions where each region had data centers located in it, right? So since there were not multiple availability zones in one region, that meant you could not replicate that data in the same region. You could, but there was no point of doing that because you had only one data center there. But what that also meant was, since there was only one region with one data center, what Azure did was, it also had quite a few regions in a particular country as well. Say for example, in India, Microsoft Azure has 3 regions. One is in Mumbai, one is in Pune, and the other one, if I'm not wrong, is in Goa. Okay. So now these places are located like 200-300 kilometers away from each other. So there is one benefit in this approach, that in case if one of the city experiences this natural calamity, you still have regions that are there in the same country. Now, when you talk about putting forth your data on these data centers, some countries may have different rules, right? The government have different security and data rules. Every country has those. So, if we had like multiple regions in one single country, similar laws would adhere for those data centers. And the replication of data would make a lot more sense for you because you would be staying close to your data, but yet far enough to ensure that these are safe from natural calamities or downtimes. So that was one advantage of Azure cloud, right? When you talk about its global infrastructure. But there were some limitations there as well. Let's not discuss that. But the point that I want to make here is the global infrastructures for both these platforms vary a little. And there are these pluses or minuses when you compare them with each other. Okay. So coming back to the AWS infrastructure, we've discussed what availability zones are, we've discussed what regions, and we've also discussed what local zones are, right? Now I mentioned, or I put forth a point saying that I can have a business that works in different parts of the world, right? There is still one issue in it, right? Let's assume that my data center now is based in India. I have a lot of audience that is in India. And soon my business gets popular in some other part of the world. Let's assume USA. Now in US, there are a lot of people who are accessing my data. So do I just go ahead and replicate all my data in some other region like US in this case? Not always. And the reason I would actually want to replicate my data in first place is because I want to avoid latency of data reaching to people in USA, right? So instead of actually going ahead and just replicating all my data in USA, what I can do is I can actually have something called as an edge location. Let me tell you what an edge location is. With AWS, you have the freedom of caching your data. Say for example, in US, there is a set of audience that accesses particular kind of data a lot more. So in this situation, what I would want is I would want that set of data that is being accessed by a lot of people in a particular region to be cached at a location that is close to USA so that there is lesser latency there. So this is something that can be achieved with AWS. You can actually have an edge location that is close to a particular set of audience where you replicate certain amount of data or cache certain amount of data rather so that it can be accessed quickly. For this, we normally have content delivery networks. AWS has a service called as AWS Cloudfront that lets you create AWS Cloudfront distributions that basically act as your content delivery networks, right? And you can actually cache your data to get or to perform all these things that I've just mentioned. So guys, this is how the infrastructure when you talk about AWS works like, right? This is how it looks like in general. So I believe by now it is clearer to you people, right? What regions are, right? What availability zones are. Now the ones you see on the screen in the orange color, right? So these are the ones that are yet to come. So you can see that Spain, it says coming soon, Jakarta coming soon, and Osaka coming soon. So guys, these are the regions where these data centers are yet to come. So we've discussed this, right? When I scrolled up, here you can see if I scroll up, there are 3 regions that have been announced. So these would be launched actually. So these are some of the data sets or information that you would want to take a look at. Do visit this website and try to understand these pointers a little more. But when you talk about the global infrastructure, these are some of the core pointers I feel you all should know or have some understanding about, right? So this is what the global infrastructure of AWS looks like. It ensures that your data is always available, gives you options for disaster recovery as well, and always lets you access your data from different parts of the world. So let us just go back to the presentation and continue with our discussion that we were having, right? Okay, so let's just go ahead and understand some other pointers now. I've already talked about these, but to give you an upper level summary, Amazon Web Services has AWS regions, and inside those regions, you'll be having data centers called as your availability zones, which are connected by low latency networks. That means your data moves quicker between these availability zones. If you are to move your data out of an AWS region to other region, as I've already mentioned, you have to connect it through a local zone for a speedy transfer of your data or migration of your data, right? So this is what AWS regions or availability zones look like. And this is what the global infrastructure of AWS is. Let us now go ahead and understand some of the core domains or core services that AWS has to offer to us. Okay. So there are quite a few services. Let's quickly take a look at some of the domains that are there and the services that fall under it. Okay. So talking about the AWS Core Services, as I've already mentioned, there are like 200 plus AWS services that AWS has to offer to us, right? So this number keeps on growing actually. So I'm actually not aware what the exact number is, but if I'm not wrong, it's around 200 services that AWS offers. So to actually name all of these services individually or to have them as individual services, it is a complex process, right? I mean, there has to be some clustering, some grouping of these services for clear management or better understanding. So when you talk about AWS, what it does is it classifies its services under certain domains. Now, these service domains are many. If you talk about the core domains, you have your computation, you have your storage, you have your networking, security, management, messaging, databases. Now, these are some of the core services. When you talk about cloud computing certifications or the roles that we discussed, every certification or every role would want you to know what computation is, what storage is, what database services are, what networking is, what security is, and what messaging are. Because these form fundamentals of your architecting and SysOps admin roles. Now, there are developer tools as well, but those are specific to developer rules, right? Or roles. So I will discuss that. Do not worry about that. But as I've mentioned, there are quite a few domains as well. Some of those are not even mentioned, or you cannot even see those on the screen right now. I've captured some major ones that I felt were important actually. But again, each day there are so many services that get launched and there are so many services AWS offers. The definition of something being important is very surface level here. And this is more from my perspective. So, because for you, machine learning services might be more important, right? For some of you, only the developer tools might be important. Say, for example, AWS DevOps services, or for some of you, IoT services might be important. So that is a perspective based response to it. So when you talk about the core domains, these are some of the ones that are most discussed, and these are the ones that you see in the certification courses that people offer across the globe. But I would try and shed light on as many services as possible. The point that I'm trying to make here is when you cluster these services, you get some of these domains which offer different kind of services. So let us try and discuss the ones that are there on the screen first. And as we move further, we'll be talking about other services as well. So do not worry about that. Okay. Now, when you talk about the service domains, first one that we see on the screen is compute. Now, compute again is a popular cloud service domain. In this service domain, you have quite a few popular services like EC2 Elastic Cloud Compute or Elastic Compute Cloud, which again is a popular computation service and is IaaS in nature. That is infrastructure as a service. So we've already discussed what infrastructure as a service is, but when you talk about compute service like EC2, it offers AMIs and instances or VMs. We'll be talking about that service at length and in detail as we get into the demo part. But these are the services, or this is one of the services that compute domain offers. Now, these are the services that let you do computation on cloud platforms, right? So this could be your infra VM that you launch. It could be a service like AWS Lambda, which is serverless in nature, right? Which takes care of a lot of activities that you otherwise would be involved in. Or it can be your EBS or Elastic Beanstalk service. So when you talk about Elastic Beanstalk service, it is platform as a service, compute service that AWS has to offer to you. So it provides you with a platform where you can do a lot of computations. So basically, when you talk about compute services, they help you in the computation part of your data and resources that reside on your cloud platform. Next is your storage domain. Now, when you talk about the storage domain, as the name suggests, this is where you actually go ahead and store your data, right? So there are services that let you store data in form of objects, in form of files, structured, unstructured data and stuff like that, right? So AWS has quite a few services which take care of even your hot storage, cold storage. Now, some of the terminologies that I'm mentioning, I'll go ahead and discuss those in detail. But yes, when you talk about storage services as well, so AWS gives you quite a few storage services, right from your object, file, structured, unstructured data to even hot and cold kind of storages, or even your archival storage. When you talk about a cold storage, it is called as archival storage, or data that you do not access frequently. Okay. So apart from that, there are your database domains where you have your database services. Like now there are plethora of services here, to be frank. You have your Amazon RDS, right? Then you have your Amazon Redshift. These services are popularly known for providing you different types of database instances where you can store different kinds of data and have different benefits. So there are very few databases out there in the market. Those are not supported by AWS, to be frank. Then you have other popular database services as well, like Aurora and quite a few others. So even these services are something that we'll discuss as we move ahead. But for now, this is what your database services do. they actually let you go ahead and have database services launched in your AWS cloud platform. The next bit in this session, or the next bit in these services that we have, are your networking domains or networking domain services basically. So when we talk about the networking domain, right, I mean, when you talk about cloud platforms in particular, networking is very important, right? Because all our data is residing over a network in different data centers. It is connected through a network. So having a network that connects these things properly is very important, which also governs the security of the network is also important. So there are quite a few networking services that help you connect your cloud, your data centers and networks or your data with each other using these networking services. Okay. So to name one of those, we have VPC that Amazon has to offer to us, that is virtual private cloud. It lets you have your subnets or virtual subnets rather, or virtual networks that you need to govern your data over the cloud network. Next, you have your security domain. Now, there's a lot being said about data being secure or not being secure on cloud platforms, right? Now, if you talk about the security services that AWS has to offer to you, the number is plenty. I mean, you have services that let you do so much when you talk about security, right? Right from ensuring that your data is secure over the network, right? Deciding who gets to access what, giving you proper access management, then ensuring that you have encryption of your data that moves over the network, and firewalls to ensure that whatever comes into your network or goes out of your network is secure. Then you have your security managers that actually act as inspectors on these networks. They keep a track of the health of a network that is functioning, your services, to ensure that those are healthy and those are functioning normally. Okay. Apart from that, it gives you suggestions on what security principles should be implemented that are cost effective and secure as well. This was about the network security that I've mentioned. When you talk about platforms like AWS, they have 24/7 working personnel that physically guards your data centers, right? And there is a layer of security that ensures that your data is secure physically as well. Apart from that, when you talk about these regions are so profound, so unknown or so secretly kept that even quite a few people who work at Amazon do not know where these data centers are exactly located in those regions, to ensure that the security of these regions is at a very high level. So when you talk about security, there are quite a few services that ensure your data is secure. Okay. Migration. Yes. So when you talk about migration, it is not always that you're just going to go ahead and start a new application on cloud, right? There could be a situation where your data is already residing somewhere. You need to move it to cloud. So does that mean that cloud won't help you here? It would definitely help you here. So what cloud does is it ensures that there are quite a few services that readily amalgamate with its platform, so you can directly migrate to cloud. If not, it also helps you in ensuring that your data can be moved to cloud. You have relevant resources that support your migration. And most importantly, it follows quite a few principles that not only help you in moving your data, but even reshaping or modeling your data and applications in such a way that they can actually reshaped or even rebuilt on top of cloud platforms. So migration is something that AWS supports a lot, and there are quite a few services that let you do this. Now, this is something that I doubt we'll be discussing in this session, because this is a very detailed topic, and to be frank, there are complete courses that talk about migration. But I'll give you some idea about it. Do not worry about that. Next in this list, we have management tools, right? So once the data is there on your cloud platforms, you need to do quite a few things, right? There are management tools that let you throw in triggers, that let you throw in thresholds or alarms when there is a particular threshold breach that is that has happened. Or if you want to keep a track of the health of the resources, this is something your management tools do for you. So they manage all the data and resources that are there on a cloud platform, right from keeping a track of your pipelines to throwing in alarms when a certain requirement is met or not met. Everything is taken care by your management tools or management services that AWS has to offer to you. When you talk about messaging, now again, you need to communicate over the network, right? Even though you have security, you need services that can help you pass messages, emails, right? Communicate with different users and stuff like that. So there are n number of messaging services that AWS has to offer to you. Those fall under this domain. And then you see the analytics domain here. Now, the reason I have put forth this name here is everybody talks about machine learning, data science, and then people ask me questions as in, can you do that on top of cloud platforms like AWS? Definitely you can do that on top of platforms like AWS. AWS has a plethora of machine learning, big data analytics services. Whether you talk about cognitive services that let you use AI, NLP, if you want to use ready to use APIs, even those applications or APIs are available that let you do face detection, image detection, sentiment analysis, fraud detection, quite a few other things. Okay. Text to speech, speech to text, right? These kind of applications as well. If you talk about core analytics, like running machine learning models, building machine learning models, then you have services like Amazon SageMaker that let you do this at length and in detail. Okay. Apart from that, there are quite a few services that let you perform big data operations, ETL operations, and data warehousing operations as well. So whether you talk about big data, AI, machine learning, everything is taken care by AWS. Now, these are some of the domains that you see on screen. Are there domains that are not there on the screen? Yes, there are quite a few domains that are actually not there on the screen. So if I were to talk about other domains or other services that AWS has to offer to you, there are domains like IoT, Internet of Things, right? Internet of Things is nothing but a practice where devices are connected to each other through the internet, and over the internet, we collect the data from these devices through sensors. Now, this data is something that can let you actually, one, operate these devices and also generate insights from the data that we get from here, making those devices smarter. So that is what the aim of IoT is, right? Say, for example, smart signals that we have, right? Smart home devices or appliances. Now, some of these work on Internet of Things, right? So since Internet of Things is a big thing these days, AWS has made room for it as well. Now, this was about IoT. For IoT, you have like services that give you administrative devices with AWS that are like AWS IoT Core and other services, which actually let you connect your IoT devices to AWS Cloud Platform with ease. There are other services like IoT Greengrass and quite a few other services that AWS has to offer to us. But that is not the point of discussion. I just want to tell you that IoT is something that is supported by AWS. That is one of the domains. Then the other domains can be your DevOps domain, right? When you talk about the DevOps domain, these are the developer tools, right? What is DevOps? DevOps is an approach where we break silos between developers and administrators. Now, these are the two teams that are involved in software development process. So the developers build it in a developer environment, whereas the operations team or the administrative team operates on this software in the production environment. Two different environments altogether. But when you talk about them, they have to work together because they are connected with each other in the form of the software that was built. So in previous days or in the agile method or the methods that were before that, we had problems where these two teams had quite a few conflicts because what worked in development environment did not work in production environment and vice versa. And both these teams believed that it was the fault of the other team. So what happened was we had a newer approach called as DevOps that actually combined these two teams to work together, and they generated a continuous integration and deployment kind of a process where you could work together and build software at a better and a faster pace. All the patches could be fixed in quickly and everything could be done at a quicker pace and at a continuous pace. So this is what DevOps brought into picture when you talk about software development, something that has revolutionized software development. There would be quite a few people who are attending this session, and they know about DevOps, right? So they can relate to these things. So basically that is what DevOps does, and it is very popular in the market. So AWS has also provided quite a few services like AWS Cloudpipeline, AWS Codecommit, which is similar to Git, right? You have AWS Code Build Services, you have AWS Codecommit, Codedeploy, right? And a Codepipeline as well. So these are the services that actually let you perform DevOps operations. And right from writing a code to committing it, to deploying it, to building it, everything is taken care here on this AWS cloud platform. So when you talk about the domains and services that AWS has to offer to you, the possibilities are many. Once we get into the console, I would show you some of those services. Not worry about that. But this is about the core service domains that AWS has to offer to you. I believe I've talked enough about them. Quite a lot actually. So let us just go ahead and take a look at one of the first domains that comes under AWS, and let's try and explore that a little more. Okay, so my presentation says that we should first take a look at the free tier account or the AWS console that it has to offer. Okay, so let's do that. Let's quickly take a look at the AWS free tier console. Right, let me give you some information on these pointers and then we'll go ahead and talk about some of the services that AWS has to offer to us. So again, let me switch into my tab, right? I'll have to log in or sign into my console here. Let's do that. Should not be difficult. I have an account here. I had a session a couple of days back for great learning. In that session, my account just refused to start. So I had to change my password and stuff. So I assume that it would be up and functioning now. Oh, I feel so relaxed. It is working. Okay, so this is a demo account that I have. I use for quite a few activities, mostly for demonstrations. So let's quickly take a look at this account. So guys, this is what the free tier account of Amazon Web Services looks like. So when I say a free tier account, it offers quite a few features that are available to users free of cost. This is for learning purposes right now. AWS, since it's a global platform, it wants more and more people to use its platform, its services, right? So what it does is it gives you a free tier account that is valid for 1 year. And for this 1 year, you have most of the services that AWS has to offer to you available to you free of cost with some upper caps. That means all these resources will have a certain limit on it. Say for example, EC2 is a compute service. So you can launch virtual machines here. With AWS, what it does is it gives you the ability to launch basic instances that you can launch at free of cost. If you want to launch bigger instances, then you might be charged. Okay. So this is what a free tier limit is. Say for example, S3 is a storage service where you can store data up to 5 GB. If you exceed that, you'll be charged. So that is what a free tier cap is. Now, for people who want to start practicing AWS, these resources are more than enough. You can do a lot of things with these resources, right? So if you do not have an account, make sure you go ahead and have one. How do you create an account? You just have to search for AWS free tier. Okay. Once you search for AWS free tier, you would be having access to or you'll have to sign up to AWS free tier. You'll have to give in your details like basic details. What your name is, email ID, where you reside, your address, and you would be actually expected to give in your credit card details. So the reason they ask you for credit card details is they want to verify you are a legit user. And in case if you cross the limits and you have to pay the amount above the cap that you crossed, that would be deducted from your credit card. But it does not debit your money without asking you. It will ask for it, and if you approve, only then it will charge you. If it is a free tier account, you can even put in your debit card details. It says you have to give in your credit card details, but with AWS, I've tried using my debit card and it works as well. So they cannot charge you without your permission. So do ensure you have a free tier account and you start practicing AWS just like, or whatever I'll be talking about in this session as well, so that you can at least get started with this platform if you haven't. Okay. So this was about how do you get started. Let's take a look at the services it offers. Now for that, if I click on the services option, you see all the major domains you have, right? We've discussed some of these. Say for example, your compute domain, right? In your compute domain, you have these services. Some of them I've already mentioned. We'll be discussing these, do not worry. Analytics, right? Quite a few services like Athena, EMR, Cloud Search, Elasticsearch service, sorry. Kinesis, QuickSight. QuickSight is your BI service, just like your Tableau or Power BI that you have, right? It lets you visualize your data. Data pipeline, data exchange, Blue, Lake Formation, MSK. Then if you go into the machine learning part, you have specific machine learning services as well. We'll take a look at it, not worry. But for now, let me just scroll up and see what are the other services that I wanted to talk about. Business applications, Alexa for business, Amazon Chime, Workmail. I haven't used these to be frank, but these are useful services. Storage, in storage, you have S3, EFS. Now this is your object storage. This is your file storage, archival storage. Storage gateway is something that lets you connect different storages in different regions, right? Now you have your management services. I've mentioned there quite a few actually. Organizations, Cloudwatch, autoscaling, formation, trail, config. So these are important services. You can study these as well. Security, you have your IAM, right? Secrets Manager, Guard Duty. There are other services as well. We'll discuss this. WAF and Shield are something that are very popular. Internet of Things. Now the services that I mentioned, right? IoT Core, free RTOS. You also have your green grass that I mentioned. IoT one click that lets you do quite a few things just at a click, as the name suggests. Okay. Databases, you have popular database services like RDS, DynamoDB, ElastiCache. DynamoDB is something that is your, it is similar to CosmoDB that Azure has to offer to you. Let's not talk about that for now. It will divert us. And then you have your DocumentDB as well. Redshift is one that lets you connect to or basically take care of your unstructured databases as well. Okay. So if I scroll down, there are networking services here. You have your machine learning services. SageMaker is something that lets you have or use ready to use notebooks, Python notebooks that it offers. It lets you build a machine learning solution end to end, right from writing codes to actually going ahead and deploying that. So it is an end to end solution, right? Augmented AI. So this and Comprehend. These are some of the AI services, right? Comprehend in particular is more of an API or an application service, which is ready to use application. You put in your data and get information. It lets you do sentiment analysis, to be frank. Okay. So then you have Amazon Lex, which lets you build chatbots that can actually be integrated with different platforms as well. And this lets you do it with a lot of ease. Okay. Amazon Poly is one of your speech synthesizers. So this is more of a text to speech kind of a thing. You enter a text and it converts it to speech. Okay. So, and its logo is of a parrot. So that tells you, right? It speaks what you tell it to speak, right? So Transcribe is more of into these translation things. So there are quite a few services that are there. You might want to come here and take a look at those one by one. This is about the console that AWS has to offer to you. You can actually go ahead and click on these right away. Or if you do not see one of these, you can just type its name. If I type S3, it will show Amazon S3 service to me. I can click on it and I'll be taken to that particular thing. What you see here is the region part. You can choose what region do you want to create your resources as well. Okay. So you have options here. You can choose different regions. You can see the names of the regions that are here. Okay. Again, if you scroll down, there are some of the tutorials as well that you can actually go ahead and use to get started with some of the things that you would want to do. Even the time is given how long it would take for you to do all these things, right? 6 minutes for you to build a web app, 2 to 3 minutes for you to launch an instance. We'll launch an instance shortly. Do not worry about that. So when you talk about AWS, it gives you quite a few options, and this is how the console looks like. So guys, let us go back and take a look at the first set of domain that we wanted to discuss, and then we can come back for the demo part again, right? So let's do that. Okay, so what is the first domain that we have in our hands? What is the first domain that we have on our plate, right? So when you talk about this domain, it is AWS Computation Service, right? Or Compute Services rather. So when you talk about these compute services, it has quite a few compute services that AWS has to offer to you, or AWS has quite a few compute services it would like to offer to you. One of those, or the first ones that you see on the screen, is Amazon Elastic Beanstalk. So Amazon Elastic Beanstalk is one of those services which actually lets you go ahead and have or use PaaS offerings that AWS has to offer to you. Okay. So when I say PaaS offerings, here basically a complete platform is made available to you, which you can access, which you can use using AWS. Say for example, I have an application that is up and ready for me. I just need to move my code to AWS and start working on it, right? Let's assume that that application is built in Python. So in this case, what I would do is I can actually go ahead and launch an instance. So instead of launching an instance and setting it up, launching a virtual machine and setting it up, configuring it totally. Okay. What I can do with Elastic Beanstalk is I can actually just go ahead and fire up one of the environments that Elastic Beanstalk has to offer to me. And here the environment is ready made for me. All I have to do is put my code and my application will start working for me. The other approach, what it also does is it gives me an environment where I can actually start coding as well. Let's assume that I'm good with Python and I know how to build an application in Python. So it will actually go ahead and create a virtual machine for me. It would create an environment on top of it, and I can actually just go ahead and fire up that environment and just start writing my Python code. And my application would be up and ready for deployment. It also lets you deploy your application with a lot more ease, gives you complete status in what stage is your application in, what stage of deployment it is in exactly. And using that, I can actually go ahead and deploy my AWS Elastic Beanstalk application. So we've already discussed what platform as a services are. So you can see on the screen on the left hand side, there's a small image that tells you it's a PaaS offering. That means my vendor takes care of everything right from networking to runtime. Whether it's my middleware, operating system, virtualization, servers and storage, everything is managed by my vendor. All I manage is the application or the data that I have to control. And if I were to define this service, I would say it is a compute service which gives me PaaS offerings, right? Now, unlike EC2, something that we'll be discussing next, you do not have to set up underlying infrastructure, and instead you can actually just go ahead and quickly deploy these applications to AWS Cloud Platform and manage them. So basically it is nothing but a PaaS offering that AWS has to offer to you. So I believe Elastic Beanstalk is clear to you people. Let us go ahead and talk about the other service or the other domain. So the next service that we have here is Amazon Lambda. Now when you talk about Amazon Lambda, it is a serverless compute service that Amazon Web Services has to offer to us. Now when I say a serverless compute service, what it does is it basically takes load off the developers to a very great extent when you talk about configuring part, right? Here you do not have to worry about resources. You do not have to worry about how to launch them or how to manage them. Whole management part and even the configuration part that we talked about in the past thing, it is taken care by a Lambda service. It basically actually goes ahead and works with CloudFormation. We'll discuss that. Do not worry about it. CloudFormation to ensure that most of these tasks are automated. Once you have your application, your data, you just put it here and it starts working for you. You do not have to worry about the management part as well. In simple words, you do not have to worry about the server, underlying server. Everything is taken care here by your cloud platform. So that is what your Lambda service does for you. So all you have to do is you just have to go ahead and put your code on the Amazon Lambda and it should work for you. As simple as that. We'll explore this a little more once we get into the demo. But this is what the gist of AWS Lambda service is. Okay. Let us go ahead and talk about the other services that AWS has to offer to us. So one of them is your Elastic Load Balancers. Now, when you talk about Elastic Load Balancers, consider this scenario, right? I've mentioned about cloud platforms. There could be a situation where your application experiences a spike in traffic. Now, since there's a spike in traffic, there could be a situation that your servers are overloaded and they're not functioning well. In some cases, your application might even crash for some unknown reason as well. Or say, for example, you have a virtual machine with you and even that crashes where all your data resides. So what do you do in this situation? When you talk about Elastic Load Balancers, as the name suggests, these services ensure that you can balance your load on different resources. Let's try and understand this point a little more. So guys, there's a lot of theory that I've been talking about. Do not worry. Let me explain these concepts. I'll recap some of these for you and we'll take a look at the demonstrations of some of these services as well. So when you talk about an Elastic Load Balancer, okay, what this service does is it distributes your incoming traffic across several targets. Okay, so everywhere you've been reading this term Amazon EC2 instances, this is something I'm afraid we should have discussed first. To give you a general idea, when you talk about an EC2 instance, these are your virtual machines that AWS lets you configure. You can actually plan what storage, what network it falls under. And on top of these virtual machines, these can be your Windows, Linux, and all these kind of virtual machines, right? So most of your applications would be residing on your EC2 compute instances. Okay. So that is why we see this term everywhere, like Amazon EC2 instance. We'll be talking about that in detail, but to give you a gist, this is what it is. So when you talk about Elastic Load Balancers, what it does is it distributes your traffic Okay, so in your case, you could have multiple EC2 instances with you. Okay, so it diverts your traffic to those instances which are idle or have lesser traffic. Say for example, your one EC2 instance is experiencing a lot of traffic. So instead of diverting all your traffic there, it will divert your traffic to some other instance. For that, it uses AWS Lambda function. Okay, so Lambda function, as I mentioned, it manages this load. It helps you transfer this load. And then there are containers, something that we'll discuss again later. So let's not focus on the word containers for now. But in simple words, what your load balancer service does is it calculates what are the EC2 instances that are functioning in those regions and distributes your load evenly so that none of your instance faces too much traffic and crashes down. Okay. What it does is, these are some of the features that you see on the screen. It lets you automatically scale to meet the incoming traffic that you have. Okay. That is something that we've discussed already. It improves your overall performance of applications. That is obvious to happen. Let's assume that there is so much traffic on one of your instance that it is not able to handle that traffic, right? DDoS attack is something that you might have heard of, where people just throw in multiple requests on a particular application so that it crashes. But if this happens when you talk about your AWS instances, it would get redirected to other instances, and whoever planned that DDoS attack, that person might fail. Okay. And this also means that your application performs better, right? Because traffic is getting distributed. Increases availability and fault tolerance. Yes, your instances are not crashing. That means they are available. And if one of the instances is facing problems, others are available for it. Regular health checks to send only healthy targets. So this falls under management as well. Your Lambda and some of your management services, what they also do is they keep health checks to ensure that all the instances in a region are healthy, or in your application, basically network basically. So if an instance is not healthy, the traffic won't be diverted to that instance. So that is what load balancer does, guys. As the name suggests, it balances the load of your resources for you. Okay. Let us go ahead and take a look at some other pointers. Okay. Let's talk about what are the types of elastic load balancers that you have with you. You have your classic load balancer, network load balancer, and your application load balancer. So when you talk about your load balancers, your classic load balancer is the typical EC2 load balancer that we've discussed, right? So what it does is it basically understands that one of the instances facing more traffic and it diverts them to other instances. But when you talk about your network load balancers or application load balancers, now these function little differently. These operate in your network layer of your application basically, or when you talk about computer networking, we have different layers, right? Which fall under your network, where basically your resources reside or your data resides, right? So when you talk about load balancers that operate in the network layer, we call them as your network load balancers, and the one that fall under your application layer are called as your application load balancers. Now this is something that we should not get into the details of, but these are some of the types that AWS has to offer to you. So the next point that we have on our screen is auto scaling. So when you talk about auto scaling in particular, what Amazon does is it gives you the freedom of upscaling and downscaling your instances. Okay. So let's assume that you have certain instances where your data is residing. So in this case, what happens is there could be a situation that I've already mentioned, that some of your instances might experience a lot of traffic. In some cases, they might just not experience traffic. So you can actually ensure that your EC2 instances are always available to handle a particular set of load. In case if you assume that, or you know that the load of your particular instance is going to increase, in that case, you can always set them up for auto scaling. When the traffic increases, they scale up to ensure that the functioning is smooth and in place. Okay. And you can even actually go ahead and terminate some of the instances right away. Let's assume that your instance is not expecting any traffic and it is not expecting or not having any traffic at all. In that case, paying money for that instance does not make a lot of sense, right? In that case, you can actually go ahead and terminate that particular piece or set of instance so that you do not shed any extra money on that instance. What are the features that Amazon auto scaling offers to you? It offers better fault tolerance. It is highly available and gives you better cost management. So I do not see a point where we talk about these pointers a lot more, because it's pretty evident from the definition itself what it is. Let us go ahead and try to understand something else here. Okay, so this is one of the most important bits that we would be talking about in the compute services domain. Okay, so we've heard about EC2, something that I should have discussed prior to all the services that I discussed, but it does not matter. We'll cover this now, and probably all that we discussed will still make sense to you. Okay, so this is one of the most important services that AWS Compute has to offer to you. It is one of the most popular services when you talk about computation domains on cloud platforms. Okay, so it is one of those services that was started in 2004. Okay, I believe this was basically found by Christopher Brown, if I'm not wrong, in 2004. He was based in Cape Town. I'm not sure whether it is the same service or some other service that he found, but it was one of those first services. It was found in 2004, and it soon became one of the most beloved services in the world. And these days, EC2 provides you with so many options. Let's try and understand what EC2 service is. So guys, when you talk about Amazon Elastic Compute Cloud or Amazon EC2, it is a web service that provides secure, resizable compute capacity in the cloud. It is designed to make web scale cloud computing easier for developers. Okay, so as the definition suggests, it lets you launch instances or virtual machines, to be frank. Now these instances are scalable in nature, they're highly cost efficient and flexible as well. As we talk about the families of EC2 that we have on our plate, you'll understand these terms to a greater or a better extent. Do not worry about it. I'll explain all these points to you in detail. But this is what the definition has to say. But I've mentioned the term instances here, right? Let's try and understand what an instance is. So when you talk about an instance is a virtual server for running applications on Amazon EC2. Okay. So guys, let me give you an example here. So when you talk about building a particular application, right? What we do is, let's assume that you are given some project that you're supposed to make on your computer. Now you do not have a computer or a resource that lets you build that. In that case, what you would actually do is, you would actually go ahead and buy that resource. But that would be a costlier affair for you. To give you an example, if you have to buy a laptop in India, it costs you around 40,000 rupees for a good laptop, right? With decent specs and good functioning. But what if my work was only for 10 days? Spending like 40,000 rupees for that laptop won't make a lot of sense, right? So instead, what if I could rent a laptop for say 400 rupees a day? So in 10 days, it would cost me like 4,000, right? So that is like 1/10 of the cost that I would otherwise invest, right? So when you talk about application development, it always won't make sense for you to actually go ahead and buy everything, right? To give you another example, let's assume that I have one laptop with me, okay? And in that, I need to run a project that I'm working on that works on Windows operating system. And I have another project that I'm working on that works on some other operating system, say Linux or Ubuntu. So instead of actually going ahead and having two operating systems, which is a difficult task, right? In my system, I'll have to boot it up, set up two operating systems, and the performance would be compromised as well, right? With cloud computing, what you can do is you can actually go ahead and launch such operating systems or virtual machines. And you can launch plenty of those. What that does is that gives you a freedom of working on a different virtual machine. So what a virtual machine is, it creates a virtual replica of an operating system for you. So since it is based on a server, you can launch multiple virtual machines on your laptop and your laptop won't hang. You won't have configuration or RAM issues, right? So that is what a virtual machine is. Think of it as a small computer which has its own network, its own storage, and its own capacities. So that is what EC2 does. It lets you launch these different kind of instances, these different kinds of virtual machines. Let us just go ahead and talk about what we have next. So there are quite a few families that EC2 offers to you. When you talk about EC2 now, there's so many types of instances, so many pricing models it follows, and so many things. So we'll be discussing these points in a lot more detail. So stay tuned. And what I would also suggest is some of these pointers you'll have to revisit as well, because I would be talking about a lot of information here. And once we do that, we'll get into the demo part. So guys, let us go ahead and now understand the different types of instances that AWS has to offer to us. So when you talk about an AWS EC2 instance, to be honest, there are quite a few types of instances that are available. I mean, you can classify them based on their pricing, right? Upon the way they function and upon their applications as well. Okay. So I'm not going to complicate the process for you. Let us talk about these things one by one and try to simplify the whole process as much as we can. Okay. So let's quickly get started. So when you talk about the types of instances, these are some of the families of instances that AWS offers. One is your general purpose instance, right? So when you say a general purpose instance, these are those instances that are used for general purpose applications. They would be giving you a certain amount of throughput or performance. Okay. So let's assume that you have an instance that works at n capacity. Okay. N is the total amount of capacity it has. But when you talk about a general purpose instance, it reserves its capacity. Okay. So these are also called as burstable instances. Let me throw in some light on this topic. Okay. So when you talk about a general purpose instance, let's assume it is working at a particular capacity. Okay. So in this case, it would not work at an n capacity. Instead, it would work at n minus 80 or n minus 30 capacity. That means 30% or 20% of its capacity it will work at. Okay. So if there is a requirement where you need to have a bigger or a better performance, in that case, it will burst out of its shell of 30 or 20% performance and it will perform better. With AWS, you get certain credits that are assigned for burstable performance. So you can use burstable performance for those credits. Okay. So that is what a general purpose instance is. Do not worry, we'll be launching an instance or two where we'll talk about these pointers. Next is your compute instance. Now, these are those instances where you need heavy computation, right? So, basically when you're talking about high compute power, that is where your computation instances come into picture. Memory instances. Now, these are the instances that talk about processing data in memory. We are talking about our RAM, ROM, all those kind of features here. GPU instances that you see on the screen, these are used for graphical processing. Okay. So when you're talking about video rendering, modeling, other applications that related to graphical processing, those are the things that work well on your GPU instances. Storage instances, as the name suggests, these are the instances that give you better storage capacity. Okay. So these are the types of instances based on their families. So these are their families, that is general, compute, memory, storage, and GPU. Okay. EC2 pricing model. Now there are instances that are classified on their pricing model as well, right? So when you say an on-demand instance, it is that instance that is available on demand. It is available anytime you want it, but it comes at a higher price. It's just like renting a hotel room, right? You visit to a new city and you rent a hotel room. So there what you do is you get whatever, I mean, you go there, you'll just demand something, you'll pick a hotel room, whatever you want, and you'll take that, right? So this could be costlier. Why? Because you're doing it on the spot, not on the spot, but on demand, right? Next is your dedicated instance. So dedicated instance is an instance that is dedicated for a particular kind of application. Okay. So you are a user and you say that I have a particular set of applications that I need to run, and I want this instance that is available only for my requirements. In that case, you go for a dedicated instance. Reserved instance, it's just like reserving your hotel in advance, right? You know, you're visiting maybe Goa or maybe Maldives or something like that, right? So you know you're going there for 4 days and these are the days that you're going to visit there. So you reserve those hotels in advance. So you get those at a cheaper price. So same is with reserved instances. You know that you're going to need these many instances for this duration. So you'll book them in advance. Okay. So they come to you at a cheaper price. Why? Because you're reserving them in advance and for a longer duration. On spot. Now this is like bidding on something where let's assume that you have an activity that needs to be done. You do not have any specific requirement here. Any kind of instance will work for you. This is where on-spot instance comes into picture. You just go there and you look for an on-spot instance. It is little different from on-demand instance. When you talk about an on-spot instance, it is you use what you get. Okay. So the pricing here is not fixed. There is a bidding on these instance. If you match that bid, you'll be given that instance at that bidding price. Once you release that instance, there could be a possibility that you might not get that instance at the same price. Okay. So these are the types of instances that we have from a pricing perspective. So let us now go ahead and understand something else. So let us talk about their applications, right? So when you say a burstable instance, okay. So a burstable instance, as I've already explained, it is something that performs at an optimal performance to start with. But when you require it to burst out of its optimal performance, it can do that for you as well. EBS optimized. Now these are applications that are used for optimal performance. Now in this case, let's talk about messaging system, right? Suppose you want to deliver messages to people in larger volumes, but at a consistent rate. So you know that the rate is consistent. You need good performance, constant performance, but in lower volume will also work for you. So that is called as your EBS optimized instance, or these instances are used in those places. Dedicated, we've already discussed that they are meant for a specific application. Let's assume that I have highly secure data that I want to preserve and want to work on it in private, right? So I can have dedicated resources which are not shared by anyone, and I'm getting the access to those resources for the time duration I want to access them. Cluster networking. Now, cluster networking is something that basically classifies your instances on a particular cluster performance. Say, for example, I need a particular set of performance in a particular cluster of applications. So I'll be using that kind of an instance there. Say, for example, I might have an instance for backend operations and one for front-end operations. And both the instances are clustered, or all the resources that are there in that cluster, they work similarly, okay, or for a similar cause. So that is what your cluster network instances are. So this was about the theory of compute instances. Let us quickly go ahead and log into our console, and let's see how do these instances work. Okay, so I'm going to quickly go ahead and fire up my AWS Management Console again. It will ask me to sign in again. That is the standard procedure it has. Each time you sign off for a while, it will ask you to log in again. So there you go, guys. This is my console. So we've discussed this console a little. Let's just go ahead and talk about EC2 instances. Now you can see there's an instance that is up and running already. I do not need this instance. I'm going to terminate it quickly. So guys, when you terminate an instance, it is not available for you to use any further. If you stop it, the instance will be there, but it would be in a stop state. It won't be functioning. You won't be charged for this instance. Okay. But if you terminate it, it would be deleted permanently. So when you talk about AWS EC2, basically, as I've already mentioned, you can launch instances here. You can launch virtual machines here, right? So what we are going to do is we're going to go ahead and launch a virtual machine and understand it from a perspective where we get to know almost all the things about it. Okay. So let's just quickly go ahead and do that. So again, I'm going to come back to the running part. It is shutting down this instance. So meanwhile, just go ahead and launch one more instance. And once we launch that instance, I'll be talking about other pointers as well. Okay. Do not worry about that. So let's just go ahead and say launch. So guys, when you try to launch an instance, you get quite a few options here. So when I say options, there are options to choose from type of virtual machine that you want to launch. So what you see on the top of the screen is it says choose an Amazon image, right? Amazon machine image. So that means you're given a choice to pick a particular Amazon machine. So your instance of virtual machine is nothing but a machine, right? So when it says choose an image, that means image is nothing but, or AMI is nothing but, it is a template instance or a virtual machine that AWS has created, which has some configured or pre-configured values with it. Okay. So you can actually go ahead and launch that particular instance or that AMI, and it will have a set of values or principles or resources attached to it. You can actually go ahead and also create your custom AMIs, but that is a complex process. Let's not do that. What you can also do is once you create an AMI, you can take, you can make a copy of it and save it with you, so that actually when you actually want to go ahead and launch a similar instance, you can do that as well. Okay. So this was about the instances in general, AMIs in general. Let's just go ahead and launch one of these instances and see how it works. Okay. So if I scroll down, You can see that there are types here. I have Linux instances, right? I have my Red Hat instance, SUSE. I have Ubuntu. It says that you can actually try out Lambda as well. Lambda, as we've discussed, is a serverless computing service that AWS has to offer to you. You can launch your Microsoft server instance as well. So guys, what you've note here is, see, it's written free tier eligible below it, right? So these are the instances that are available to you free of cost. You are not supposed to pay for them even if you release or launch these instances. Not all these instances are free of cost. If you scroll down, you see these deep learning AMIs. Now these are something that are not free for you. Why? Because actually these are something that come with higher configuration, and that is why you're charged for these instances. So the minimal size of instance is something that you can launch under your free tier account that you have. Okay. So this again is a free tier instance you see here. Okay. So, okay, you can actually go ahead and launch some of these instances. Let me quickly just go ahead and launch. Which instance should I launch? Let's launch the Windows one. It is the easiest one to actually go ahead and configure. Okay. So, there are different ways in which you connect to these instances. Say, for example, your Windows instance can be connected through remote desktop processing. But if you have a Linux instance or a Ubuntu instance, for that you have to actually go through PuTTyGen. And PuTTY, that is something that lets you decrypt your keys, and then you can log into those instances using PuTTY generator. Okay, it's called as PuTTY if I'm not wrong. I'm not sure the exact pronunciation whether it's PuTTY or PuTTY, but I call it PuTTY. Somebody recently corrected me telling me that it is PuTTY, so let's stick to it being PuTTY. Okay, let's just go ahead and now launch this instance for now. So I say next. It gives you details about the VPC here, virtual private cloud. It is a networking service that you have in your hand. So you can decide what kind of subnet do you want it to fall under. Okay. So it will give you all the details here for that. You can actually go ahead and change that. IAM role is a security service, IAM, that lets you create IAM roles, who gets to access what. So you can create a new one, or you can use something that you already have if you want one. If I don't do anything, it creates one role by default for me. So I do not have to do anything. I'm just going to go ahead and say next for now. So when it creates something by default for you, it comes with basic settings and security. If you want to optimize on it, you can do that. Now this is where the storage part comes in. Okay. So when you say a storage part, okay, so by default, it comes with 30 GB of storage attached to it. Okay. So I can actually go ahead and attach more storage, or I can just change the storage value here. I can go up to 100 GB if I want. So we're gonna see how to actually go ahead and attach volume to an instance, but we'll do that in the later half of the session. Let's not do that now. Okay. So, and these are the types of volumes that are attached. That is your general purpose SSD, provisioned IOPS SSD, magnetic standard, right? So these are SSDs. You can also have SDDs, but you don't see that here in option, right? Because SDDs are nothing but a hard disk drives, something that you attach externally. So if I add more volume to it, right, this is where I'll get more options here. Right? See, cold SDD, throughput SDD, right? So this is the option that you get when you attach something or volume externally. So the volume thing, we'll get into the details of it later. Let's just go ahead and say now add tags. Tags are something that let you differentiate your instances, because when you launch like 50, 60 instances, it is difficult to classify all those instances. So tagging is a good habit. Security. Now by default, see, I'm gonna RDP sign into this instance. It will use TCP protocol, this port range, and source from any traffic. It will let me get the traffic in. I can choose what IP I want to use as well if I want to. So depending upon what kind of security you want, you can make changes here, right? So if I use the basic one, it says rules with source so and so to access the instance. We recommend setting up security group rules to allow access for known IP only. It says that change it to your personal IP because that would make it more secure. But this is a demo instance. We do not have to worry about it. So let's just say launch. It is again giving me a notice saying that you can improve the security, but let's skip that. So this is the last bit of it, which again is important if you ask me. So when you talk about these instances, right? So basically what AWS does is it lets you sign into these instances through different media, different ways. So what are those different ways and different mediums through which you can sign into an instance? So not different ways, basically I misspell or misuse the words there. So basically when you talk about a key pair here, what AWS does is in these EC2 instances, it actually lets you sign in with a key pair. So key pair is nothing but a collection of public and a private key, as you see on the screen. So what this does is you basically are given a private key and AWS has a public key. Together they allow you to connect to an instance. You cannot do it without one or the other. Okay. So when you actually go ahead and choose a private key here, it gets downloaded and you have to ensure you keep it safe with you. Because if a private key is lost, you cannot access your instance going ahead. So that is an important criterion there. So make sure you have your private key safe with you. Okay. So how do you do that? You just come here and say create new. Let's call it demo 321. And I say download. So as I've mentioned, keep it safe with you whenever you use it. And now I'm going to just go ahead and say launch my instance. So launching this instance will take a couple of minutes. Okay. So let that instance get launched and then we'll see how the instance works and what else can we do with that particular instance. Okay. So what shall we do now? Okay. So let's just go ahead and take a look at some other pointers meanwhile this instance gets launched. Okay. So if I click on EC2, it will show that one instance is running. Why is that? Because I've deleted or terminated one of the instances, as you can see here. So it does not show me two instances up and running, right? If I scroll down here, you see that I have these spot requests, the pricing that we talked about, right? Reserved instances, saving plans, dedicated hosts, scheduled instances, and all those things. Images, AMIs, you have it here. You can choose different AMIs, right? You can create your own as well. Volumes. Now, if I come to volumes, there is one volume that is already here with me. I can actually go ahead and create other volumes as well. Let's say I want to create one more volume of 30 GB. Let's call it 50 GB just to be safe. I can choose a region where I want that volume to be in. So preferably keep it in the same region where your instance is, and then you just say create volume. And just like that, your volume would be created here. We don't see any right now because it will take time. There you go. Your volume is here, right? Its performance is also different. So you can always have a volume that is up and ready with you. So if I click on this, it will give me an option of modifying my volume. I can increase its size. If I have an attached volume, I can increase its size, right? If I actually have to delete a volume, I can do that. I can detach a volume from an existing instance and attach a new volume to it as well. So these are the options that I get with an instance that I create, okay, or volume that I create. For now, let's just go ahead and delete it. I can take a snapshot of it as well. So I can create an image of my volume as well so that I can reuse it, repurpose it. Let's just delete it for now. We do not need it. Okay, so it will delete the volume of the instance. So let that happen at its pace. Okay. Let's just meanwhile go ahead and see if our instance is up and running so that we can start using that instance. There you go. Our instance is up and running. Its status check is still showing initializing. So basically it goes through two status checks for you. You can actually go ahead and wait for it to happen. You can even launch instance right away, but let that status check actually go ahead. If I click on this instance and if I scroll down, you'll get more information about the instance, right? What family it belongs to, which region is it located in, availability zone, as you can see, scheduled events, its type, okay, root device. This is the root volume. So when you actually go ahead and detach a volume and attach a new one, you have to ensure that you attach it to this device or this root device only then that you can attach a different volume to it. So these are some of the things that happen when you, these are some of the things that are there. Status checks, if you come here, yeah, it will give you status check, status. So one of the status checks is already passed. See, now both of them are passed. Instance reachability check passed and this also passed. So there you go. We have cleared our status checks rather. So let's just go ahead and launch our instance, shall we? So I say connect. It would say download RDP. Using this, I'm going to connect to my instance. Okay. And for that, I would be needing my public private key, right? Private key that I have, but I need to decrypt it first. So I'll have to choose my file. So if I just go to downloads and if I look for demo, I should be having demo 321. This was the one we used. There you go. And now I will say decrypt the key. So no sooner I say decrypt the key, it will actually go ahead and generate a password for me. So I just copy it from here. There you go. I close it. I launch my RDP. It will say connect to the instance. Now what do? We enter the password that we've used. Let's say OK. And I say yes. So just like that, we've actually gone ahead and launched a virtual machine with a lot of ease. Now this is a Windows virtual machine, so it would look like most of the Windows systems that you use, right? So you'd be having similar tabs, similar ability to connect to internet and stuff like that. So yeah, there you go. It is just like the normal instance that we have, right? And here are some links that you can visit to. So you can actually go ahead and connect to internet as well. Whatever internet that you use at home, it is accessible, or you can access that internet using this instance. Again, this acts as a separate machine altogether. See, so I can launch multiple instances in my system. If I click on this thing, it will, okay, let's go here. Okay, and let's take a look at the volume that we have. So we have this 30 GB of volume, 16 GB of it is used for obvious purposes. C consumes that, right, for the software that is installed. And 29.9% was the total 30 GB that we actually assigned to it, right? Can we change the volume here? Yes, definitely we can change the volume. Let's see how to do that. Okay, for that I'm going to terminate this machine for now. Let's say yes. And what do I need to do? I need to stop this instance to do that. Okay, so we will just say stop the instance. Yes, stop. There you go. So it will take half a minute to stop. So I've actually gone ahead and I have a volume that is attached to it, right? So let's just go ahead and do one thing. Let's just go ahead and change its size, okay, and see how does it reflect. For that, we'll be needing a command called as yeah, this is the command that we need. Okay, so this is something that lets us connect to our instance, basically not connect, but lets us manage our disk space, disk mgmt msc. Okay, so I'll show you why that is used. We'll get into the details of it as well, but our instance is stopped meanwhile. So let's just go ahead and quickly go into volumes first. Volumes, and in volumes I have 30 GB of volume. Let's just say modify volume and say make it 100 GB. There you go, and I say modify. Are you sure? It may take some time for performance changes to take full effect. You need to extend OS file system or the volume to okay. So it's just like our hard drive, guys. I'll brief you on that, what they mentioned by the commands that are there. So let's just go back to the instance, and whatever change that you've implemented, they say that it might take a while for that to reflect. Okay, so let's just go ahead and see what we can do with it. I'll say start my instance. So it will take half a minute again to start the instance. So let this instance start. Okay, so There you go. So it will initialize my instance again. Okay. So I hope I've launched the right instance. Yep. So the other one is terminated. So this should not be a problem. Once this is up and running and it is initialized, we can actually go ahead and connect our or make the changes to our volume that we have, right? So I was telling you about this command, right? So basically when you say disk mgmt msc, okay, so what this command does is this lets you manage your disk space. Okay, so once we actually go ahead and connect to our instance, let's see if we can connect to it. Whenever you restart an instance, it actually takes time for you to go ahead and connect to that instance. So let's see if we can do it like right away. When I say decrypt, I say copy. You do not have to go ahead and launch RDP each time, okay? I mean download it each time. You can use the one that is already there with you. So let's see if it connects, because normally when you detach a volume and attach it again, it is then that it takes time. But now in this case, it has successfully launched in. Okay. So okay, so if I just come here again, and if I just click on this icon and I say File Explorer, and if I look at the PC, okay, it still shows 30 GB. There's a reason for it. For that, I have to go back again and I will have to go into my run command, run option. Okay, desktop app, disk mgmt .msc. Maybe you can start it from here again. So if I click on here, it will give me certain options, right? Extend volume. So I say next, and I say next, I say finish. So now my volume would change here. Let's just go ahead and see the changed volume. You can, okay, it's still not reflecting. It will reflect, do not worry, we've changed it, right? The reason we had to do this was there you go, 100 GB. So it's just like formatting your disks, right? When you attach a volume to it, you have to format it. So that is what I did when I went into disk mgmt.msc. Okay. So this is how you launch an instance. This is how you actually go ahead and do the things that I did with the instance, right? So this was about EC2 instances. You can actually do a lot of things. There's stuff like public IPs, private IPs, right? You can control quite a few other things as well. We'll discuss that some other time. But as far as EC2 is concerned, I believe you people have understood what EC2 is, right? So let's just go ahead and terminate this instance for now. Okay. So I'm just going to say instance state to terminate. And this will take half a minute for this instance to actually go ahead and terminate. Okay. So when you talk about AWS, again, there are other services as well, right? You have storage services like S3 here, where you can actually go ahead and store your data, right? So this is more of a bucket and object kind of a storage. You can see there are certain buckets that are created here. You can create one. Now each bucket is globally unique, right? It does not show any region here. Why? Because you can because buckets are considered as globally unique. So buckets act as folders, right? Where you actually go ahead and upload some data, which you can do like right away here. Let's say add a file. So I'm going to just go ahead and pick up one of the thumbnails that I have, and I'm going to say upload. Okay. And within a minute, that file would be uploaded here right away. Okay. So this is hot storage. That means you store hot data here. That is something that you need to retrieve or store right away. You have cold or archival storage called as Glacier, where you store that data that you are not going to access frequently. So it comes at a cheaper price. So when you talk about AWS, there are quite a few services that are similar to this, right? And you can do so many things with these services. It's just the matter of coming here and exploring these services. So yeah, we just actually did go back and saw how EC2 works on AWS platform, right? It is a virtual machine service or compute service that AWS has to offer to us. We talked about EC2 instances, right? So let's just go ahead and talk about Elastic Beanstalk as well. Let me see if we can actually go ahead and take a look at a demo. Okay, so when you talk about EC2, right, or when you talk about computation services, I've talked about what platform as a service is, right? What kind of service model it is and what kind of services it has to offer to us, right? So let us just go ahead and try to explore Elastic Beanstalk, which is a platform as a service that AWS offers to us. So for that, I'm going to just go ahead and type Elastic Beanstalk. And it will redirect me to that page. Unfortunately, I don't think I have Git repositories with me. Let's see if we can just launch a sample application for now. Okay. Getting started. It says application information. Let's call it sample demo. Okay. Sample demo looks good. Let D be capital so that we can keep track of it. So guys, this is how the interface looks like. I'll be talking about quite a few things as we move further. Do not worry about that. Platform, let me choose one. Let's say PHP. It will by default take an environment. Okay. And then it says use sample application. You can even upload your own code, but let's just go ahead and upload a sample application, right? So let me explain you what is happening here. As I've mentioned, when you talk about Elastic Beanstalk, it is a platform as a service. What that means is you can actually go ahead and launch applications on a platform that is already there with you. So as you can see, I'm launching a template application here, right? I've named it sample demo. So it asks me what platform you want to use. See, it's giving me all the options that are here, right? I can choose these platforms. There's so many of them here, right? So a pre-configured platform is given to me, right? So it chooses I can actually go ahead and make changes to the versions as well that I have. Okay. So it gives me all these kinds of freedoms. So that is what platform as a service is, right? When we launched an EC2 instance, what did we see? We saw that we had to configure everything from the scratch there. I had to choose, a particular AMI, right? A virtual machine, a template of it. Then I had to, even though I selected by default options, but I selected a subnet for it, security group. I could even control the access there. So I'm setting up an instance at a root level. Here, a platform is given to me. So this platform is also based on a particular instance, right? So the configuration of the instance and all those things are taken care by my platform or AWS in this case. And it sets up this platform for me with ease and with so many features for me to actually go ahead and use, right? So let's go ahead and launch a sample application and then we can talk about these things a little more. So let's just say launch an application. I hope it does not ask me for my Git account. I do not have one right now. Okay, so it's creating all the environment by default, as you can see, right? So see, it will take few minutes because it will do all this process that you see at 10:58 p.m. right? What it's doing is it's actually going ahead and setting up an Amazon S3 storage bucket. So this is where my data would be stored if I use any, right? First it creates a bucket. We'll talk about S3 buckets. It's a storage service where you can store your data. Going ahead, it would create an environment. Okay. So you can see using Elastic Beanstalk, it has chosen a region for my bucket as well. South. Actually, buckets are globally accessible. We'll discuss that later, but yep, you should know that. But it's based in this region is what it's suggesting. Again, what else is it doing? It's creating an EIP, that is Elastic IP address that is associated with my instance. Okay. So a security group would be created that keeps my resources secure. Okay. So guys, what is happening here is the environment is getting created for me. I'm not required to do any of these activities, right? So let this happen, right? Once this happens, So this would be a basic application. We are not doing anything major here, but let this happen, right? I mean, some demo is better than nothing. So let this application get created. So it might take half a minute. So let that happen. Once that is done, we can actually go ahead and talk about other things as well. Now it says that it's waiting for EC2 instance to launch. So basically it will configure the complete EC2 instance that is required for this application to run. And I do not have to worry about anything here. Okay. So added instance as well to our environment. Now it will actually go ahead and put everything in place for us. So hopefully we can start sooner. Okay. So meanwhile it creates this environment. Is there anything else that we can do, right? So let's quickly just open another console. I do not want to tinker with the console that is open already because I do not like the Elastic Beanstalk interface. Last time I created an application and it took me a while to actually search for it. So that is why. Okay, so successfully launched an environment. Environment health has transitioned from pending to okay. Initialization completed 32 seconds ago and took 2 minutes in total. Okay, so we are almost set and ready to go. So you can see that the process started like 3 minutes ago, right? And within 3 minutes, an environment was created for me. You can even actually go ahead and deploy your application if you want. If I just actually go ahead and click on this link, it would open that PHP website for me, right? The application that it launched. So this application that we've launched is nothing but a documentation that AWS has to offer to us. Okay. And this documentation or this application that is here, it is residing on an EC2 instance. Okay. On a platform that is created by Elastic Beanstalk. Okay. So if I come back here, okay, I even have an option of upload and deploy. So I can actually go ahead and deploy my set of piece or my set of code as well, whatever it is. And the option that you saw when we said create a sample application, I selected a by default application, right? We can actually go ahead and do one thing. We can also, if you select to upload a code there, you can actually go ahead and connect your GitHub repository to it. So once you do that, if you have pieces of code that you've worked on and you want to move into these environments, you can do that as well. So as I explained in the initial concept phase where I talked about platform as a service, I mentioned that you can move your data to a platform or you can create ready to use applications based on the platform that is available to you. The platform setting up process is something that is taken care by your vendor, in this case, AWS and Elastic Beanstalk. So as you can see, our basic application is up and ready and we have an environment with us as well, right? And from creating your application, you can actually go ahead and deploy it as well. Okay. So these are the options that you get when you actually go ahead and work with Elastic Beanstalk. Okay. Let's just refresh it for now. Okay. I go to applications and let's see if we can delete it. So make sure whatever you create, you always delete those applications because it says delete the name of the application. Okay, sample demo. That is why I have names that you always remember, guys, so that you do not have to waste your time doing these things. So sample demo, I select it and I delete it. Delete it because even though these resources are under free tier, it's always advisable that you actually go ahead and delete these applications so that in future, if you forget any of these and you connect something else to these devices which are chargeable, you do not want that to actually go ahead and terminate or harm your free tier, basically. Okay, so it is under the process of deletion, so it should be deleted. Do not worry about that. We should let go of it and go back to our presentation, right, and talk about other concepts. Okay, so we've actually gone ahead and successfully explored EC2 instances, right, how they work. We've also talked about Elastic Beanstalk, right? How you can actually go ahead and set up an environment with ease. You don't have to set it up. Elastic Beanstalk does that for you. Yes, you are open to make changes to it, but since you're opting for platform as a service, it's better all the configuration part is something that is taken care by your vendor. Okay, so let's just go ahead and talk about some other concepts now. So we finally come to the next topic of discussion, that is AWS Storage Services. Okay. So in this, there are quite a few AWS storage services that are there on our hands that we can use. we are going to get into the demo of these services. While talking about EC2 instances, we did talk about EBS, and we saw how to actually go ahead and increase the volume of the instance, right? So that volume was EBS backed up. It was EBS in nature. So it is one of these storage services. We'll talk about that at length, but let's just go ahead and talk about storage services in general and try to understand how cloud storage is actually different from normal storage, right? So what exactly is cloud storage, right? Let's try and understand that. So let me give you an example. If I were to go back, I mean, recently there was a time, not recently, some 7-8 months back, I was interviewing quite a few people. And then I asked them a question as in, can you tell me about cloud computing in general? So these were some set of interns that we were trying to hire. So they were fairly new to the topics, but since they had written these things in their CVs, I thought let's go ahead and test them on these topics, right? So when I asked them about cloud computing, they said that it's a mechanism to store data. So they were correct to whatever they said, right? I mean, when you think of cloud, what you think of it as Google Drives, and right? Google Drives where you take your backups and stuff like that, which is true because that's nothing but a cloud resource for you, right? A cloud service for you. But when you actually do cloud computing work on these cloud platforms, you realize that cloud computing is a lot more than just the cloud storage that you have at your disposal, right? I mean, cloud computing is not just storing data. It is a lot more than that. So that is where I could realize that maybe there are quite a few people out there in the world who actually have some myths about cloud computing, cloud storages and storages in general. That is when I had actually gone and taken quite a few sessions on YouTube as well that talked about differentiating between normal storage and cloud storage and stuff like that. So that was an instance I remembered. I thought I should share it with you people. Let's just go ahead and understand cloud storage, how it works, right? So when you talk about AWS cloud storage or cloud storage in general, right, we are referring to online storage that is available over a network. Okay. It is, when you talk about cloud storage, right, it is nothing but providing online storage to people over a network, right, which consumers can consume over a network as storage as a service. So basically, yes, cloud storage is a storage where you store data, but the major point that you need to note here is it is made available over a network. So you can access it through the internet, right? So say for example, when you talk about the storage, you can actually go ahead and store your movies, your chat, right? It can be backed up on your Google Drive or your drive, not Google Drive, your drive in general, right? Can be any cloud drive. So, to give you an example here, right? Say for example, my WhatsApp chat gets backed up at 2 p.m. I'm not sure that that happens every day, but that happens at 2 p.m. So there is a cycle that is set up there. So where does this chat get stored? Does it get stored in your phone always? No. You always link your email ID with your cell phones these days, right? With your smartphones. So basically your data is getting backed up into the drive that is connected to your email ID, right? If it is a Gmail, it would be your Google Drive, which again is a cloud service, right? So your data gets backed up there. So this is what cloud storage is. Your data is getting stored over a data center that is residing somewhere across the globe where the data center is, and it is getting backed up through the internet. I mean, you are not physically putting your data there. It's getting backed up through your mobile, through the internet. It is flowing over a network and it gets backed up to the data center that you're using. So that is what cloud storage is. And there's a lot that you can do with cloud storage. We'll explore that as we move further. But I believe the basic definition is clear to you people as to what cloud storage is. Okay. So what are the features or some pointers that you need to know about cloud storage? First one is your data backup. Okay. So when you say data backup, I've already explained that, giving you the example of WhatsApp, which is a messaging app, right? I'm sure most of you are aware about it. Next one is your messaging data, right? So again, WhatsApp is an example here, but let's talk about it from a bigger or a longer perspective, right? Or a wider perspective rather. Say for example, I have multiple applications, right, that communicate with each other over a network. Now, this messaging or communication is again nothing but messages and data, right? It needs to be stored somewhere, even though it is flowing on the network, right? So it would be backed up on your cloud storage. So that is one of the applications or usage of cloud storage. Application data. Now you can also store your application data. Communication is again application data, but when you talk about an application that we just created, right? So you saw that there was an S3 bucket that was getting created, right? So S3 bucket would hold all the relevant data that concerns your application, right? Some of the data would also be backed up on the ephemeral and persistent storage that you have, right? We'll talk about that. Do not worry about what ephemeral and persistent storage are, but it also will get backed up on those things as well, right? So application data is also getting stored on cloud that reside on cloud or are connected to cloud, right? Multimedia. So you have your files, right? You can talk about your images, your videos that you upload, right? Even the chat in WhatsApp, there would be always images and stuff that get backed up, right? So your multimedia files can also be stored on cloud, and also processing and application data. So cloud is not just limited to storing images and videos and messages. You can actually process your data, and even that can be stored using cloud storage. So this is an important thing that you need to know. Do not worry, we'll be talking about quite a few pointers. I've also remembered one more example related to multimedia. So one of my friends, he actually never used to take cloud backups, okay? So for me and my generation people, cloud backups are these are cool things for us, because I come from an age where we actually did not have cloud when I grew up. And I've also lived a life where there were no phones, actually, to be very frank, and no mobile phones to be specific, and no smartphones. So I've seen all this transition. So if I am not to go too back, I remember one of my friends losing all his data. Why? Because his phone got some rebooted or auto booted. Okay. So he lost all the data he had in his phone. Then he decided to actually go ahead and start backing up his data. Next time when his phone got rebooted, his data was stored on the cloud drive. So that is how he saved his data. So that is what cloud storage also lets you do. The backup lets you retrieve your data, even if your phone is not in a condition to handle the data. Okay. So this was about different storages that cloud has to offer to us. Okay. Or different applications that cloud storage gives to us. Let's go ahead and talk about the AWS cloud storage services that are in our hand. Okay. Okay. Now there are some benefits that we need to discuss first. So let me talk about those first. Okay. So what are the benefits? The data is readily available for you. So when you say readily available, I mentioned that it is cloud backed up, right? So I can actually just go ahead and access that data, and it will stay, it is persistent, right? Even if I change my, move to a new phone and stuff like that, my data would always be there with me because it's backed up on cloud. It's cost effective. Cloud platforms are cheaper, right? We've talked about that a little, not at length, but we've talked about that to some extent. So let's not elaborate on that point, right? Secure. Yes. So, another example to give you of cost effectiveness is, you do not pay for your Gmail, do you? No, we don't, right? So yes, we pay for the internet. I understand these things, but buying a physical hardware to store your data than to store it on drive is a better option, and it's a cheaper option. That is why cost effective. Security. Yes, since you have data backup, your data is secure as well, right? You do not have to worry about it getting lost physically because it's stored over the network on your cloud platform. And cloud platforms are very secure. We've discussed that as well. Easy processing. Now, when you say easy processing, yeah, since the data is available, you can consume it right away, and processing, we'll discuss this in the database part, right? When we talk about data processing and stuff like that. Okay. So it makes, when you talk about data being on cloud, it is easier to process your cloud data basically. So these are some of the benefits of AWS. Okay. So cloud storage myths. So we still haven't gotten into AWS services. So I believe I'm a couple of slides away from the storage services that AWS has to offer to us. So let's discuss storage myths first, and then we'll get into the AWS cloud storage services that are there on our hand, right? We'll discuss those in detail and at length. Okay, so cloud storage myths, right? When you talk about cloud storage myths, people have quite a few misconceptions like they have about cloud computing. They also have myths about cloud storage as well. Let's try and discuss those one by one and in detail. Okay. So when you talk about cloud storage myths, one of the major myths that people have is cloud consumes a lot of power. So what they assume is, since there are so many big data centers that are running out there, it's gonna consume a lot of power. So that's obvious, right? It will consume a lot of power, but at cost of what? You have to understand that as well. So when you talk about a data center, the amount of data that it can store is huge, right? So even if you do not move it to cloud, you'll be moving this data somewhere in. Even those resources will consume your power when you use it or do whatever you want to. So does cloud consume power? It does, but does it consume more than what you would use otherwise? That's debatable. Another important point that you need to understand here is when you talk about popular cloud platforms in the market, they do a lot of research on these things, as in how to optimize resource usage, how to optimize use of electricity as well. GCP, Google Cloud Platform in particular, does a lot of research on these topics. So what that means is they've ensured that they make use of minimal amount of electricity to do these things. And the amount of electricity that they use, that also serves a very large audience, which would other which way consume electricity in that amount. That is why GCP, if you see, on a shorter run, it is one of the most affordable, not one of the, it is the most affordable cloud platform if you look at services from a shorter duration perspective. And it also offers you per second billing. So that tells you the research that they've done in ensuring that their data centers consume less amount of resources and electricity, and that is why they can actually provide these services to you at a cheaper price. So this is one of the reasons. Okay, so I believe that clears your myth as to cloud. Even though it consumes a lot of power, it caters a bigger and a wider audience. Complexity in data storage. So when you say complexity in data storage, what people assume is it is difficult to store data on cloud, as in people first of all have this mythical feeling about a cloud that it is something that is very it's located somewhere far away, the data storage takes time, it is not secure and stuff like that. So people have these beliefs in their mind which are not always true. So is it complex to store data? We'll take a look at S3 service. You'll understand how easy it is to store data there. Okay. So is it complex to store data on cloud? No, it is definitely not complex to store data on cloud. Not for small scale businesses. Why are we discussing small scale businesses? Even as an individual, our WhatsApp data gets backed up somewhere, right? So from a user perspective, definitely you're using cloud whether you want it or not. From a business perspective, is it only for larger scale businesses? No, that's not true. Even small scale businesses can actually use cloud platforms. You can host your applications, your websites, your data, and even store it there at a cheaper price. So nowadays, the flexible pricing model ensures that people can actually afford these services at a very cheaper price, and even by not investing too much money. Next one is downtime and security. So does cloud have downtime? I won't deny to this point totally. Okay. I mean, see, when you're talking about any resource, any domain, it is never 100% clean or right, absolutely right or correct, right? There would be some fault anywhere, right? So when you talk about downtime, if you take a look at disaster recovery and reliability numbers, something that we'll see in future slides, you'll realize how safe this cloud platform is from downtime and stuff like that. Yes, if you go back to like early 2010s, like 2011, 12, back then there were some outages which were major, but we are like 8 years away from that. And outages handling, downtime handling has improved like anything when you talk about these cloud platforms. And since you have option of availability and disaster recovery, data backup options, downtime is very minimal if it happens, and your data is very secure there. Since you have ability to actually take backup of your data, you can always stay assured that your data can be restored even if you lose your data. To give you one more example, we talk about Netflix, right? We stream our data regularly. So when we stream data on Netflix, it is rare that Netflix goes down. Even if it goes down, it is up and running for us, right? We do not have to worry about the outages there. And Netflix itself resides on AWS. That tells you what kind of service or what kind of storage and what kind of different mechanisms they have actually to prevent downtime and have security issues, or to prevent security issues rather. So do we have downtime and security issues? See, there's always a possibility, but that is very, very, very minimal and very rare. I don't need cloud at all. Now, this is one of those myths that I've come across, and people saying that I just do not need cloud. Maybe from a business perspective, you do not for now, but you've been already using cloud, whether you're posting a Facebook image or anything, right? Because it is using cloud. Other things than that, see, we all have been hit by corona pandemic right now, right? What are we doing? We are sitting at home and working. It's been like 4 months now that I haven't hit my office. I've been working from home, and I've been actually working a lot. And I'm sure that is true with many of you, right? How are you actually working on your office stuff? Most of you are using cloud, at least the ones who work in IT or fields that require you to be online all the time, right? My brother is a public relations officer, and he too is working from home. His company that never used laptops to this greater extent have ensured that all the employees have laptop now. Using internet and using all these cloud platforms, they can communicate with each other with the apps that use these cloud platforms. So do you need cloud? Do you not need cloud? You can debate that. But to be very frank, the future is very much towards cloud computing, at least for next decade or so, until something new comes up. So these are some of the myths, right? I've been talking about these myths very personally, as if cloud is something that I own, but that is how cloud computing is to me. The love for it comes naturally. Okay. So, these were some of the myths that I feel that I could throw more light on. Debatable for some, but yeah, that is how it is. So this was about cloud storage myths. Let's now go ahead and talk about cloud storage services on AWS. Finally, we have reached this slide. Let's try and talk about this. Okay. So guys, when you talk about cloud storage services, right? So AWS offers following kind of cloud storage services. Now, these are some of those. There are other services as well. We will discuss some of those too. Do not worry. So when you talk about cloud storages or AWS cloud storage services rather, these are the major ones. First one is your block storage. So the first two services that you see are block stores. The next two are your object stores. And the third one is your EFS, which is a file store at the bottom of the screen. Apart from that, there are some services that let you move your data physically from one data center to the other, like your Snowmobile and Snowmobile. We'll talk about that. Do not worry. Let's try and understand the services that are there on the screen first, and then I'll actually go ahead and talk about the ones that are not there on the screen. So when you talk about EBS, it is Elastic Block Store, a type of block storage. So when you say a block store, this is a storage that comes in the form of blocks, and it needs a virtual machine or a host machine to which it can connect to. Okay. To give you an example, the hard drive that you connect to your system, right? It's a good example of block store. Okay. So on cloud, you have, or on AWS cloud, you have these services. So EBS is something that we saw, right? So when I launched an instance, it came up with a storage, right? That was attached to it. And when I deleted that instance, even the storage that was attached to it got deleted, right? So that was an attached storage that came in with my EC2 instance. Okay. So this kind of storage is called as ephemeral storage. Okay. So this needs an instance to survive, a host machine to survive, and it exists only as long as the host machine is there with you. Okay. So if you delete the host machine, the storage will go. The other storage that was, I also showed you that we can create volume, right? So this volume is something that do not require a host machine. Okay. The volumes are same, whether you talk about ephemeral or the EBS that you see on the screen. I mean, both work similarly, but the one or the ephemeral one that comes attached with EC2, it gets deleted when the instance is deleted. So all the data that was there on it, it would also get deleted. But if I take a backup of it, or if I have created a separate volume which was not connected to the instance, it is persistent in nature. It is not necessary, or it will not happen that if I delete the EC2 instance, the volume, persistent volume that I created separately would also delete. Why? Because it is a separate entity. It can survive without an instance, but if you want to use it, you'll have to connect it to some instance. Okay. And detach it again to save it. Okay. So this is what your EBS is. I unfortunately did not talk a lot about it when we launched the EC2 instance, but do not worry. As we get back into the demo, I'll talk about it again. Okay. Then you have your object storage. So here, all your storage files are treated as objects, and these files get stored in a folder. The folder is called as your bucket. Okay. So what you see on screen is two types of storages. One is your Amazon S3 storage. The other one is your Amazon Glacier storage. So your Amazon S3 storage is a hot storage. So when I say a hot storage, it is that storage that basically stores data that needs quick retrieval or storage. So I can instantly put in my data there, delete it or connect it to some resource and start processing it, right? So that is why this data is accessible right away. So you also have to note one more thing. It is also a costlier source of data. Why? Because retrieval time is higher here. The other storage that you see on the screen is Amazon Glacier. From the name Glacier, you can make out that glaciers are cold, right? We are talking about ice glaciers here, right? So these are cold in nature. So Amazon S3 is hot in nature. When you talk about Glacier, it is cold in nature. Why is that? Because it stores archival data. Do you know what archives are? Archives are that set of data that you do not actually go ahead and take a look at regularly. So to give you an example, it's been a while to that as well. So I was creating my passport. It was in 2013-14 if I'm not wrong. So I needed my birth certificate, something I did not have a copy to. So for that, I actually had to go to a hospital where I was born. And when I went there, I realized that that hospital existed no longer. So I was in a jiffy because I could not get my birth certificate. I had to put in extra efforts to get my birth certificate, something that you can do in India, right? We call it jugaad lagana in Hindi. So that means basically making arrangements to some under the table arrangements to get your job done. So this is what the point that I'm trying to make here is. I do not want to digress from the main subject. So the point that I'm trying to make here is, the birth certificate is something that I might not go to the hospital to get every day, right? So if you go to a hospital, not every data that is stored in hospital is something that you'll need every day. Same with government offices as well. And if I go to a hospital, it's not that I say, give me my birth certificate and that person will say, oh, come here, take it and go away. Right? Nowadays, with everything going online, that is possible. But I still belong to the ages where we used to use written documents as well. So to find a particular document, these people used to take a day or two. So when I apply for it, I had to be in a situation where I could actually go back and collect the data in a couple of days' time, right? So the point I'm trying to make here is, when you talk about archival data, it is this kind of data, something that you might not access right away, or you are certain that you might not get access to it right away. So when you store that kind of data, you can use something like Glacier. Why? One, it comes at a cheaper price compared to S3. Now, why does it come at a cheaper price compared to S3? Since it is archival data, you cannot retrieve this data like right away. It takes few hours for you to actually go ahead and retrieve this data. So we store only that data that is not very important for us, or we do not need immediate access to that data there. So that is what Glacier is. It stores archival data for you. And then you have your EFS. So basically, when you are dealing with file systems, what kind of storage would you use when you use AWS? You'll go for EFS. It is Elastic File System for you. I also mentioned that there are other kinds of storages that AWS offers to you. Now, what are those other kinds of storages that AWS offers to you, right? We cannot exactly call it storage, but these are basically data movement mechanism or data storage movement mechanism that AWS offers. Now, AWS Snowball is one thing. So basically, it is something that holds your data physically. You have a hard drive, right? Now, let's assume, I'll give you one more example here. Back then, if I go like 5, 6, 7 years back, if I needed to get some series or movies that I wanted to watch, so I used to connect. I used to visit a friend who always had all the data stored with him. Used to give him my pen drive, copy all the data that I wanted, and I used to move it to my system and watch it, right? Because back then, we could not stream this data this easily, right? So we had to actually go ahead and use physical devices to move data. Okay. So when you talk about moving short data like images, messages, mails, you can do that online, and it was possible back then as well. So that is something that you can do over the network easily, but in some situations you might be required to move a large amount of data, and if you are to move it physically, right, you always not over the network. In that case, you can use a service like Snowball, which lets you move your data physically. Snowmobile is something that lets you move a larger amount of data, something that would be required, or that would require a proper mobile to move it. So these services basically let you move your data when it is in smaller amount compared to the Snowmobile. You can move it through Snowball. If it is very large in size, like a data center size of data, you move it through Snowmobile, which physically moves data from one location to the other. Okay. So this was about your services like cloud storage services that AWS has to offer to you. Okay. Let's just go ahead and take a look at these services one by one. Okay. So first on our screen, we have Elastic Block Store. I do not want to talk about Elastic Block Store first. First, let us talk about S3, and then we'll come back to Elastic Block Store. Okay. So we'll talk about S3, take a look at its demo, and then we'll actually go back and talk about EBS. So S3, Amazon S3 stands for Simple Storage Service. Okay. That is SSS, and that is why it is called as S3 to make it more appealing. It's a simple web services, or basically has simple web services interface is what the definition says. I'm never good with the definitions. Let's go through that and then I'll break it down for you in simpler words. Okay. So what the definition says is S3 has a simple web services interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. Okay. So basically what you're doing here is you are using a web interface. We'll get into the demo part. I'll show you how to create buckets and stuff like that. Okay. You'll get to know how easy it is. So you can use this web interface, create these folders, these buckets for you, and you can store and retrieve your data from there with ease, just using your internet. What are some of its important features? We have flexibility, right? We have durability. We have availability, cost efficiency, security, and scalability. So durability and flexibility, I'll give you numbers on these. Do not worry about that. Okay. But we've talked about some of these features at length, what scalability is, what security is, and all those apply to your Amazon S3 as well. Just to throw a light from a normal perspective, secure, it is very secure. You can actually decide who gets to access your bucket, who doesn't. You can set rules on it. You can even set in rules as in how do you want to move your data in cycles, stored data in cycles. Again, we'll discuss this in the demo part. Do not worry about it. Okay. So we can actually ensure that our buckets and our data in the S3 service is very secure. Cost efficient. Again, it is very cost efficient. Yes, it charges you a lot, but you have a mechanism where you can move your data to Glacier. If you feel that your data is not being used frequently and it is costing you more, you can first move it to infrequent access data store in S3, and then you can actually move to Glacier, where you would be charged according to the rates of Glacier and infrequent access, which are cheaper than standard S3 charges. Okay. So cost efficient, yes, it is very cost efficient. Scalable, yes, it scales and you can store a lot of data here as well. Durability is something we'll discuss later. Okay. Available, yes, you can take backup of your data. So data is available and you have quite a few options. So hence it is highly flexible as well. Okay. So how does S3 work exactly? When you talk about Amazon S3, you can store data in the form of buckets and objects. So the definition is same, if I'm not wrong, what you see on the screen. Let's just talk about buckets and objects. Okay. So when you talk about buckets and objects, right? Buckets are nothing but your containers that hold your S3 data. Okay. So, the data can be files, images and stuff like that, right? Multimedia sources as well. So your object is nothing but your data that you're storing in your buckets, right? So the data that you store always comes in with your key and version ID. So you can actually have versioning to your data. Let me see if we have something called as versioning in the next slides. I'll talk about it. If not, I'll talk about it in the demo part, as in what versioning is, because it is a very important topic when you talk about S3 data. Okay, the presentation isn't in the best of formats. Forgive me for that. Okay, so Amazon S3 cross-region replication. Okay, so it is nothing but it is an ability using which you can automatically and asynchronously copy your objects across buckets that are based in different regions. So buckets are configured for cross-region replication, and you can also automate this process basically. So basically, let's assume that I have 2 buckets based in different regions, or I have 2 different buckets, right? So I can set up policies that ensure that after a particular action trigger or amount of time, my data from one bucket gets replicated into the other bucket. So this ensures my data is secure, right? So if one of the buckets goes down, I will have a backup of it in the other bucket. Okay. So this was about my S3 cross-region replication. Okay. Versioning, it's there. So we'll discuss this, do not worry. So we'll take a look at it in the demo part as well, but let's talk about it. So guys, when you talk about versioning, it is nothing but maintaining different versions of a particular file. Now there could be a situation where my file got changed, right? And once I changed the data, I re-uploaded it to my S3 bucket, which already had the same file. So when I restore that bucket, so I will, if versioning is activated on my bucket, I'll tell you what it is, do not worry. If versioning is activated on my bucket, and if I re-upload the same file again, so what it will do is it will maintain a copy of the latest file that I uploaded. Say for example, my first document had an ID 123333, right? Then I stored same file again, but with modifications in it. So its new ID would be 4323333. If versioning is activated on my bucket, if there's a situation where I feel that I needed previous version of the file, I just click on that file and it will give me multiple version IDs. So I can choose the previous version ID as well. So when I say versioning, what it does is basically S3 keeps both the versions of my file with it. So I can always go back and refer to the older versions as well. Okay, so this was about versioning, as in what versioning is, right? I mean, if there are multiple versions of a particular file that you want to maintain, you can do that by using Amazon S3 versioning. So we'll see this as we would get into the demo part. Let's just go ahead and talk about some other features about S3 as well, right? So we've discussed certain pointers saying that what kind of storage S3 offers. We've discussed about what kind of features AWS offers in general, right? We say that it is highly reliable, right? So if you talk about its durability, it's pretty visible here, right? It's 99.99%. Whether you talk about the standard, infrequent or Glacier, okay? We'll discuss these pointers. Do not worry about that. But even availability is 99.99. And if you take a look at the actual number, it is 99.7 to 9 times 99999. So that tells you how deep it goes when you talk about its general durability and availability as well, right? So, going away from the topic that we were discussing, let's just understand what are the types of storages that AWS S3 offers to us, right? There are different classes in it. So when you talk about these classes in general, so you have the standard one, which is most commonly used or by default used, right? Then you have your standard infrequent access. And finally, you have your Glacier access. So when you say standard, this is where standard charges apply, and you have normal or the standard input, output, or even retrieval rather. Okay. But when you talk about infrequent access, this is what we are talking about, data which we do not access right away. Okay. So it's, when you talk about retrieving this data, it would take longer than your standard, standard storage that AWS S3 class has to offer to you. And then you have your Glacier. Now this is where you actually go ahead and store your archival data. We'll discuss Glacier in detail once we get into the AWS Glacier part. But this is where we actually store our archival data that we do not access frequently. So the important point that you need to note here is when you talk about an object size, your infrequent storage is the only one that requires minimum size for you to have. That is, it is 128 KB in general, right? So it has to be minimum of that size. When you talk about your S3 classes like standard and Glacier, there's no limit there. But obviously there has to be some size because you'll store something there end of the day, right? Apart from that, if you talk about minimum storage duration, standard duration or the standard S3 class will actually have no minimum duration. And that's obvious as well because it is the costliest one. So you will end up paying whatever money you do. But when are these cycles coming into picture? I mean, the standard one, the infrequent one, and the Glacier one. So what S3 does for you is it has a particular kind of life cycle, right? Where let's assume that I'm using certain data that I need on daily basis. I know I have to access it whether I like it or not. So I would be putting it at or in a storage where it can be accessed right away. Okay, whenever I need it. That is why this is where standard storage comes into picture when you talk about S3 classes. And it is the costlier one compared to the other two. If you talk about infrequent access, let's assume that there is some data that you are not accessing frequently. You can put that in infrequent access place where you have to have the data there for at least 30 days. Okay. And then when you talk about Glacier, it has to be there for at least 90 days. The fact that you're putting your data in there for 90 days, they know that you'll be using this service for this longer duration. And that is why it is cheaper. Another important point that you need to notice the retrieval rate. So first byte latency is milliseconds for the first two methods, right? So when you say milliseconds latency, that means you can retrieve this data for the first byte in this lesser time. Now, depending upon the size of remaining data, this time might vary, right? But if you talk about Glacier in particular, it takes like 3 to 5 hours. So it's written as standard as 4 hours here. So it takes like 3 to 4 hours for you to actually retrieve your data, right? And that is if you follow the normal procedure. So there are expedited extraction of data there and the normal extraction of data. So when you talk about normal extraction of data, it will take at least 4 hours for you to retrieve that data. So that is why it's called as cold storage as well. And that is why it is cheaper compared to the other two. So if you can see retrieval fees, standard access, you are not charged anything for retrieving your data. And that is obvious, right? I mean, because you are already paying for a storage that you want to use frequently and you are not going to pay money if you want to frequently store or remove the data from there. But the hindsight to this is that you'll be actually ending up paying more money because you are storing your data in the costliest vault here. The other two, however, these are cheaper, but if you want to retrieve your data, you'll be charged on per GB rates. And these prices vary depending upon how much data and how frequently or how quickly do you want to actually access that data. So when you talk about storing it, it is very cheap compared to these things. And since we are storing archival data in the other two, that means data that we do not access frequently, that means we'll be retrieving this data once in a while, right? So that is why paying this per GB fees is also not a problem here. So these are the types of classes that AWS S3 has to offer to us. Let's see what is the next topic here. Okay, so we are into the demo part. Let's do one thing. Let's quickly go ahead and see how S3 works. Then we would come back, understand what Glacier is, how it works, right? And we'll also talk about EBS, something that I said we'll discuss later, right? So let's just quickly get into the S3 demo part. For that, I'll have to go ahead and log into my console and search for AWS console. So there you go. It says you are logged out. Let me quickly just go ahead and log in. And let's see how S3 works, right? So when you talk about S3, so as I've already mentioned, you can search for your service under the storage domain here. You can type it here. It is even available in your history if you've used it recently, right? So these are some of the services that I've used, whether it's SageMaker, Elastic, Beanstalk, Cloudfront, S3, right? So let's just go ahead and open S3 for now. What it says is we've permanently re-enabled the previous version of S3 console while we continue to improve S3 console. Okay, they keep on experimenting with the consoles that they have. So there's a possibility that if you see this demo and if you go back, the console might change. That is how AWS is. They're not major changes, but they keep playing with the console. So you can see there are quite a few buckets that I've created. Not all of these buckets are something that I use. We can actually go ahead and delete it. I'll show you how to delete one. So when I try to delete a bucket, it will ask me for the name of my bucket. S3 bucket demo 321 is the name here, right? So if I say delete, so it will ask me to enter the name S3 bucket demo 3 to 1. And naming convention is also particular here. You are not allowed to use caps when you actually go ahead and create an S3 bucket. Sample demo 3 to 1, sample demo 3 to 1. So I will delete this one as well. And I'll let the Elastic Beanstalk buckets be there. It's a pain to actually delete those. I think I've left some of my instance open, up and running, and that is why I cannot delete these buckets, because these fall under a particular resource group. Okay, so that is why I'm not able to delete these. I'm not deleting them for now. Let's just go ahead and create a new one. Okay, I say create a bucket. Let's call it. Okay, see, it says you cannot use caps here, right? I again by mistake I put a caps there. Let's say demo bucket for today. Let's call it demo bucket. Let's see whether it accepts this name. The probability of getting these kind of names is very less, because these names are unique across the whole globe. So if somebody's used this name, you cannot actually. So in Mumbai Pacific rather, it is going to get created. See, its access is global, right? I mean, whenever you try to create a bucket or you are in S3, the access always shows global. But where is it residing right now? It is in Asia Pacific, Mumbai. So let's just say next. See, I told you it would be rare that we get this kind of bucket name, and it has denied us that, right? Let's just use this standard formula, add in 3 to 1 to it, and just say next. Okay, demo bucket 3 to 1 also exists. 3 to 1 one more time. Now let's just see. Now it should be definitely there, right? So versioning, do I want to keep versioning on? I can actually go back and activate it again if I want. Server logs, something that I do not need. So I'm not going to activate it here because I want to show you how to maintain the versions of the files that you upload, right? Let's just say next for now. Block all accesses. Do I want it to be an open bucket? Let's just say it's an open bucket. Block all access may result in bucket and objects within becoming public. Yes, let them be public for now. If we are to do anything, I do not want this bucket to be access restricted. So I'm not going to keep it restricted, because then you have to come back, look for it. What access do you need to give it and all those things. So let's not get through all that pain, right? I mean, why waste our time doing all those things? So let's just go ahead and see whether the bucket is there. It's up and ready here for our use. So let's just say open, right? So there are certain things that let us look into those first. Then we'll see how to put in objects here and other things, right? So when you talk about properties in general, right? You see versioning, something that we are going to enable. Okay. Server access login, website, static website hosting. So basically when you host a website, right? No matter what application you run, you are going to store your data somewhere, right? If it's residing on an instance, EBS storage might be used for the data that is concerned with the instance there. But whatever application data that you're talking about, you need to store it somewhere, right? So this is where your S3 bucket comes into picture. So when you talk about content delivery networks as well, right? So you would be needing a particular server location where you host your data. So when you create that central point, in that case too, your data gets stored in your S3. You have an option of putting your data in S3. So there are quite a few other applications that you'd be using during the course of your usage with AWS, and you'd realize that S3 is one of the most reliable storages where you actually go ahead and store all this data that you have there with you. Okay. So object level logging, default encryption. This is something that AWS lets you do on its own. So you do not have to tinker with it. If it's disabled, that means it's not going to happen. But if you enable it, your data would get encrypted, right? I've mentioned about the fact that when you talk about AWS, your security is taken care of, whether you talk about it being over the network or inside an app or even physically, right? So when you talk about encryption, it is something that ensures that when your data moves through the network, right? It is secure while it is moving through the network, and the firewalls are the gateways that you have, right? Not the gateways, the firewalls rather. So firewalls ensure that even at the entry, check-in and check-out points, your data do not gets corrupted in any possible way. So that is what default encryption lets you do if you activate it, something that we are not going to do for now. Okay. Permissions. Okay. So this is where I've actually made it public, right? It says, do you want to block public access? No. For now, let it be open. If you want to, you can. So what you can also do here is create a bucket policy. Okay. So when you click on bucket policy, I I can actually go ahead, when you say ARN, it is the path to my bucket. Okay. So I can decide what kind of bucket policy that I want to use. So we just talked about cross-region replication as well, right? CRR. So when you talk about CRR, you are planning to replicate your data from a bucket in one particular region to a bucket in the other region, right? So this is where this bucket policy comes into picture. You need to have a policy that ensures that when you actually make a copy of a data in a particular bucket, when do you want to or how do you want to replicate it to the other bucket? So this is where something like bucket policy comes into picture. The applications are wider, but this is just one example as to what you can do with bucket policies. So I believe a gist or a general idea as to what a bucket policy is and what you can do with it is clear to you people in a nutshell, right? So then you have CORS. To be very frank, I've never used CORS. So I do not have a lot of idea about it. So I'm not going to just go ahead and talk about it. So let's just skip this for now. Okay. And then you have your management. In management, you have life cycle. So when you say add a life cycle here, right? So we just discussed those three types of storage classes that we have. So when you talk about lifecycle rule, what it does is it gives you the freedom to decide as in, okay, if this data is residing in my S3 normal standard access, right? In that case, if I'm not using this data for this longer duration, why don't you instead move it to infrequent access? And after a month's time, even if it is not getting used in the infrequent access, then move it to my Glacier storage. So what that would do is, instead of that data lying useless or not being used in a particular class, it would actually move to the other level, other transitioning class that AWS offers to you, and you would be charged at a cheaper rate, at an optimized rate, right? So you won't end up paying the money that you would for a standard class otherwise, right? So you can actually go ahead and add a name of a rule. This is a general procedure that we follow here. Okay. So once you fill in all this data, next you get into the transition phase. So which class do you want to transition to? Do you directly want to transition to your infrequent access, right? Or do you want to move back to your standard access? You can decide all those things here. Okay. In the transitions, expiration is the time duration that you set in, right? I mean, after what duration do you want to move your data into the other storage class? And finally, you review all the things and you actually go ahead and approve this process. So this is how you actually go ahead and create a lifecycle rule when you talk about moving your data from standard access to infrequent to your Glacier or vice versa, right? So this is about the lifecycle rule. Now let us just go back to the overview part, right? Let me show you how to actually go ahead and do these things or upload certain files to it, right? I mean, since we are talking about S3, let's see what happens here actually. So this is my bucket that I have with me, right? And in this bucket, I can actually go ahead and add a particular file. Let's say I add a file called as 1. Okay, 1.png. So that's a snapshot that I have. It says next. I can actually set up rules here and here. Okay, set permissions, set properties, review it, and then I can actually publish. If I go to previous, you can see all the information here. So by default, it is going into my standard frequently accessed data, right? So I can decide what tier do I want to move my data into. Do I want to move it to Glacier directly? I can do that as well here, right? Glacier Deep Archive is something that is one facility that AWS provides you, or EC2 rather. It's not EC2, S3 rather. So see, there are options here that you want to choose into if you want to, right? And this is where you set in permissions, right? It says user ID. Apart from that, you can access or decide the access to an object. Now there's an object level access as well that you have, right? Once we get into the Cloudfront part, I'll discuss why access is important. I'll show it to you in the form of demo. So basically what happens is when you say an object access, let us say that I have a particular object that is being hosted on a particular website for me. So to do that, what I do is I use a particular domain name to access that data, right? So if these objects are not public, if they are private, I might not be able to access them through an HTTP or HTTPS mode if I have not set the properties correctly. So that is why setting up right access is important. In our case, we are giving it public access to everything that we are doing right now, right? So it should not be a concern for us. Let's just go ahead and say upload. So once I go ahead and actually upload my data would be visible to me here. Okay, 100% successful, but why can I not see my object? This should have been here by now. It says 2 success, 1 in progress. Shall we refresh it? Normally it does not take this long, it happens quicker. Let me upload one more file. Let's just say select a file and let's just say upload. I just say upload. The bucket is empty. Upload new objects. Okay, this is new. It says it's successful and it has uploaded the file that I was looking for, but then why do I not see it, right? I should be able to see it. Let's just close this and let's see if there's some problem with it. This is really the first time that I've experienced something like this. Never seen anything like this happening. So let's just go back and use some other bucket. Maybe there's some problem with the bucket I have. Let me just go ahead and say I create a folder. Okay, let's just upload a file instead. Let me choose a file. And this time I'm going to choose a different file just for the sake of simplicity. Yeah, standard storage, successful. Do not create a folder. Refresh this thing. What is happening to my buckets? Nope. Still a no. Let me just create a folder and see if we can upload it there. Okay, so a folder is created at least, that is for sure. It says successful, 1 error. There's some error here. 100% failed. And why is that? Let's view the details. Options request denied. Okay. Let's see if we can upload a file here. There's no object in this path. Next, read, write, manage permissions, standard frequently accessed data. Next, upload, and 1 in progress it says now. Last time it had shown success. In the previous attempt it showed failure. Upload successful it says. Let's just go ahead and create a new bucket. Probably I messed it up when you talk about giving it certain access. So let's just say demo2 today, and let's just say next. Let's just say create. Demo2 today. Now let's upload a file here. See if it works for us. and I say upload. So hopefully we get something uploaded this time round. Why are our buckets not getting uploaded, or why are our objects not getting uploaded? So for that we'll have to get into the properties part, or maybe go back here, select a particular bucket and edit public access block. Turning this on is same thing as turning all 4 settings below on. Block public access, say save, I say confirm, and I say confirm here. So what it says now here is, if I select this bucket name, if I close this part, say save, say confirm again, okay, so this was successful for us. Now let's see if we can upload a file here. For that I'm gonna just go ahead and choose another file. I'm gonna say upload. If this is something weird that is happening, this is something that absolutely never happens when you use an S3 bucket. But do not worry, we will get this fixed later, right? We'll come back to this demo and we'll talk about it as in why is this happening. For now, let's skip this part, okay? So the gist is clear. Once you actually go ahead and upload a file here, it becomes visible to you right away here, and then you can do all those things. I mean, I was trying to show you how versioning works, but since we are not able to upload any files here for some reason, I do not understand why that is happening, because our accesses are okay, but for some reason it says you are not permitted to upload anything. If you click here, options request denied, okay? So you cannot upload this for some reason. I'll get this fixed and then we can actually go back and take a look at how these things are happening or how it is working in person, okay? Okay, so let's just go ahead and talk about something else. I'll go back to the presentation. We'll talk about the other pointers, right? And later I'll come back to show you how this part works as well. So let's try and understand the other types of storages that we have. I'll talk about Glacier and then I'll come back and talk about EBS, and then we'll see a demo for both. Okay. So when you talk about Glacier in particular, right? So as I've already mentioned, we have 3 S3 classes with us. So Glacier is a part of it. But when you treat Glacier as an object storage, think of it as a storage that is cold in nature. So when you say cold storage, right? So what happens with cold storage is basically we are talking about data that we do not need to access like right away. To give you an example, let's see, or let's discuss this scenario. Okay. If you go to hospitals, right? I mean, if you go ahead and tell them that, okay, I need my birth certificate, especially this happens in India. If you're listening to me from some other part of the world, so this could be different for you. But in India, it's like if you want to get your birth certificate, and especially if you go to small places, small towns, and if you go there and tell them that give me my birth certificate, they'll say come back a couple of days later. Probably they might not have resources to retrieve it for you right away, or it might be documented in such a form that it takes time for them to actually go ahead and get hold of the data, right? This is something that you cannot get right away. To give you my personal experience, it was in 2014-15, if I'm not wrong, that I was applying for a passport and I needed my birth certificate. So I happened to visit the hospital that I wanted to, and I realized that the hospital was closed there. So I had to actually work under the table to get my birth certificate up and ready. So the point that I'm trying to make here is not all the data that you access is something that you'll be needing every day, right? The day I went to get a copy of my birth certificate, it was already like 20 plus years of my life that had passed already, right? So I don't think anybody from my family might have visited that place. So what this tells you is there could be data that you might not explore every day, right? Some records that stay. Hospital is one example that I gave you. Not all the data in your database is something that you'd be exploring or using every day, right? You'll go there once in a while to get some receipt or something, right? If you visit a doctor like in 3 months time, you'll access that after that duration, right? So this kind of data is something that you do not need every day. Let's assume that your hospital maintains a data store for this data that is very costly in nature, right? They'll have to increase the fees they charge from you, right? The reason for that is some of the storages where you access data frequently are very costly. So in order to make sure that this data is not put in storages that are costly and you end up paying a lot of money, instead what you can do is you can always go ahead and opt for storages like Amazon Glacier. Now Amazon Glacier is a kind of storage that stores vault data, archival data, or data that does not get accessed frequently. Something that you can put in there and stay assured that even if you want it, you would be able to do without it. So this is not business or mission critical data, something that you store in your S3, something that needs processing in real time. So this is where your Glacier comes into picture. Now, when you talk about Glacier, right, let's see if there are any other features that we need to discuss. But if you take a look at the definition, I've actually gone ahead and talked about all the pointers here. So let's just go ahead and talk about something else. This is the data that I would rather discuss, right? Or these are the pointers that I rather discuss. So when I say that your storage is cheaper with Amazon Glacier, what am I trying to refer to? So here, when you retrieve your data, there are two options that you have. One is your expedited retrieval. This is the case. Let's assume that you want your data right away, frequently, right? So in case you put in your data there and you are being charged at a minimal level because you've stored it there for on a subscription basis, right? Something that you'd be using for like, or not using for something like 3 months, 4 months. But then you go there someday and say that, okay, I need this data. So they'll come and tell you that the standard retrieval period here is like 4 hours. So you can retrieve this data within 4 hours, but then you have a requirement where you feel that you need the data like now or in minimal amount of time that you can retrieve that data in. So in that case, you would be charged at an expedited rate, okay, an increased rate for retrieving that particular set of data. So this is what your data retrieval might be like when you talk about using Amazon Glacier or AWS Glacier for that matter's sake. What are the other features it offers? Glacier Select. Glacier Select lets you operate and work on some selected amount of data that you want to. Let's assume that you define something in your Glacier Select. This is the data that would be available to you quicker if you want to actually go ahead and access that piece of data. Then we have other services that AWS Storage supports. One is your AWS Snowball and Direct Connect. So as the name suggests, Snowball is basically, think of it as a smaller storage, like a ball that lets you store and move your data physically. It is not always possible for you to actually move your data from one data center to the other over the network. Why? Because the volume of data could be larger. So in that case, if you want to avoid your network latency or there are other security concerns that you have, you can actually move your data physically. That is something can be done using Snowball. Now Snowball is like a hard drive that you're moving physically, just like you copy, at least you used to copy movies, right? If you go back like 5 years from now, we used to copy our movies into hard drives. I used to do that at least, and then move it to my system and watch it. With the streaming part these days, we don't do that, but you can actually physically move your data with your hard drives, right? So that is something your Snowball lets you do. Direct Connect is something that lets you connect 2 points for data movement, okay, with security. You have something called a Snowball as well, or Snowmobile rather, which is similar to Snowball but larger in size. Something that lets you move huge data center data into or from one data center to the other. So when you talk about Amazon Glacier, it actually lets you readily connect or basically readily integrate with Snowball, Direct Connect and Snowmobile with ease. You have vault access policies and inventory as well. Vault lock and vault access control. Now what do these things do is they let you make sure that your vault is secured, locked. Unless and until you get in eventual or proper credentials, you won't be able to log into your vault. Vault is something that we'll discuss. Do not worry about that. I believe it was there in the previous slide. We missed out on that. We'll talk about that. And then it ensures that your data is highly durable and reliable. Okay. So I believe we've discussed availability and reliability already. So let's not get into security services for now. Let's go back quickly and discuss these pointers. So just we have buckets and objects when you talk about S3. When we talk about storage services or Glacier in particular, here we have archives. Archives are nothing but your data that you are not going to access right away. And vaults are something as folders where you actually go ahead and put in your data when you talk about Glacier. Okay. So this was about Glacier. Let's quickly talk about EBS first and then we'll get into the demo part again. So for EBS, I'll have to walk back fairly long. This is where we have EBS. I had said that we'll talk about EBS in the other half, right? Or once we are done with the S3 part. Unfortunately, we cannot or could not get into the S3 demo. We'll figure that out later and see why we could not see or do that, right? So when you talk about Elastic Block Store in particular, or EBS, this is that storage that is block in nature. It is a storage which comes in the form of blocks where you can store your data. But guys, this is more of a symbiote kind of a relationship between an instance and your storage, or I would say give and take kind of a relationship. So for your block storage to exist, not to exist, but to work at least, we need an instance that it can get attached to. So if you have to access that storage, you'll need an instance. Say for example, your hard drive, right? I mean, you cannot just play something on your hard drive, can you? You need some system that is connected to it. You can connect it to your TV sets, you can connect it to your laptop. And once you do that, it becomes active. You can connect it even to some other devices as well. So where you can actually go ahead and watch the images, the files or the videos that you put forth there, right? So when you talk about Elastic Block Store, it is that kind of a storage where you actually go ahead and connect your device to a system, and then you can access that device or that particular storage. So when you talk about Elastic Block Store, it comes in two types, two natures, right? So I had launched an EC2 instance to show you how it works, but we did not discuss that in detail because we were focusing on the compute part then. We'll again go back to the storage part and we'll talk about it in detail. So when you talk about persistent storage, persistent as the nature or the name suggests, it is basically something that persists even without its other supporting system. So in this case, when you actually go ahead and launch an EC2 instance, a volume or some storage would come attached to it by default, right? So if I delete this instance, that volume will also go with it. But if I create a volume separately, right? So that volume would exist irrespective of if I delete the instance or not. Yes, to access that volume, you need an instance attached to it, but for its existence, you might not need an instance always. So the instance which survives even without the volume which survives even without the instance, that is called as persistent volume in nature. This is something called as an attached volume, not the root volume. Root volume, on the other hand, by default, it comes as ephemeral in nature. That means if my instance ceases to exist, so will the volume that is attached to it. I have an option of making sure that I can actually convert this ephemeral instance or volume to persistent, something that we'll see once we get into the demo part. Okay. So that is what your Elastic Block Store is in general. What are the types that AWS offers to you or EBS volumes offer to you? Basically, you have your two types, right? One is your SSD and the other one is your HDD. So when you say your solid state disk drives, basically these are something that are used for high IOPS actions. Okay. So these give you higher performance and they come by default attached to your instance. SDD is something that is your secondary volume, just like your systems, right? I mean, to give you an example, if I have a hard disk drive that is attached to my system, let's assume that I want to throw my system away because it's not working well for me. I can remove this storage, right? And throw the system away. So I can use the storage somewhere else. But let's assume that I throw my system away with the storage. So my storage will also go to trash, right? I won't be able to use that. So SDD is something that gives you an option of making sure that you have secondary volumes that can be attached or detached from your instance. Okay. SSD is something that mostly comes attached with your instance. Again, this is something we'll see in the demo part. Okay. So when you talk about SSD in general, these are used for high IOPS performance. There are two types here. One is your general purpose. Okay. And the other one is your provisioned IOPS. So when you say IOPS, it stands for your input output per second, right? So how do you decide that? So the size of your volume would decide how good or IOPS can you use, okay? What kind of performance can you get? The more the size, the more is the probability of you getting better performance, okay? But then again, there are certain defined IOPS that come associated with the SSD based volumes that you have. So if you talk about general purpose, these are used for standard IOPS performance, where you need good performance. Okay. So it is around 16,000 IOPS if I'm not wrong. So you can get a performance up to this level. Let's assume you want more performance than this. So this is where you can use a provisioned IOPS. So that is above 16,000. How high can it go? It can go somewhere around 64,000 IOPS. Okay. If you talk about its performance. Let's assume that you need consistent performance, but at a lower IOPS. This is where your HDD based devices come into picture. Now, what do these devices do is they give you two options. One is your throughput optimized SDD. Again, good performance, but IOPS is less. It is as low as 500 IOPS. So that is max it can go to. Cold HDD on the other hand is more low than this. So it's mostly for that data that you do not access frequently because it's called as cold, right? So you can have like 250 IOPS here. So this is what your cold HDD or basically your SDD based storages are like. Let's get into the demo part and see how what can we do with the storages that we have. Let's hope that our EC2 or rather AWS console works smoothly. For some reason it wasn't working well enough, right? Okay, so let's just go ahead and talk about EBS. For that I'll have to get into EC2. And meanwhile, let me just, okay, something is happening here. Every place I'm getting, everywhere I'm getting some updates, right? So probably AWS is under the process of updating certain things. Let's just go ahead and see what we can do. So we've talked about instances, right? As in how to launch it, what all can we do with it and stuff like that. So we are not going to stick around and talk about those pointers. We are going to launch an instance and I want to show you certain things. What all can we do with it? So let's just say I say select. And in that I select the basic one. You can see that it is EBS only, right? Virtual CPU is 1, memory is 1 GB, something that I can change. Network performance low to moderate. It is a minimum instance that I'm using here. And if I get into the storage part, see guys, this is where I have an option of deciding what kind of storage I want. Do I want it to be ephemeral in nature or do I want it to be persistent in nature, right? So when I say persistent storage, it is going to stay whether the instance is not there or not, right? So you can see there's a tick here that says delete on termination. So basically if I untick it, right? So this volume would stay even if I delete the instance, right? So I have an option here. I can do that. Okay. So let's not do that for now because I think I have an attached volume already. If not, we'll create one. And I say create an instance. Just say launch. We know that we need a key pair here. Let's say create new demo, download, and I say launch my instance. So there you go. My instance would be launched now. Okay. In a couple of minutes. So by the time that happens, let's just go back to the volumes part. So I'll have to go back to EC2. And in EC2, I'm gonna go ahead and say volumes. So you can see this is the volume that is in use that got created with our instance. I can actually go ahead and say create a new one. Let's say I want 100 GB volume here. I can say create. So I can actually go ahead and detach my existing volume and attach a new one to it. Okay, so I can do that. So you see there are two volumes here, right? Now what I'm going to do is once my instance is launched, I'm going to delete my instance and we'll see that this volume is gone with it. This will stay. This is persistent in nature. Okay. Another important point that you need to know here is your snapshots. So what can I do is I can actually create a snapshot of volume that I have. Okay. So basically it is like creating a template of the volume that I have. So if I lose my instance, I'll have a snapshot of it. So I cannot actually go ahead and use a snapshot directly. I'll have to replicate that snapshot into a volume first and then attach it back to my instance. So that is what a snapshot does for us. Okay. Let's see if our instance is up and ready for launching. Okay. We are not going to get into the details of launching it. We've done that already, but I just want to see whether my instance is ready for connection. Okay. If it is ready for connection, we'll launch it and then we'll delete and we'll talk about the volumes that we have. Okay. So it's running. Let's see if I can connect to it. Download RDP, and meanwhile that happens, get the password. How? I need to choose a file. The name of my file is demo and it should be in downloads. So I say demo.pem, select and I say open, decrypt, and I say copy my password. I did that. I'm closing it. I'm gonna launch my RDP and I'm gonna say connect. Okay, yes, and the instance should be up and ready for usage, right? So the instance is performing fine, right? Like we do normally, and there should be a 30 GB of storage in this instance as we had seen last time as well. There you go, the instance is there, right? So if I come here and I say File Explorer, there you go, and there should be an attached volume to it, 30 GB, right? So we have a 30 GB volume that is attached. Let's just close this, say okay. If I come back to the volumes again, okay, there you go. The internet is working very slow today. I do not know the reason for it. Whatever it is unfortunate. See, this one is the one in use. Okay, so I'm going to go back to my EC2 dashboard, to the instance, and I'm just going to go ahead and say instant terminate. So it will delete my instance. On an EBS backed up instance, the default action for the EBS root volume to be deleted when the instance is terminated. So we ticked it again, right? So if I delete this one, my volume will also go with it. Okay, so let this thing get deleted. Meanwhile, I'm going to quickly jump and do something that does not concern this demo. I just want to see if my Elastic Beanstalk has something in it that needs deleting, right? I think there are buckets in it in my S3 where I have Elastic Beanstalk attached to it. So let's see if I have left something in Elastic Beanstalk up and running or up and working, right? So we're going to go ahead and just delete that if there's anything here. I go to applications. Okay, this is terribly slow today. Absolutely nothing is happening here. So Okay, let's not hang around here. Probably our instance would be deleted by now. So let's just see if the instance is out of our way. So if it says 0 instance, that means our instance has been terminated. So if I go back to the volumes, I'm sure there would only be one volume there, that is that 100 GB volume. There you go, the other one is deleted. We do not need this as well, so we'll just delete it, right? And I say delete. So good riddance. We neither have a volume now nor an instance, and we saw what ephemeral and persistent storage is. So similarly, if you go to Glacier, right, you have an option of creating vault and all those things there. We cannot actually go ahead and retrieve the data right now. The reason for that is I do not have a third-party tool. We need a third-party tool actually to do that if we have to do it through the console. So I can actually go ahead and create a vault here. Let's say sample. Say next. Do not enable notifications. Okay, next. Review Asia Pacific Mumbai is where the vault would be created. There you go. So I can create a vault like this, right? So I have a vault here with me. So all the information is here. What all can you do with it? What are the permissions it has and stuff like that, right? As I mentioned, you need a third-party tool to actually connect to your vault. So I'm just going to go ahead and delete it. Okay. So this was about different storage services that we had on our plate. As I've mentioned, I'll fix the storage part, right? The S3 storage part, and see why that did not work. And once we are done with the next bit, we will actually go ahead and take a look at the demo of S3 as well. Okay. Meanwhile, let's just go ahead and talk about the other services that we have on our plate. So let us go ahead and now talk about AWS Networking Services, right? So when you say networking services, so we are talking about cloud platform, and on cloud, as we know, everything is connected through a network, right? So when you say network, we are talking about a network that exists for these devices that are virtually present, right? So this network is little different from a normal network. Let's try and understand that a little more. Okay. So when you talk about AWS Networking Services, this is what the definition says, what I just explained you, right? We know that cloud connects data and applications around the world, and that is why it is very important to put this data and these applications under networks, right? So AWS provides a series of services that caters this need. Okay. So we'll understand these services that help you control the network and certain security aspects as well when you talk about cloud and AWS in particular. But before we do that, let's differentiate between what a virtual network is, what a traditional network is, right? So when you say a traditional network, so for people who have studied networking in their college, they would know that we have different layers of networking, one that exists, right? And then you have physical components that support this networking. It can be your routers, right? It can be your network wires that basically help you communicate with each other, right? So traditionally, this is how security, or rather networking, used to work. So I remember in my college, all the laptops were connected by wires. Okay. So getting one of those wires actually at home to connect multiple systems was a big thing for us, because we were doing something that was nice and something different, right? Picking up those long wires, bringing them home and doing all these things, connecting them to system and transferring data and doing a number of other things, right? So this was one example of physical network, right? I mean, when you talk about applications that still run on physical networks, then we are talking about routers that are physically present, right? And the wires that connect these routers and quite a few other things. So when you talk about traditional network, this is how it would look. But these days, with the advent of internet, even the definition of networks has changed, right? I mean, we send images through WhatsApp. And when we use WhatsApp, it is in our phone, right? We are not connecting any wire to share any data, not any pen drive to do that, right? It is happening over a network that is virtually present, right? It is actually present, but you cannot touch it physically. That is what I'm trying to make a point here. Okay. So when you talk about virtual networks, these are the best that can be used to govern your cloud services as well. Now, why is that? So when you talk about your cloud services in particular, what happens is basically we are talking about resources that are that reside in different parts of the world, right? There could be resources that reside in Mumbai. There could be resources that reside in US, right? So basically they are residing in different parts of the world, and I cannot connect resources in US and Mumbai, right? Let's assume that there's a resource in North Virginia. I cannot connect it with a resource in Mumbai through a cabled network, right? Through a physical network or a traditional network that I have. I would need a network that governs all those properties that concern that particular cloud resource or a cloud domain, right? So that is what your virtual network does. It gives you room to have a network that surrounds those particular requirements or those particular resources. So as we go further, we'd understand this concept in little more detail. Do not worry about that, okay? So one of the services that lets you do this on cloud is VPC. So when you say VPC, we are talking about virtual private cloud. So as the name suggests, this device is present virtually in your network, and it helps you connect all the resources that lie under that network. So basically what it does is it creates a bubble for your resources. Let's assume that you have 100 resources lying in a particular region or in a particular area, right? So I'll be having a bubble around it. It's called as virtual private cloud, right? This bubble gives me all the networking requirements that my system has, okay? Or my resources have. So what does the definition has to say here? It says that Amazon VPC can configure AWS services resources in virtual sub network, right? That bubble that I just mentioned. So default VPC. Now when you talk about virtual private clouds, there are two types in it. One is your default and one is your non-default. So default, as the name suggests, is something that comes attached to your resources, right? So when I create a resource, it has to be under some bubble, right? Under some network for me to move my data, to actually communicate with other resources and stuff like that, right? Or even to ensure that I put it under certain security groups, I need to have a network around it, right? So whenever a resource is created, it falls under your default VPC, okay? You can also have a non-default VPC, something where you can actually go ahead and make modifications to suit your needs of the applications. So this is about your VPC, right? Let's see how it works actually. So this is a diagram of Amazon VPC and it's working. So when you say it's working, we are talking about how resources lie. Let's assume that we are talking about EC2 instances, right? We've discussed EC2 instances, what those are. So when you say an EC2 instance, basically what happens is we are referring to a resource that lies in a particular region. Let's assume your EC2 instance is residing in Mumbai again, right? And the other one, as discussed, is residing in some other region. So when you say VPC, what VPC does is it puts both of these instances under particular region, okay? So say for example, I have a VPC, a network, okay? In this network, I have two EC2 instances as you see on your screen. So both these instances are put in different regions, as you can see. So VPC for EC2 one has a separate subnet, and the other EC2 has one more subnet. So when you say a subnet, we are talking about a subnetwork. So there's an intra network as well that is region based. So if I have a resource that lies in a particular region, it would be under a smaller bubble, okay, where all its necessary resources are there, okay, that concern that particular network. Similarly, if you have another instance in another region, it will be having a similar subnetwork, a similar VPC subnetwork, okay, that would be concerned for that other region. And now these two regions can be connected by router, right? One, they're connected over a router that is virtual in nature again. And both these regions lie under a bigger umbrella, a bigger network that's called as VPC for you. Okay. So we are having networks inside a network, basically. That is what I'm trying to convey here. And how do you communicate with each other? One, there are routers. Okay. And let's assume that you want to connect to external data, external sources. You have a gateway, internet gateway, that ensures your encrypted or your protected data moves smoothly in and out from your network to the other physical devices that are out there. So as you can see, there's internet, and through internet we are connecting to an internet gateway, and you have remote management and administration. Okay, so this was about VPC. We will get into the demo part and we'll understand what VPC is. Do not worry about that. But in a nutshell, it is a virtual network that cloud provides, right? And it provides further isolations by giving you sub networks under it as well. Okay. And all these networks are connected through routers and internet gateways to ensure that our applications are secure and good enough for working. Then we have other services, right, with AWS that are concerned networking. That is your Amazon Route 53. So when you say Route 53, we are basically referring to a resource that provides domain naming system, which is also scalable in nature. So basically when you say a domain name system, right? So what we are referring to here is we are referring to a system or a resource that basically lets us convert our data, right? Our human-like data into IP addresses that is understood by my computer. To give you one simple example, let's assume that I have a website, right? My website would be called by a particular humanly name. Let's assume that the website is for AWS tutorials. Okay. So if I name it as www.awstutorials.com. So basically this is something that is understood by me as a human, but my computer will not understand this. That is www.awstutorials.com, right? So for them to actually access the data, they are more concerned about databases or resources that are connecting to each other. And a computer understands these resources, or your systems understand these resources by the IP addresses they have. So what Route 53 does is it understands that this particular domain name is associated with these IP addresses and diverts your traffic accordingly to those IP addresses. Okay. So this is what Route 53 does for you. Now that we know what the definition is, so when you talk about Route 53, again, the other services like AWS provides, it has to be available, right? Because when you talk about domain names, you want resources that are accessible always to you, right? Apart from that, these resources have to be reliable and flexible as well. So when you talk about Route 53, it is all of these. Okay. So another service under networking domain is your Amazon Direct Connect. Okay. So when you talk about Amazon Direct Connect, it lets you actually go ahead and establish connections between your cloud platform that you have, in this case AWS, and your on-premise infrastructure, right? So this is more of a private network that is established, and what it does is it gives you better bandwidth, faster data transfer, right? And more consistent internet-based network performance. So basically this is a secured line, okay? A secured virtual line that AWS lets you establish with your on-premise infrastructure. Now, when you talk about cloud, as I mentioned, it is not always that everything that you do will be on top of cloud, right? Some of your resources would still be residing on your on-premise infrastructure, right? It's not always possible that you move everything to cloud. Let's assume that you have an application that is completely on cloud, but there's a possibility you need to connect to something that is on-premise, not on cloud. So in that case, you need a dedicated network. That dedicated network in terms of AWS is your Amazon Direct Connect. Now, what are the features it offers? Those are visible on the screen. One, it gives you good network performance, right? The other one is it has lesser bandwidth cost. Okay. Enhanced security. So now this is a particular VLAN through which you can actually ensure that it gives you more security. Again, private connectivity to Amazon VPC, ensuring more security, highly elastic in nature, and it can be operated through your Amazon Web Services Management Console. So whatever you do through Amazon Web Services Management Console, as we have seen, it is actually easy for you to work. You do not have to hard code anything, go into the backend and work on other things as well, right? So you have more of an interface that is click and drop, click and play kind of an interface when you talk about the console. And it supports easy management access using that console, and is highly compatible with different platforms as well. Okay. So these are some of the features that AWS Direct Connect has to offer to us. Okay. So let us just go ahead and get into the demo part. Okay. And see what AWS VPC is. I would also like to see if our S3 is working. There was some problem when we tried the last time, right? So let me quickly see if our S3 is up and working. For that, let me quickly again sign into my console. And it would say, do you want to sign in? Today my internet as usual is working extremely slow. I've had a change in plan recently for my internet connection. And since then it has been doing very slow. I normally have a 250 Mbps internet, so it's actually fairly good, but yep, right now we are in a pickle of a situation where these things are working slow. So let's see if S3 is working again, right? We tried doing that a lot when we were talking about the S3 buckets. So let me quickly see if it is working. Demo for today. Okay, there's a file here. Let's see if we can upload more files. I'm gonna say upload 1. %, successful, it says, in progress. You gotta be kidding me, this error again. 100% failed. There you go, it got uploaded. There's something wrong with that file maybe. So this thing got uploaded like right away, as you can see. It's called as images JPG, right? If I click on it, okay, let's not do that. Let's go back here. And what I'm gonna do now is I'm gonna get into properties. I'm gonna say enable versioning, right? So versioning is enabled now. I think I should have enabled versioning before I move the file, but let's see that still works or not for us. Okay, I'm gonna say upload. I'm gonna pick this image again and say open and upload. No sooner I try to give you all a demo on S3, something happens, and I mean, this is one of those services that is smoothest and works very instantly, but for these demos, somehow it's taking longer than other services. So I had enabled versioning, right? We talked about previous versions of file being available, right? You see there are 2 versions here. Now I uploaded one at a particular time and the other one at the other time, right? You can see one is uploaded at 10 and the other one is uploaded at 10:1, right? So that tells you, as in, that gives you a picture of how versioning works, right? I mean, I have access to my previous versions as well. So if I click on this, I should be able to access the previous version of the file that I've used. You see here, right? I can actually use the latest one as well. It will say latest then. So guys, try and understand this thing, right? I mean, when you talk about versioning, in this case, I'm using plain images, so there's not a lot of problem with it. But let's assume that I'm talking about data that needs little more editing, right? In that case, these versions might be a lot more useful for you. You can actually, I mean, then plan, if you wish to go back, you can do that and then actually take up your resources accordingly based on the data that you're trying to look into or process basically. Okay. So this is what versioning does. I think this was the part that was left. We can also do cross-region replication, where just like we enabled versioning, we have to actually go ahead and enable cross-region replication. And then you have to set up one simple bucket policy. You don't have to write code for it. If you go online, you'll get on Amazon documentation, you'll get a piece of code for it. All you have to do is create 2 buckets in 2 different regions and look for a policy that helps in CRR, cross-region replication. Just copy paste that in your bucket policy and what it will do is it will automatically replicate a piece of data from one bucket to the other. Okay, so this is how a cross-region replication also works. So this was about S3. Since we had missed out on what S3 does, what you can do with S3, I just wanted to come back here and show it to you. Thankfully, it has worked this time around. So we haven't missed out on any demo that we are supposed to take into consideration. Okay. Now let's just go ahead and talk about VPC a little. Once we are done with VPC and these services that we've discussed, we have certain important things or some other services that we need to look into that concern networking as well. Okay. So we'll talk about that in detail and I'll give you a good nice demo on that as well. But let's quickly walk through the interface of VPC, see what VPC is, right? So when you click on VPC, right? There you go. I see if I launch an EC2 instance, it will actually go ahead and create a VPC that is needed for that instance. Okay. To give you an example, if I say launch, so this interface has changed again. This wasn't the interface when I checked a couple of weeks back. Okay. So the interface again has changed. This happens with AWS a lot. They change or they tinker their interfaces once in a while. So let's just go ahead and pick up one instance that is free tier eligible. Okay. Finally, it is loading. So, it got refreshed. Did not launch any instance for me. Let's just launch this one. Okay. So when I say next, so guys, when you see this, it creates a by default VPC for me, right? So when a VPC is created, it would come up with certain policies. Okay. Subnet, again, it says it's a by default subnet that I have. I can choose a region for it, right? Where I want my resource to lie basically. Okay. So I can choose a region based on that, or I can create a new VPC as well, right? Create a new subnet as well, depending upon my requirements if I have any, and I can actually go ahead and update those. Subnet settings, it is enabled here, right? So all your networking concerns are taken care in this tab here. So for every resource that you create, there would be a VPC that would be associated with it, a network, a private cloud that would be associated with it. Okay. Now, if I go to VPCs, right, I have a VPC that is available. It is, it might be connected to something. I can also say create one. I can add name to it, and then I can give in these details as well, right? The IP address range that I have, right? I can choose what block I want to use, right? And I can decide on Tennessee as well. Then when I say create, there are some other formalities that I need to fill in, and then my VPC would be up and ready to use. So based on the VPC that I have, I can actually go ahead and select one of these for the instances that I launch as well. Okay. And then when you click on or search for direct connect, so you can create a connection here, right? Decide whether you want a classical one or you want to use a wizard to get some of these things done quicker and faster. You have to give in details here. What is the location that you're looking for, port speed, what are you trying to connect to and stuff like that. And accordingly, you'll establish a connection to actually go ahead and move your data here. Okay. And then you have your route 53, that is for your domain names. Yeah, so basically whether you talk about your DNS management, traffic management, availability monitoring, and domain registration. So guys, this is more concerned towards your website. So when you say domain registration, see, it's giving you options like .net, .com, .org, right? Because your website can have different extensions with it, right? You can also manage your domain name system, right? Your C tags, A tags that you do when you create a website, right? You have canonical names there. So it lets you control those as well. So when it says DNS management, it helps you setting up those processes for you. Okay. So this was about Route 53. Okay. Let's just go back and discuss one more important service that concerns networking, and we'll take a look at its demo in detail. Okay. So let's just quickly switch back to the presentation. Okay, so the next concept on our plate is CDN. That is your content delivery network. So when you say a content delivery network, we are referring to basically, you can think of it as a point that delivers content to multiple points. Okay, we'll talk about that in detail. Do not worry about it. So let's first understand this example. Okay. So let's assume that I have a server based in Mumbai. Now Mumbai is a city in India. Okay. So guys, these are different cities that India has to offer to us in case if there are people who are from different parts of the world and do not know what I'm referring to. So Mumbai is a city in India. You have other cities. Chennai is based in Tamil Nadu state. Bengaluru is based in Karnataka state. Mumbai and Pune are based in Maharashtra. And you have Ahmedabad that is based in Gujarat, India again. Okay. So, let's assume that you want to travel to these pointers, right? So Chennai is the farthest. It will take like around 12 units of time to reach to Mumbai, right? Bengaluru will take lesser. It will take like 8. Ahmedabad is closer. It will take 6. And Mumbai is the closest, like 170 kilometers if I'm not wrong. That is roughly 110 kilometers roughly, or miles rather. Okay, so 110 miles roughly. So basically when you talk about Pune, it is the closest and it would take lesser time. Let's assume that 2 units of time is what it takes to reach Mumbai, right? So basically let's assume that if I want to connect with Mumbai, the farther I am, the more time it will take for me to connect to Mumbai, right? Same is with your data movement as well, right? Let's assume that I have a Mumbai server where I have a website that I'm using and my data is residing on this Mumbai server. Okay. So I try to access that data from Chennai. So Chennai will take the longest time. Why? Because it is farthest away from it. So it is understandable that there's going to be a latency between these two servers, right? So since there's latency, right, it will take more time to reach to Chennai comparatively to Pune, Ahmedabad and Bangalore. But then when you talk about highly available systems, right, you do not want waiting time for your customers or for your consumers, right? So in that case, how do you solve this problem? Now this is where your content delivery network comes into picture. What content delivery network does is it helps you increase the speed, uptime and security of your resources. How? So what content delivery network does is it creates an edge location. So when we say an edge location, think of it as a point that connects these two locations. In this case, let's assume Chennai and Mumbai server. Okay. So when you talk about an edge location, it would be on this route, which is close to Chennai. Now what this does is when you talk about an edge location basically backs up your data. Okay. It makes a copy of your data, caches your data, not backs up, it creates a cache of your data. Okay. That is close to Chennai in this case. And whenever Chennai user throws in a request to that data set, it would be available there. So how it works is now it is not always possible to cache all the data that Mumbai server has, right? So when a Chennai server throws in a specific request for a particular set of data, in that case, if that data is not available at Chennai server, it would actually go ahead and look at the edge location that is close to it. Now, if in that edge location, if the data is not there, the request would be routed to the Mumbai server and a copy of it would be stored one in your edge location and moved to Chennai. So whenever a request is made to that data, we have a cache copy of that data to be delivered to the user at a faster pace going ahead. So that is what your content delivery network does. It ensures that your content gets delivered through the network to the user without having to worry about the latency part. So what it does is it gives you following benefits. One, there's an increase in speed, right? So when you say speed, yes, your data is getting transferred at a faster pace, right? Because there's an edge location that is present. There's a decrease in load that your central server might face. Now in this case, if your data is getting cached, right, at 4 edge locations that are close to these cities, not all the requests will go to Mumbai server, right? Those would be fetched through the edge location that is close to them. And this in one way or the other reduces traffic on your Mumbai server, making it more available. Uptime. Obviously, if you have a greater speed and your server is also not getting loaded with work or with requests, your uptime is naturally going to increase. Since not all the final point is security. Now, since all the resources are not trying to connect to Mumbai server, they are dealing with the cache. So the security threats for a Mumbai server are also less. Why? Because lesser number of requests are coming to it from different servers, from different regions, right? So that is what your CDN is all about. Okay. Now, when you talk about AWS in particular, there's a service called as AWS Cloudfront. What AWS Cloudfront does is it actually lets you go ahead and perform these CDNs or create these CDNs for your AWS network or CloudFront distributions via AWS network. As the name suggests, AWS Cloudfront is a service that speeds up the distribution of a static and dynamic web content. It can handle files in formats like HTML, CSS, JavaScript, and even images. So basically, as it says, it speeds up the process of distributing your data across different servers, different regions, right? So basically, it is a CDN service that AWS provides to you. What are the pointers it considers? One is your routing, the other one is your edge location, and the third one is your availability, right? So when you say routing, so basically what we are doing here is we want to move our data through the network and it has to be delivered to different regions, right? Different servers, different locations. So data routing becomes important. So when you talk about Cloudfront, it routes your data as well. It controls your domain names as well so that it knows what IP addresses to connect to and how. Okay. Edge locations. When you talk about an edge location, again, edge location is nothing but your distribution or a location that is close to the area where you want to serve your data. Okay. Availability. When you talk about availability, ensuring that your resources are available 24/7. Is what Cloudfront lets you do. So these are some of its features. Let's not get into the details of it. It's not very important, but I believe you have a gist as to what Cloudfront does and what CDNs are. Okay. So how does it work exactly? So I had explained this when I was talking about CDN. Let's talk about it from a Cloudfront perspective, right? So basically, let's assume you are a user, right? Now you set forth a request for a resource that is again based in Mumbai server and you're based in Chennai. So the amount of time it will take through normal latency is a lot and it would be frustrating for you. But let's assume that you have AWS Cloudfront with you. What it will do is there would be a Cloudfront distribution that would be created, an edge location for you. So whatever request you send, it will go through S3 bucket and Cloudfront where a copy of this data is maintained. Okay. And once it fetches that copy, it will make a copy of it at the edge location and it would be distributed to you as a copy that you requested for. And whatever requests you put forth going ahead, the requests get speed up because now there's a copy maintained at the edge location. So what are the applications of AWS Cloudfront? So when you say applications, right? There are quite a few things that you can do with AWS Cloudfront, or there are quite a few features that AWS Cloudfront offers to you. One, it accelerates your web content delivery, and that is obvious, right? So when you talk about your web content, if it is moving through a network that ensures there's no latency or lesser latency, you are not spending a lot of time waiting for the resources. I mean, good examples of this are the streaming websites that we use, right? You always have data that is cached somewhere, and whenever you put forth a request for it, it gets available to you right away. Serve on demand or live streaming as well. So as I've just mentioned, I mean, it serves both for your static data that you want to move and also for your streaming data. So when you talk about streaming data, the streaming data is delivered to a particular edge location or your server in packets, right? So no sooner these packets are available, those start getting streamed or delivered to your location one after the other. Okay. So in the form of packets in this case. So that is what live streaming also is supported by your AWS Cloudfront and the CDN service it offers. Data encryption. Now there's an option of data security as well. You can encrypt your data that you want to move over the network. Okay. So yes, there's an option for data encryption as well here. Okay. And customize your edge locations as well to ensure that there's proper data maintenance there, security, and ease of transfer to the closest region that you want to transfer your data to. Okay. So this was about CloudFront features. Okay. Let's just go back and take a look at the demo that CloudFront has to offer to us. Okay. So I've actually gone ahead and came back to my console. So let's just go ahead and create a CloudFront distribution to see how it works. Okay. So for your CloudFront distribution to work, we would be needing two important things. I think I have those with me already. There you go. So guys, there's a Great Learning logo that I have, and I have an index file. Let me delete this for now. I'll create a new one instead. Okay. So let's just say HTML, right? Okay, so I made a blunder out of there. I hate HTML, to be very frank. Hate as in I do not like using it. I know it's fairly easy, but not one of those things that I'm fond of. These tags make me confused a lot, or get me confused. So next one is your head tag, and inside your head tag, let's call it, say, okay, demo, right? And let's have a body tag as well. Let the body tag say successfully routed data. Okay. And let me just save it as index.html. So there you go, my HTML file is created. Okay, so we are going to go ahead and create a CloudFront distribution and try to access these two files there. Okay, let's just come here, and for that we'll need to create a bucket to start with. So we already have a bucket with us, right? Let's just go ahead and say delete, and then upload the files that concern us. So I say upload, I go to desktop and AWS demo, I select this file, I select this file, and I say open, and I say upload. So both my files are here with me. Demo for today, demo 2 today is the name of the bucket. So guys, now we are going to go ahead and create a CloudFront distribution. For that, I'll have to search for AWS CloudFront. I open it. And I say create a distribution. Okay. So there are two options. One is that says create a distribution for static data, and the other one that says RTMP is for your streaming data basically. So let's create the first one, and let's use this bucket, right? So it will use it as my origin domain name. Okay. So it has created a domain name based on the bucket that I have. Okay. Original path, I do not have to get into these things, do I? No. So origin ID, it is this bucket, right? So it will use this bucket as a server that I want to use. Are the other things that I need to make changes to? Restrict bucket access. I say yes. Choose an identity. I would say create one on your own. Okay. If I say do not restrict bucket access, anybody can access this bucket. I think this will create a problem for us, but let it be for now. And redirect my HTTP to HTTPS. Okay. Rest I think we do not get into the details of. Let's just go ahead and say create. So this creation takes time, guys. It takes like a few minutes for your distribution to get created. Cloudfront private content getting started, using Cloudfront to serve private content. So basically it's giving me some information as to what all is happening here. So as mentioned, guys, the distribution will take time. If I go to distributions, so as you can see, guys, this thing is taking a lot of time, right, to load. So it might take like 5-6 minutes more. Once that happens, we should be able to basically go ahead and access a piece of data. So basically what it will do is, since I have my data that is rested in my bucket, right? So whenever I actually go ahead and type a particular domain name, right? So what happens is, let's assume that I have my data residing in my bucket. Now in this case, my bucket is that server point of connection, right? So you can see that there was a domain name that was created. So what it does is, when I look for that particular domain name and for a particular file, it would fetch that file for me from the bucket in first place, and then put it on the Cloudfront distribution, so that going ahead, whenever I want to access it, I can access it quicker and faster. Okay, so you can see that our Cloudfront application is up and running, right? So let's just go ahead and use a particular piece of domain name. Control C. Let's type it here. And let me say index.html. Okay, there's an error here. It says access denied. So let's just see what we can do. Okay. Let me go through the S3 bucket first. So inside this S3 bucket, guys, let's see. Block all public accesses. Don't do that. I say confirm. And then I open the bucket and I have certain files, right? Make public. Now my buckets are public as well, and the objects as well. So let's just try it out now if it works. Okay, it should. Demo successfully routed data. It will basically route the data to me through my distribution at a faster pace. Let's try it out for the PNG as well. There you go, right? The logo that we had put forth. And if I look for index.html, it does that instantly for me, right? Because it is getting distributed to me through a cache that I have, and that is located close to the region that I'm based in. Okay. So this is what Cloudfront does. It ensures speedy caching of data and delivery to you that is closest to your place. Okay. So this was about some of the popular networking services that we have in hand. Let's now just go ahead and see what all can we talk about. But ensure one thing, that before you leave, you delete your distributions as well. Okay. So if I select this now, it would say delete. So delete your resources. Disable this one to start with. And once it is disabled, and once this is disabled, you can actually go ahead and delete it as well. Okay. So let us go ahead and talk about AWS DevOps services, right? So before we do that, we would be discussing what DevOps is, right? We would understand what are the AWS DevOps services that are there on our hand or with us. And once we are done with that, then we would actually go ahead and explore how DevOps can be implemented using AWS. So let us go ahead and get started then. So first and foremost, let us discuss what DevOps is, right? So when we talk about DevOps is nothing but a set of practices that aims to reduce the time between committing a change to a system and it is the change actually that is being placed into normal production while ensuring high quality. So now this is what the technical definition says, right? So what we are talking about here is it is a set of practices, basically an approach, right? That helps us actually reduce the time when you talk about the whole process of software development puts it through, right? So when you talk about software development, right, we are talking about building a software, then testing it, and then putting it into the production environment. Now there are various phases or various things that happen here. One, you get a piece of code, right? Then there could be a place where you actually decide to go ahead and build the complete application, right? So when you build the complete application, there are problems associated with it. The major problems are, one, if you have a complete software in place, let's assume that that software is giving you certain problems. In that case, you are actually forced to go back and backtrack all the activities that concern with that particular piece of software, right? Why? Because if you build it using SDLC method or the traditional way of building applications, the problem is you are building whole application or software as a whole. So if something goes wrong, the problem is you have to go ahead and test the complete thing and then fix it, right? So what happens here is this process is a little more complicated than what I've just mentioned. It's not just that you have a software, you go back, make changes and make it work again, right? This again goes through quite a few phases. So when you talk about software development, it is not just that a developer builds it and you as a user start using it. So when you talk about DevOps, you have to actually understand how software development lifecycle works first. It is only then that we can actually go ahead and talk about DevOps, because DevOps is something that is going to help us solve the problems that I just mentioned, right? So let us try and explore these problems a little more first, right? So what I mentioned was, when you talk about this software development process, so a developer will first build a piece of software. So once the software is built, it then goes into the production environment where it is handled by the operations team. Now, these are the people who actually take care of quite a few things when you talk about it from a perspective where the software runs in the production environment. So these are also the people who face consumers, right? Consumer facing people. So if there are any changes that need to be implemented, it is the operations team that actually conveys or carries out these minor changes. If not, it goes back to the developer and the developer has to change everything. Now, what is the problem with this approach as well? One, since we are talking about two teams, now these two teams cater to different problems, different needs. As a developer, you would be building an application in the development environment. But as an operations member or as an operations team member, your job is to test this software, but in the production environment. So these are completely different environments, right? So occasionally what happens is something that runs in the production environment may not always run in the development environment. Something that runs in the development environment may not just go ahead and run in the operations environment, because these two environments can be different. But when you talk about building an application, what a developer feels is if it was running in the developer environment, my job is done. But the operations team feels as in, since it is not running in the production environment, it is something that a developer might be at fault. So what this process does is, one, there are tussles or there is constant communication between these two teams because both of them are trying to resolve what is going wrong. And this process is one, time consuming and requires a lot of effort from both the teams. So this is where DevOps comes in and solves this approach. What DevOps does is basically it is a methodology. When you talk about DevOps, it is not a technology, it is rather an approach towards software development that actually tries to break silos between the development team and the operations team. Okay. I know this is something that is not going to fit into your brains right away because this is too much information to capture in one go. But as we move further, I would be talking about examples and this topic would start making a lot more sense to you people. So basically what DevOps does is it brings in an approach that helps us solve these issues. Okay, the issues that we just discussed. So how does DevOps help in? How does DevOps contribute here? So as the name suggests, right, what you see on the screen is Dev and Ops coming together. That means we try and break in silos between these two teams, try to make them work together. Now, how does this happen? So basically what DevOps does is it tries to introduce a concept called as continuous integration and deployment. This is something that you might have heard in Agile approach as well, but Agile is more towards setting up a process. It's more towards setting up the planning process where you decide what needs to be done in what bit. But when you talk about DevOps, it is an actual approach where you try and resolve issues between the developer team and the operations team. Now, how does that happen? So basically, when you talk about continuous integration and continuous deployment, here basically what we do is we try to break our software into parts being developed separately by maybe micro teams or maybe individuals, right? And when this happens, this chunk of code that is developed individually, it is integrated into one single code, which is then moved into production environment. So even if there's a change in this piece of code, only that particular piece would be required to be mended and not the entire software, right? And since there's a continuous process of integration and deployment and development, we do not have clashes between something not working here or there. So this is what DevOps does for us. So let us actually go ahead and understand DevOps a little more. Now, ever since I've started, I've been talking about what DevOps is, right? You might be wondering as in why are we discussing DevOps since we are talking about AWS in particular. Now, DevOps is one methodology. Now that the fact that we've understood DevOps to some extent what it is, DevOps is a methodology that brings in the developer and the operations team together, as I mentioned, and it is something that is being implemented at a larger scale. So AWS also being a popular cloud platform, it understood this need where DevOps was being implemented by people at a larger scale and on a larger need, right? So what that did was that kind of stimulated AWS to actually go ahead and have a set of services that could actually implement or let people implement DevOps on top of AWS cloud platform. And AWS has readily amalgamated with this approach or made this approach its own to help people build software using DevOps approach if they want to. So that is why DevOps again is a very popular approach, as I mentioned, and so is AWS. And if you are learning these two things, it is going to be a stronger hold for you if you talk about it from a career perspective. So that is why we see people talking about DevOps on AWS as well. And hence we are having this discussion here. So now that we know what DevOps is, at a surface level at least, let's go and understand what continuous integration and deployment is a little more, right? And once that is done, we'll talk about different AWS DevOps services as well. Okay. So when you talk about DevOps, right? And when you talk about continuous integration and deployment, right? So basically this is what you see, or this is what happens, to be very frank. Yeah. So, when you talk about steps that are involved, right? As I've already mentioned, what we do is there is a set of planning that happens, as in what needs to be built, what is the time that needs to be invested in this process, right? And how it is, or how to actually approach this particular problem. So basically what we would do is, let's assume that I have a software that is X folds in size. So we would basically divide this X folds of software or the development that we are planning to do into certain set of plans or parts rather, right? So these parts, you can think of them as individual pieces of codes that different developers would be working on. So these pieces of codes are basically put forth in a repository, right? In this case, it can be your Git or GitHub. Now these are DevOps tools again. Basically, these are repository management systems where you can put up particular pieces of code that you have with you. And there could be a master branch with you where you could actually go ahead and merge all these pieces of code. So in some cases, you might be working on individual codes as well. So you might put forth your individual code there. And if there is a set of people working on a similar set of software, you can actually go ahead and put forth that code on a master branch where the person with right authority would merge your code to the total piece that you have with you. So when all these pieces come together, they help you build a software. So this is why if some of you who've interviewed in recent times, they might have realized that if you look for development jobs, people will ask you as in, do you have a Git repository with you? Or do you have a Git account where you have put forth your existing projects, right? What they're trying to understand is if there is any set of development that you've done, if there are any pieces of codes that you have with you that have been pushed on GitHub, right? So as we get into the demo part, we would be talking about how to build a pipeline using AWS, and we would deploy a piece of code there, a set of application to be frank. So in that, probably I'll talk about some of these steps that I'm discussing right now. So probably we'll get to see what GitHub is, how it works, right? How can you actually go ahead and pull and push code from there, right? So we'll talk about those pointers as well. And we'll discuss how to create a pipeline using AWS as well. But before that, let us go ahead and understand this process a little bit. And once we are thorough and through with all this process, then probably we can get into the demo part where I would be talking about these AWS services that are there in our hand or on our plate, right? So when you talk about source code repository, right? So this is where you put forth all the pieces of code that can be combined. Okay. So let's assume that you are working on these codes that you have, right? So this code then goes to the next phase of development where you have a build server. Now this is where your code is compiled, right? And this is where it is integrated as well, because as I've mentioned, you have your code in pieces. So this integrated code comes together, it gets compiled, and then it moves to the next phase. Once the build phase is done, it would then go into the staging and user acceptance test phase. So this is where basically what happens is when you say staging or user acceptance test, so staging is a phase where you test your code. So now that you have integrated different pieces together, you still need to understand whether your software is up and working smooth and nice for you, right? So this is where your testing process comes into picture. And once this piece of code is tested, if it is not in place, it is sent back. Guys, remember one thing, if there's a fault in any of these stages, your deployment process stops there and then it goes back, it is reiterated and it is corrected, and then it moves into the further stage. So if it is approved, then it goes to your production server. This is where also you have your builds happening constantly. So let's assume that it is in production server and then there are problems with it. The patch is immediately sent back. It is tested, worked upon, and repatched software is sent to you. So what we see these days is you might have constantly seen that you get your, if you use an Android or any phone, right, which has operating system. So there are constant patches or software fixes for you, right? So you get these constant notifications saying that a new version is available. Some of the bugs have been fixed here. Some of the issues have been fixed here. There's a new release for you, right? So what this means is basically your software is undergoing certain set of tests, and all the bugs that were there, those get fixed. To give you one example, now, I'm not sure, but there's a game called as Pokemon, right? Pokemon is something that is a very world-renowned game when you talk about middle-aged kids, right? So basically for them, this game is like gold, and even adults these days, I mean, I've seen quite a few adults being crazy about it. So one thing that I've followed here or noticed here is this company is very good at fixing whatever bugs they have, right? So whatever games they release, those are also released in cycles. So whatever were the issues with it, those get fixed in the next edition for sure. So they do this analysis very well, where they understand what are the issues that they're facing with the game, and those get fixed right away. So this is just one general example. Do not stick to it very seriously. If you talk about Windows operating system as well, right? I mean, if you use a licensed version, now I'm talking about Windows because I've been using that for a while. I never had a chance to actually go ahead and use Mac operating system a lot, so I won't be commenting on that. But if I stick to Windows, right? So basically what happens is I constantly get notifications saying that my Windows operating system had certain bug fixes or a new interface is available to me. Same happens with AWS as well. We'll see that. So basically we see that constant interface changes there. So this is something that happens easily when you talk about DevOps. Why? Because you are fixing bits and pieces of it. You are not kind of working on the entire software and making everything work differently there. So that is why you can constantly keep fixing bugs that are there. So that is what DevOps does, and that is how it breaks silos between the developer teams and the admin teams. Okay. So this is one way of looking at it, right? So again, if you talk about bringing these things in place, making these things work, right? There are quite a few software out there or tools out there that let you actually go ahead and do these things in practice, in actual, right? So what are the services that let you do all these things? Now, if I were to talk about it from a DevOps perspective, right? So we have Git, which actually lets us do all this repository work. Then you have your Puppet, you have your Chef, you have Jenkins, right? Ansible. Now these are different tools that let you do different things, whether you talk about software build process, whether you talk about this continuous integration, whether you talk about automating certain actions. All of these are taken care by these tools. And if you talk about DevOps, I mean, the set of tools that are there, the options are pretty high for you. There are pretty much options that you can actually go ahead and choose from. So when you talk about DevOps, right? So in general, these are the tools that you can actually target. But when you look at it from an AWS perspective, there are certain set of tools that AWS also offers to you that lets you do all of these actions in one place, or basically control this whole process of software integration, breaking it down, again integration, then development, and then deployment, and in between testing as well, right? And what AWS does best here is it actually automates quite a few of these processes that we've just discussed, thus simplifying quite a few things that you otherwise or would have otherwise taken a lot of time to do. Okay. So let us go ahead and take a look at some of the services that AWS has on offer, AWS has on plate for us. And once we take a look at those services, then we can actually go ahead and take a look at how these things work on top of AWS. What are the services that AWS has to offer to us? Okay. So there are more services than these, what you would be seeing on the screen or in the slide deck. But as we get into the demo part, I would be discussing other services as well. But that is for the demo part. Let's try and understand these. So when you say AWS Codepipeline, it is a fully managed continuous delivery service. So when we say continuous delivery service, basically it helps you automate quite a few processes, whether you talk about basically building, testing, or deploying your application. So all these processes that concern release of your software, basically these things are automated by using AWS Codepipeline. Okay. So as the name suggests, it is a continuous delivery system. And since we call it pipeline, the reason we call it pipeline is it acts as a conveyor belt. When you talk about industries, we are talking about manufacturing, right? If you manufacture a particular product, what happens is it is readied first for usage, right? It can be food that is cooked. What your production line does is it cleans it, if required heats it, then cools it. After that it might go through certain processes like packaging, right? Cooling again, or sealing up, and those things, right? So there are quite a few phases that are involved in your production line, right? So when you talk about AWS Codepipeline, it is this pipeline that controls or has various phases that continuous integration and deployment has. And all these things happen inside this pipeline called as Codepipeline. And it automates these processes to simplify quite a few things that we do in DevOps on top of AWS. Next is your AWS Codedeploy. So as the name suggests, this is a fully managed deployment service. It automates software deployments to a variety of compute services such as Amazon EC2, your Fargate, Lambda, Elastic Beanstalk, and other options as well, even on-premise. So guys, understand one thing, even if you are implementing or building software on top of cloud, it is not always that you would want to store it on the cloud, right? You might want to migrate it to your on-premise applications. We are talking about hybrid applications as well. So in places or in times when you want to migrate your applications into the on-premise infrastructure, you can do that by using AWS Codedeploy as well. Apart from that, as you can see on the screen, it says you can migrate it to your EC2 instances, right? You can do it with AWS Fargate and to Lambda as well. So Lambda is your serverless computing service, right? So you can do it there. EC2 is your infrastructure as a service. You can actually go ahead and deploy your applications. If you have an instance that you configured on your own, you have a proper S3 service that is connected to it where you can store your data, right? So, and you have proper security or security groups under which this instance lies. One option is you do it on your own. The other one is you use Elastic Beanstalk, which is platform as a service, and you can automate certain processes of setting up your EC2 instance. Once that is done, you can actually go ahead and deploy your application to Elastic Beanstalk or the corresponding instance that you have. Okay. So Codedeploy basically lets you move your code on top of the AWS services that you have, computation services, or in the environments that are on-premise as well. Now, this was about these two services. What we have next is your AWS Codecommit and Code Build. So when you say AWS Codecommit, now AWS Codecommit is more of a fully managed source control service that hosts secure Git-based repositories. It makes it easy for teams to collaborate on code in a secure and highly scalable ecosystem. So the definition that I've just read, right, by this you should already realize that it is an AWS variant for Git. So basically when you say a fully managed source control resource, what that means is basically it is giving you an option of having repositories being held in Codecommit, right? Just like you would have done on Git. Now, why do you need to do that on Codecommit? If you have an in-house repository holder, you can actually ease up the process of doing that. Else you'll have to always go ahead and approach Git for that, right? So you are talking about an integration with a tool that is out there somewhere, right? Not on your cloud. Now, when you talk about Codecommit, do you eliminate Git completely? No. If you want to move your Git repositories to Codecommit, you can do that as well. We'll see how to do that once we get into the demo part, but till then you'll have to wait. So next is your code build. Okay. So when you say code build, so when you talk about the pipeline, the first thing that happens is your code commit, right? Because you are getting in touch with your repository, and that could also be the last thing that is happening in your cycle. But for now, let's consider that is the first thing that happens. Next is your code build phase, something that we should have actually discussed before, but we are discussing it last, right? But let's talk about that first. So when you talk about code build, right? Basically what happens here is it is a fully managed continuous integration service that compiles your source code. It runs tests on it, produces software packages that are ready to deploy. Here you do not have to worry about provisioning, managing and scaling your own build servers. It scales continuously and processes multiple builds concurrently, so your builds are not left waiting in a queue. So basically it takes care of all the activities that concern building a software, right? Whether you talk about provisioning or managing or scaling your resources, it says it takes care of it by itself, right? And it lets you package a software as well and run tests on top of it. So chunk of your work actually happens in AWS Code Build. And this is where, these are the applications that actually go ahead and simplify a lot of responsibilities that concern your software development. Okay. So, this was about the DevOps services that we have in our hands, right? So we've discussed quite a few pointers. Let us get into the AWS console and see how the demo part works. Okay. So this could be a longer demo than we normally do, but let's get into it as quickly as possible. Okay. So let us just go ahead and first log into our AWS console to start with. It says I'm not logged in. Let me quickly do that as well. Okay, so this is how the AWS Management Console looks like. Again, for people who are new to AWS Management Console, make sure you create a free tier account if you want to. Now the demo that we are going to implement again falls under the free tier. That means we won't be charged for whatever we do. But note this thing, that it is important you have a free tier account for this. If you do not know how to create a free tier account, just search for AWS free tier and in any browser you have, and actually just go ahead and register there. It would ask you for your credit card and debit card details. My personal experience tells that even if it says credit card, your debit card is also accepted. I've always or mostly used my debit cards here. It would charge you ₹2 in India if you are, for the verification purpose. The reason it wants to verify is it wants to see whether it's a legit account, a legit card. And then you have 1 year of services, or services worth 1 year free of cost. Now these services come with upper cap, upper limit. When I say upper cap, say for example, if you talk about S3 storage service, there's a limit of 5 GB which you can store in it. If you store above it, then you would be charged for it, and AWS will start billing you for that. So this is what metered usage is. You have a metered limit that you can use or work on. And if you kind of cross that metered limit, this is where AWS will start to charge you. Okay. So, create a free tier account. Do not worry, you won't be charged. Whatever demos that we are performing fall under free tier. So be assured or stay rest assured that we won't be charged. So once the account is ready, you can actually go ahead and start implementing these things with me. So what are we going to do here today? So I have this repository with me where there's a piece of code that I wish to deploy. That is a piece of code that I've actually taken from a Git repository. It does not belong to me. It belongs to some other user. So I would be using that. I had used this initially. The purpose was different back then. I wanted to see if I can deploy a piece of code to 3 different instances and keep them running, even if one of the instance goes down. So I would be using the same code, but the application would be different. We won't be deploying it to 3 different instances. Instead, what I'll do is I'll create a code pipeline today. We'll create PaaS application. I've been mentioning what PaaS is and what it does, or what Elastic Beanstalk does, right? So what we'd do is we'd actually go ahead and create a PaaS application, right? And basically use that PaaS environment to have our Git repository code hosted on an EC2 instance, and we'll carry out the whole process of code commitment and deployment using AWS Codepipeline. Okay, so let's take it step by step. Let us first go to Elastic Beanstalk, create a platform for us to use. Okay, so how do we do that? We first go to Elastic Beanstalk. So you can search for it here. Since I had used it recently, it is available here. So guys, if you have no applications that are currently running, this is how the interface would look to you. But if you've created an application, the interface would look a little different. So do not be frightened if the look is any different for you. Okay. And as I've mentioned, AWS also keeps changing this look. So if you are implementing this demo and you are not doing it with me, this interface could look a little different for you, but just follow the steps, follow the process. And I don't think it should be a problem for you to get hold of any of the things that we are doing right now. Okay. So what do we do now? We actually go ahead and create an application. So I say create. So it would say, give me a name for the application. What should we call it? Let's call it demo for today. Okay. Application tags. I don't think I need to get into the details of that for now. It says select a platform. So guys, as I've mentioned, when you talk about AWS in particular, right, or Elastic Beanstalk that AWS offers, now this is where it is platform as a service. So it gives you a pre-configured platform for you to use. It's not that you cannot choose one for you. You have options of choosing one. But if you've known that this is the environment that I want to work into, I can have a pre-configured environment set for me without having to configure any part of it. So this is the difference between an infrastructure as a service and platform as a service. So when you say infrastructure as a service, this is where you'd be setting up everything, right? So you decide what kind of security group you want, what kind of network you want for it, what kind of storage you want for it, what is the size of instance that you want to use. So here what Elastic Beanstalk does is it plans all these things for you. You just pick an environment that you want to use. So what kind of environment would we be choosing here? See, we have these many options here, right? We have a .NET Core, Linux if you want to directly, right? On top of Linux, that is. You have .NET Core on top of Windows Server, Docker, Glassfish, Go, Java, Node.js, PHP, Python, even Ruby and Tomcat. In this case, I'm going to choose PHP for me. Okay. So by default, what it does is it selects a platform branch for me, that is PHP 7.4, and it's running on a Linux Amazon machine that is 64-bit in nature, and the version of PHP is 7.4. Platform version on the other hand is 3.0.3, which is recommended. I can choose others as well, but probably when you talk about PHP, this is the option that I have. So let's stick to that. Next, what we do is we actually go ahead and, so guys, there are two options here. When you talk about platform as a service, you have control over the code that you have and the applications that you have. So you can actually go ahead and build your own code, right? If you have a piece of sample code with you, you can move that piece of sample code here. The other thing that you can do is you can actually go ahead and have a sample application for you. Okay. So, what AWS does is it offers certain template applications that you can use. So in case if you have a piece of code with you that you want to use, in this case, we are going to use a repository, but we are not going to type our own code here. Let's create a sample application first and try and use that, because our aim is to have an environment in place and not actually go ahead and create a piece of code, something that would take a longer while for us. Let's not do that. Let's just go ahead and say create application. So there you go. Demo for today -env. It is an application that is getting created here, guys. Now what I wanted to do is closely observe what all is happening here, right? So right now it's 10:49 p.m. here. And the first thing that has happened is basically it says that it's creating an environment. Using Elastic Beanstalk, right? It has first created a bucket for me. So when you say a bucket, this is where your data would be stored, right? So bucket, S3 bucket, S3 is the storage service that AWS offers, and it stores data in the form of objects for you. So as you can see, a bucket is getting created here. Once the bucket is up and ready for you, what it does is it creates a security group, ensuring that a certain set of security principles are set. You can actually go ahead and modify these security principles. We are not going to do that, but I'll show you what happens there. But that is for the later part. Next, create an Elastic IP for the instance that I'm actually launching. Okay. So environment health has transitioned to pending. So basically it is creating an environment for me, right? So when it is creating an environment. What is happening here is basically it is setting up the environment and seeking or checking whether the health of my environment is up in place or not. So waiting for EC2 instances to launch. It may take a few minutes. So basically what it is doing is if there are multiple instances that are to be launched, to launch those. If there's one instance that needs to be launched, it will launch that particular instance. So let that instance get launched first. See, even when you talk about the instance, all these steps are happening here one by one, right? So basically in a set of like 2 minutes, right? It has actually gone ahead and set up an environment for me. It says it will take few minutes. It actually takes lesser than that. Like 2 to 3 minutes and your environment should be up and running for you. Something that you can make use of. Okay. Added an instance as well to our environment. Application is available at demo for today. Successfully launched an environment. So technically speaking, it took less than 2 minutes to actually go ahead and get an environment in place that we can actually go ahead and use for this particular demo. So our environment is up and running, right? We have an instance in place. Let's now move to the AWS Codepipeline setup and see what all we can do there. Okay. So demo for today /env or -env is the name of our application. This is something that you'd want to know, the environment, or keep that in mind. So guys, remember the names that you create, right? Simplifies the process, whether you talk about deleting it or using it. Now let us look for AWS DevOps services meanwhile, right? I said that I would be getting into the demo part and talking about these services, something I haven't done. Okay. So let me quickly show you what are the developer tools, right? So when you say DevOps, we're talking about developer tools. So you have X-Ray, Cloud9. I haven't used these services ever, so I won't be committing a lot on those. Same is for CodeStar as well. I've never had a chance to work on it. Time when I was actually exploring these tools a little, I mostly spent my time understanding how AWS Codecommit works, how build works, how artifact works, how Codedeploy and Codepipeline works. The other ones is something that I haven't have had much time or chance to explore or get into the details of. So let's not get into the details of those. But if you want to know, if you click on it, you'll get all the information here and here as well, right? So when you say AWS CodeStar, right? It's not available in the region. So let's not change our region for that, just to understand it. Let's go back. Okay. So this is something that I did not want to do, but still let's scroll down. And if I click on AWS Artifact, right? See, AWS Code Artifact. It is secure, scalable, and cost-effective artifact management. So it's fully managed artifact repository service that makes it easy for organizations of any size to securely store, publish, and share software packages in their software development process. So basically it lets you control the software packages that you have with you, and you can actually control those in this environment. There's a diagram here that tells you what you can do with it. If you expand it, you'll get to see, right? So all the steps are explained here. You basically pull your application dependencies from public artifact repositories, right? Move it to code artifact, which is secure, scalable, and cost effective in nature, right? And then you basically go ahead and move it through the, you have your repositories inside it, right? You have 1, 2, you have your domain, right? So you can manage access and apply policies across multiple accounts within your organization. You can even securely publish and store your packages to other repositories as well. So you are not restricted to one repository. You have n number of repositories here, and developers can actually go ahead and access these artifacts, right? You can even connect it to code build for your CI/CD operations. So similarly, if you go back, you have other services in hand as well, right? You can explore those as well. So if you come down here, you have other services. Okay. So similarly, you have your Cloud9. Let's see what info we get out of it, right? It's an IDE for writing, running, and debugging your codes, right? How it works. All the details are given here. So you can actually come here and refer these applications or refer these services that AWS has to offer to you, and try and understand what all you can do with the DevOps services that we have in our plate or on our hands. So let's just go back to the console, and what I'm going to do now is I'm going to go ahead and launch my code pipeline. So for that, again, I'll get into the developer part and I'd say code pipeline. So if I open code pipeline, you see basically this pipeline takes care of all these things. First is you set up the source that you want to use, artifact if any, you build your piece of code, you deploy it, and then you can actually go ahead and check the status of all this that is happening here at one single place. So that is what DevOps does for you. It basically lets you do all these things at one single place. Okay. Now, what do you do here? First and foremost, you create a pipeline. Let's start by doing that. I say create a pipeline for me. I'd have to give a name to my pipeline. So there's a sample name given here already that I have, Sam Repo. Let's just stick to that name for now, right? Then it would say, do you want to create a new service role, right? So when you talk about AWS, right, what it does is it defines a certain set of rules, right? Or policies, roles that actually let you control how instances, how resources would work on top of AWS. So you'd be needing a service role here as well. You can use an existing one, right? So in this case, I have an existing service role with me. This is the name of the service role. So right now I've selected a new service role. So if I try and create it, it won't allow me to do that. Do you want to see it? Let's say next. Why? Because this role already exists is what it says. So I had created an application with the same name. That is why we had that suggestion known as Sam Repo. And there was a role that was created. So when I deleted this pipeline, the role existed. It did not go off with the application. So that is why the role is there and I'm not able to create the same role. So let's just go ahead and say use an existing role. So this is the role that I would be using. In the advanced setting, what are the options I have? let's not get there. Let's say next. Now it says select a source. So I want to, this is where you store your input artifacts from your pipeline. Choose your provider here. So I say use GitHub because I have my repository there. For that I'll have to connect. So guys, my account is already here. Okay. So it has actually gone ahead and authorized that account for me to use. If you do not have an account, you'll have to sign in here. So if I go to GitHub, right, let me quickly show you. So guys, this is the repository that I'm using. I'll type it here so that you see it clearly. Okay. It is AWS Codepipeline S3 Codedeploy Linux. Okay. AWS Codepipeline S3 Codedeploy Linux. So this is somebody else's repository that I'm using. It does not belong to me. I'm just using it for the sake of this demo. So you can actually go ahead. If you do not know what GitHub is, what I would suggest is go there and create an account in GitHub. Okay. So if you look for GitHub here, I have an account here. This is how the GitHub interface looks like. And you see, this is the repository that I have imported. Okay. So when I say imported, I've pulled this repository from somebody else's branch. Okay. So that I can use it. And this is the piece of code that is there on my repository that I would be using. You have your appspec.yml file and index.html file. Something these are used, even readme.md. Okay. So basically you have an option here, right? It says this is the master branch. In my case, I can branch. Okay. I can even pull, push and fork the repositories if it belongs to somebody else. And I can start using that for my personal purpose. You see, there's an option of forking here, right? You cannot fork because you own this repository and are not a member of any organization. So, since I own this, I cannot fork it. If you were to try and fork it from my account, you could actually, okay? So you can do that. So go ahead and get this repository. Okay. And then you can do the demo that I'm doing. Next, what I do is I actually come here and I select branch, in this case, master branch, right? Now, what are the detection options? I'm going to stick to webhooks. Let's not get into the details of what it does. And do I want to build anything? I'm going to skip the build stage because I have a piece of code with me. I don't have to go ahead and test it for any purpose. So I'm just going to say skip this stage. Yes, skip. Deployment provider. We have created an environment. Elastic Beanstalk it is, right? So it would ask me where is the environment and what is the name of the environment. Demo for today was the name, right? Yep. And what was the environment name? This. Okay. So choose the application name that you have already created on AWS Elastic Beanstalk console. So you can do that. What was the environment name? This is the environment name. I say next. So guys, see, you can verify your steps here. What all is happening, right? So these are the stages of pipeline that it is going to follow. My source stage, my source action provider, it is GitHub, third party, right? Build stage, I don't have one, right? And this is the deployment stage. Where are we deploying it? Deploy action provider is your Elastic Beanstalk. Name of the application, demo for today, environment, demo for today /env. So I say create pipeline. And there you go. Your pipeline is getting ready for you. So guys, you can see it will go through phases here, right? First step is your source. Now it is in your source. Your source GitHub got succeeded. That means it verified that repository that you wanted to deploy. Okay. And now it has gone into the deployment stage. Since we do not have a build phase, we can skip that for now. When you say disable transition, you won't get to transition your applications or see it. Okay. So, now it is in the second phase. It takes half a minute or 1 minute to actually go ahead and do that for you. So let that happen for now. Okay. So this will take a minute or two for this to happen. So let this happen. And once this happens, we can actually go ahead and see, what we want to do with it. There you go. So successfully the deployment has happened. So basically, see, it took a couple of minutes. This was a basic application, and it did not take long for AWS Codepipeline to actually go ahead and deploy it for you. Now let's just go back to the instance that was created by the environment that we have in place, right? So I say come here. So guys, we created a Linux EC2 instance. If you remember, it was there in the environment when we were trying to launch it, the PHP environment we tried to launch, right? So it said that it was set up on the Linux EC2 instance. So let's see if we have a Linux EC2 instance by the same name. So there's one instance that is running. There's an elastic IP as well that we saw, right? So I say running instances, and you can see the name is also same. It says demo for today, right? And all the details are here about your instance that is there in place. See? So it was created at July 10:49, the exact same time, right? I mean, when we were looking at the time zones, I said that it takes like a couple of minutes to set up this environment. This was the time there, right? So it is pretty evident that this is the instance that we are talking about. So guys, if you scroll down, you'll get more information about the instance, what all it is having here. So everything here was set up by AWS Elastic Beanstalk, right? And as discussed, it was set up accordingly. So there should be all the information that I was discussing. You have your subnets. This falls under your networking part. You have your IAM role as well that is associated with it, which ensures your instance is safe and secure for your usage. Okay. And post that, you have other things on your plate as well. Okay. So let's just go ahead and see how this application works. I say copy. Once I copy it, I come here. Oh no. I just basically go ahead and paste it here. Congratulations, you have successfully created a pipeline that retrieved this source application from an Amazon S3 bucket and deployed it to 3 Amazon EC2 instances using AWS Codedeploy. As I mentioned at the start of the session or at the demo, that I would be using a repository that was meant for doing something else that I had done in the past. I deployed an application to 3 different instances to check what happens when the strength of the instance goes down. But as I mentioned, I would be using the same code, but this time I've deployed it only to 1 instance and for a different application. But the message remains the same because this is the piece of code or the text that would be there in the source file. So if you come back here, right, GitHub. So if you take a look at some file, I'm not sure what is the name of the file. Where do we get it? I'll have to look into it. Cannot recall. I think it should be index. No. So basically, yep, this is where the code has been set accordingly, right? So if I change it now, right, deployed it to 3 instances, and that is why it is displaying that code to me there. Okay. This is something that we had used for the other application that we deployed, and that is why the message is still there. Do not get fooled by that, but I believe the gist for you is clear, right? As in what was to be done and what we've done out of it. So we've successfully done that. Let's just go ahead and get rid of all these resources that are there on our plate because we do not want to get charged unnecessarily. I'm going to just go ahead and try and delete all of these one by one. So let's start by deleting the environment. Copy the name of the environment because it would ask you what environment you want to delete. To do that, just come here and say terminate. See, it asks for the name, so paste it there and say terminate. So again, this resource would be deleted for you and you do not have to worry about what happens next. So once this thing is deleted, we also have to delete other things that are there in our hand, but let's delete them one by one. The reason I want to do one by one is some of these resources are interconnected. So if you try to delete the other one before deleting the first one, occasionally it gives an error. So let us follow the same pattern in which we came in, right? So let's just delete this environment first. Because we are talking about everything getting deleted here. So once this gets deleted, even the instance that was set with it, even that will get deleted. So let's just go back and see what's happening. Okay. Now it says 0 instances running. Why is that? Because the instance got terminated. Because we deleted the environment that was along with it. Now what we do is, we come back here. Let's see whether everything is cleaned up. Okay, so it is under the phase of getting deleted any which way. Well, let's just wait for it to actually go ahead and get deleted completely. So this will happen. Do not worry about that. Let's just close this, go to services, and now we go to Codepipeline. We would want to get rid of the pipeline that we have. So I say delete. In this case, I type delete. And there you go. Your pipeline is also deleted. So we've actually gone ahead and successfully implemented or seen how you can actually go ahead and implement DevOps on top of AWS, right? So again, guys, there are a lot of things that you can do. You can move an application into on a production server as well, right here. So there are a lot of things you can actually go ahead and bring in your applications from different places that you have, move it to AWS, and then actually go ahead and host it using the services that AWS has to offer to us. Okay, this is something that should have been terminated by now. It isn't, but let's ignore that. Also, what we'll have here is, if I go to S3, there would be certain buckets that would be created. I don't think all the buckets get deleted when you delete an environment, right? So there you go. You have like Elastic Beanstalk, AP South, the bucket that we used, right? So you have similar buckets that are present here, but these are not the ones that we've used. I think our buckets, okay, no, this is the one. So this is the one that I created recently. Again, not the one that we created today. So the buckets, some stay, some get deleted, but the buckets won't charge you anything unless and until there's data in it. So we should not worry about that. So if I come here, okay, let me try one thing out. You see SAM repo. So whatever data was there in my repo, it's here. You see, it's making a copy of it here. So this is something that I did not create now. This was for the demo sake that I had used this, but it is still here. So your data remains here when you talk about S3, and this is where your data gets stored when you actually go ahead and create the resources using AWS Codepipeline or other AWS DevOps services. So I believe the gist is clear to you people, as in what all can you do with AWS DevOps. Okay. If there's anything else that we need to look into, let's quickly scan through the AWS services that we have on our plate, or AWS DevOps services that we have on our plate. So I'm going to go into the services part. And in the developer tools, let's see what Cloud9 or X-Ray does. Okay. So if I click on X-Ray, you see that it is a service that makes it easy for developers to actually go ahead and analyze the behavior of their distributed applications by providing request tracing, exception collection, and profiling capabilities. So basically it is used for debugging, tracing, and service map. Okay. Okay, so this was about the different AWS services that we have in our hand or in our plate. I believe by now what DevOps is clear to you people, and you have some gist as in how DevOps works on top of AWS, right? So as I've already mentioned, DevOps is something that is trending a lot these days, and people are wanting to make a career in DevOps. So I've actually got these questions from quite a few people here, as in, what is DevOps? Can we use it on AWS? So I normally have these sessions that I take where people ask these kind of questions, as in, can we use DevOps with AWS? How is AWS and DevOps similar or different? So people are still very unaware about what DevOps is, what you can do with it, and how AWS supports these services, right? So when you talk about DevOps, there's a lot of scope, and this sets one foot in the right direction. make sure you actually go ahead and explore these services a little more and try to build these applications. You can also try doing that, what I mentioned, right? You can actually go ahead and have applications deployed to 3 different instances and check the availability of it, as in what happens if one of these instances does actually decide to go down. Okay. So that's it. Let's end the AWS DevOps part here. So machine learning is something that has been discussed a lot in recent times. Now, whether you talk about machine learning, data science, cloud computing, AWS, big data, RPA, DevOps. Now, these are some of these things. When you talk about from a technological career, people normally refer these terms a lot, right? Programming, technology, software development, data analysis. These are the terms that have been trending a lot. If we talk about the anything that has come after 2010s mostly. So people have been attracted rather towards these terms. And it's understandable with the advent of internet, with the advent of technology, data and all these things have become a lot more important. And that is why we see people having a trend or a psyche where they feel that they should do these things to have a good career. And that is fairly understandable. Even marketers have realized that these are the things that are selling points, and people are actually trying to brain your head in such a manner that you would actually feel attracted toward these terms. So since there's so much hype about machine learning, right? Let's talk about what machine learning is, and then we'll actually go ahead and discuss how we can carry out or how machine learning, data science, big data, all these things are supported by AWS, Amazon Web Services, right? So let's first try and understand what machine learning is to start with. So again, in simple words, I mean, this is a very simple definition that you see, and it's very true about machine learning. It is an ability of your machines to learn and become smarter, right? So to give you an example, right? When you talk about machines, when you press a button, they do a particular activity, right? When you talk about machine learning, you're trying to make them smarter. Now you might say that this is artificial intelligence in a way. Yeah, it's true. But machine learning is also similar to that. Basically, machine learning forms the foundation of whatever we do with artificial intelligence, right? So let's try and discuss these pointers. Okay. So let's try and understand machine learning first, what it is. Okay. So if I were to talk about machine learning, right, I would give you an example of we as human beings, right? I mean, when we are born, we are clean slates, right? I mean, we can write anything on the slate and it's there, right? We all have been part of schools where we've written stuff on board, erased that, right? I mean, as a child, in childhood, rubbing that board was a fantasy for me for some reason. I don't know. I wished teacher gave me control of the duster that was there and the chalks that we had, right? So we could control all those things. So that was a fantasy for me. Could not be for you, but it was for me actually. So coming back to the topic in hand. So basically when I say clean slate, on those boards you can write anything and rub it, right? You have control over it. So even we as children, our brains are like these clean slates, right? I mean, whatever we write there, it gets written there. Say for example, I come from a Marathi family and we speak Marathi at home. So to say come here, we say ikde ye, that means come here, right? In English, you would say please come here or whatever you have to. When you talk about Marathi and these things or these languages, right? So how do we learn them? Basically, our parents or the surrounding where we are born and brought up, we hear about these things and those get imprinted in our mind, right? Say for example, I am also a fluent Hindi speaker, and the reason for that is the school I was brought up in. There were quite a few students who used to speak Hindi there, and with them I basically learned Hindi very well. So that is what education does. That is what learning something does to you, right? I mean, how do we know a particular shape is round, a particular shape is square, a particular color is blue, a particular color is black, right? Because that has been imparted to us. It's not always that you have to tell that this is blue, this is blue, this is blue. You learn it with time, right? You see things, you try to imagine those things, and you actually go ahead and grasp those things. So that is how your mind works. Something that is imprinted on it again and again and again, you tend to remember those things. Now, it comes to you naturally. You don't have to be told that this is circle, this is square. Same is with driving or riding as well, right? I mean, when you learn to ride a bike, when you're new, you would always be cautious. What is the speed of the bike and when should you change the gear, right? But as you get smoother or used to it, you don't have to look at your speed meter, right? You just know that, okay, I need to change the gear now. That comes with experience because that thing gets imparted in your mind and you know when to do what. So responsiveness is also a type of learning something, right? Responding to situations. So when you talk about machine learning, that is what we do with our machines. We give them data that they can actually process again and again and again till they learn it, master it. So if I give a new data to a machine, it should be able to figure out that this is what that data is about. Say for example, what you see on the screen is a Scrabble, right? If I basically train my machine to understand what kind of Scrabble it is, in this case, it would figure out that the red one is an odd man out. Why? Because it has been trained with the data that is white in color maybe. So if there's something that is off place, it would recognize that part there and there right away, right? So this is what machine learning does for you, but in sense of a machine. You train machines to be smarter. It may not be always where you have a robot where you tell it what to do, what not to. Say for example, when you say a robot that picks up Coca-Cola cans for you from your refrigerator, that has machine learning imparted in it, but that may not always be an application for you. When you say machine learning, it can be as basic as predicting whether I have, say, let's assume I have 10 samples with me. Out of those samples, if there's a particular person who has cancer or not, right? Figuring that thing out is also machine learning. As simple as that. So when you say machine learning, basically what we try to do is we try to find out solutions to the problems that are there in our hand. So given the fact that there's a lot of data that is being generated these days, people have realized that this data could be utilized for doing so many things, right? I mean, you can predict patterns, you can predict what's going to happen, you can study trends and understand where this trend would take you at this rate. It is something that was done prior as well, but people who were smart enough or active enough could do that. But now with the amount of data that we have and the tools that we have, this has become a lot more easier for us to do. And that is what machine learning lets us do. Let's just go ahead and take a look at another example, right? So what company's logo does this image match, right? So I'm sure all of you have guessed it by now correctly. So it's very similar to what YouTube logo looks like, right? The reason you see this on screen is recently I was actually going ahead and playing some music on YouTube. Not recently, now this is a trend that I've noticed for a very long time. So what YouTube does is if I watch a certain set of videos, right? Let's assume that I watch Pokemon cartoon. Okay, let's assume that. So when I watch Pokemon cartoon, next time when I open YouTube, it would suggest me Pokemon related stuff. What this YouTube does here is it does collaborative filtering. It understands that I've been watching Pokemon related stuff, so it will suggest that. It will also study what people who watch similar videos also watch. So if there are other people, like hundreds of people who watch similar stuff, apart from this video, what else do they watch? So it will suggest that to me. Same happens with, recently I was looking out for shoes. I looked for shoes on Amazon and then I moved into an application called as CricBuzz. Okay. I browsed it on my web page. CricBuzz is a cricket application that gives cricket scores. Cricket is a sport that is very popular in India. So while I was going through that CricBuzz app, what I also noticed was there were 2 suggestions of shoes for me, somewhere from Amazon and other websites as well. So even this website is doing collaborative filtering and understanding what is, based on the data that I was surfing, it understood what I wanted to buy, what I was looking for. This sounds dangerous as in I'm searching it somewhere else and even CricBuzz knows that. But this happens because I've been logged in with same account everywhere and my data is accessible to these websites. Yes, scary, but what I want you to focus on the marvel as in how quick recommendation systems and collaborative filtering is working. And all these things work on machine learning algorithms or basically data science algorithms. So that is what machine learning does for you. Let's just go ahead and understand some of the types that machine learning has to offer to us. Okay. So if we talk about types of machine learning, right? So there's supervised learning and unsupervised learning. I do not take credit for these images, guys, that you see on the screen. I think it is, I do not remember the name of this. I've actually picked it up from somewhere. So I do not want to take any credit for these images that are there on the screen. These do not belong to me. So if there are any copyright issues, forgive me for that. So basically when you talk about these images, what I'm trying to make a point here is basically we are talking about supervised learning and unsupervised learning. So when you talk about machine learning algorithms, there are three actually. There's supervised, there's unsupervised, and then you have reinforcement learning as well. Let's try and understand these one by one. So when you say supervised learning, right? So basically when you say supervised learning, these are the set of algorithms where you know your target variable. That means you know what are you trying to achieve here. As I mentioned, if I give you a set of data and I say predict whether, build a model based on this data and predict for the given record if this person has cancer or not, right? Or let's assume I give you 20,000 records of telecom industry data. Then I pass in a new user data and say, based on the data you have, predict whether this person will churn or not. So what is churn? Basically, when you talk about telecom industry, there are a lot of people who buy SIM cards, right? It is how frequent that is we actually change the SIM cards. It's very frequent. People will just buy a SIM card. After that, they'll be bored and they'll throw it away and buy a new one. So when a customer leaves telecom industry or a particular SIM card and opts for something else, it is called as churning. And in telecom industry, this is a very big thing because it is getting stagnated. There are a lot of companies out there in the market, and if a customer leaves, they suffer a lot of losses. The reason for that is a lot of money is invested in marketing and bringing these customers in. So they try to preserve that those customers. So telecom churn is a big industry out there. Okay. So companies like, Reliance and all, they actually study these trends, and that is how they had captured the market initially with that Reliance Jio SIM in India, especially. Okay. So lakhs and lakhs of people bought those, and they covered a lot of market. So they actually did this churn analysis and a lot of other things. So basically, churn analysis and predicting whether somebody will have a cancer or not, these are examples of supervised learning. So these are basically your regression models that you're running, right? You even have your classification models where you classify your data into certain groups, okay? But here you know what your target variable is. Let's say I ask you to classify data into male and female. In that case, it would be your classification algorithm used here. So you are building a machine learning algorithm that will help you classify your data based on the data it has already studied. Okay. So that is one example. What you see on the screen is again an example, right? You pass in data that is apple. My system will predict whether it's an apple or not, right? So it is a supervised learning algorithm. Then you have your unsupervised learning algorithm. Here you do not know what a target variable is. You just pass in a source of data and it will basically classify the data into clusters to which it feels that data is similar to. Say for example, it will cluster all the apples together, peaches together, and bananas together. In this case, I know what those are. If I do not know, when I say I do not know the final output here, right? Target variable. What I mean is, let's suppose that I'm taking clusters or making numbers, clusters of numbers, right? So in that case, I might not always know the mean, but what what machine learning does is it basically creates those means and saves data around those means in one cluster. That is what clustering does. So clustering is an example of unsupervised learning algorithm. And then you have reinforcement learning, where you reinforce certain set of information onto your instances or onto your reinforce certain set of learning on your models, basically, so that they predict better results every now and then. So basically, unless and until you get the desired result, you keep on repeating the process of learning your machine until you get good and perfect answers. So that is what reinforcement learning does for you. So guys, these are some of the different machine learning algorithms that are there in our hand. Okay. And this is what machine learning is all about. If you talk about machine learning, there are quite a few other algorithms as well, right? You have your random forest algorithms. We haven't explored classification algorithms to a bit, neither regression algorithms. So if we talk about machine learning, it is a vast and deep topic. We can talk a lot about it. But since we are in an AWS session, I wanted you to get introduced to what machine learning is. And I believe I've made my point, right? Now what we are going to do is we are going to go ahead and discuss how machine learning works with AWS. So to actually go ahead and explore different machine learning services that AWS has to offer to us. Okay guys, so we've already seen what machine learning is, right? We've understood what are different machine learning algorithms. Now let us go ahead and discuss how machine learning works on top of AWS, right? So when you talk about AWS has also realized that machine learning is very important. People are wanting to learn machine learning, and since AWS is a platform that lets you do almost everything related to technology, so it wondered why not have machine learning services as well. Not just machine learning services, we would be discussing cognitive services as well, right? We would understand how artificial intelligence, natural language processing, machine learning, and to some extent data science, BI, how do these things work on top of cloud? So this is not going to be a very demo heavy stuff. I'm not going to get into machine learning details, but I'll tell you how these services work. What all can you do with these services, right? So let us just go ahead and take a look at some of the major services, as in what are the services that AWS offers to implement machine learning. Okay, so when you talk about machine learning on top of AWS, there are quite a few services. There are some services that provide you infrastructure, right? I mean, so we've discussed what infrastructure is, what platform is, and what software is when you talk about service models that AWS offers, right? So when you talk about machine learning in particular, AWS offers different services that actually let you take care of different requirements as well, right? Say for example, if you have like services like SageMaker and all, right? So this is where you have your platform in place, right? Because with AWS SageMaker, you can actually go ahead and use already existing notebooks or put your code in there. You can set up your infrastructure by using the IaaS services that are there in your hand. And you also have application based services where you don't have to code, you don't have to worry about the platform. Just go ahead and implement some of the applications that are already there for you. So we'll be taking a look at those services as well. Do not worry about that. So we'll discuss all of these in detail. Let's quickly take a look at some of the services that we have on our plate or on our slide to start with. So when you talk about machine learning on top of AWS or all the services that I just mentioned, right? Data science, AI, natural language processing. So all of these, I mean, there are some services that let you do these things. Say for example, Amazon SageMaker. Now this is a very good service which lets you build end-to-end analytics solution here. So to give you an example, let's assume you have a data set with you. You can actually go ahead and create an environment where you have Python running with you. You can get in that code. You can actually go ahead and train and test that code, right? Build in that data set rather, train and test it, divide it into proper training and testing data set, right? Build machine learning models using it, and then predict or ask some of the questions that you wanted to these models, and you'll get answers here. There are some ready to use notebooks as well, where these machine learning models have already been defined. All you have to do is put in your data there, some pieces of code, and your machine learning models will start working. So when you talk about Amazon SageMaker, it is an end-to-end service that lets you take care of all these pointers, all these issues that concern machine learning or data science in general. Next you have is your Amazon Comprehend. Now this is a natural language processing application service that AWS offers. So this application is ready to use. All you have to do is put in your data, okay, and you'll get results. So you might wonder as in how is it different from SageMaker, right? So SageMaker is more towards building machine learning algorithms, right? Or putting in machine learning data and creating algorithms and generating insights out of it. When you talk about Comprehend in general, it is a simpler version where application is ready for you. In this case, let's assume that you have to do sentiment analysis. So all you do is you put in your data. Let's example, you have a review with you. You put in that review there and it would do sentiment analysis on that review. So there is a plugin that is available that lets you do all these things, or an API rather that lets you do all these things. So that is what Comprehend does. Basically, it lets you do natural language processing on top of AWS. Then you have your Lex, right? So when you talk about Amazon Lex, Lex is a service that lets you build chatbots. Okay. So when you say chatbots, chatbots are nothing but interactive. You can think of it as an interactive software that can be installed or comes with any particular application or website. So if I put in a question, I'm expecting an answer there, right? So instead of having manual support members to sit and require or respond to your queries, if there are certain general queries, these chatbots let you reply to those queries. So when you say chatbots, these are nothing but bots or robots that people or websites put it on those websites, right? Where if there are some mundane queries that need answering to, these chatbots can answer those for you. To give you an example, when you visit certain websites, there would be a pop-up saying that, hello, how may I help you, right? So it could be a chatbot. So if you type in a particular query, it has a data set with it and it replies to that data set that is put in there. So that is what Amazon Lex does. It actually lets you go ahead and build those kind of chatbots for your usage. Okay. Then you have your Amazon Poly. So what Amazon Poly does is you give in text to Amazon Poly and it converts it into speech. Say for example, I say a particular sentence, right? What Amazon Poly would do is not say, I write a particular sentence and give it to it. So Amazon Poly would use a particular kind of voice to say that particular sentence. So here I have options of customizing what kind of voice I want, right? What kind of things I want to say, whether it should be a male voice, a female voice, whether it should be an Indian access, American access and stuff like that, right? So that is what Poly does. It creates lifelike speech for you based on the text you give it. Then you have Amazon Rekognition. Now Amazon Rekognition is a powerful service. It lets you analyze basically images and even video streaming. So it gives you real-time analysis in these cases. So nowadays there are so many images that come into picture, right? So images can also tell you a lot of story or give you a lot of insight, right? So what Amazon Rekognition does is it helps you extract that information from an image and in some cases even videos as well, right? So it works in the animation frame of mind. What do I mean by that? Say for example, when you talk about animation, right? How do you animate something? There is a series of pictures that is thrown in, right? So these pictures have different motions. Each of these pictures will have a minor adjustment. So if there are like 1,000 pictures, 1,000 picture might convey a particular motion of walking, right? So when you have a video that is running in, what Amazon Rekognition does is it takes snaps of those videos and it would give you information based on the images it has. So it breaks down a video into images and gives you real-time analysis on that. So it works on the similar principle as in how images are analyzed here, but what it does is for videos, it breaks down that videos into images, right? We'll see this once we get into the demo part. So when I say we'll see this, we won't be seeing how videos are analyzed, but I'll give you an idea about that. So Amazon Deep Lens. So when you say Deep Lens, this is where a lot of, okay, we'll discuss this once we get into the demo part. I don't want to talk about it now. We'll get into the demo part and then we'll discuss this. And then you have Amazon Textract. So what is Amazon Textract? So again, Amazon Textract is something that we can discuss in the demo part. These are two things that I want you to take a look at when we get into it, because I personally not use these services a lot. So let's not talk about them a lot. Let's jump into the demo part and see what are the offerings of these services that we have in our hand, right? So let's do that. Okay, to do that, I will have to go ahead and log into my AWS console, right? So let's quickly log into it. So it would say log back in. I am user or root user. In this case, it's a root user. Let's not get into the details of all these. And just say STA. And there you go. I've successfully logged into my management console. Now we are going to go ahead and take a look at some of the services that I discussed, right? So as I've mentioned, guys, I won't be building machine learning models since I am not a pro in machine learning, I'm more towards the cloud side of things, and I love being towards the cloud side of things, but I will give you a general idea as to how machine learning services work. But if you scroll down here, there are certain tutorials for you to actually go ahead and implement. So if you want, you can try out some of these, right? How to host a static website. Okay, these are compute things. If you click on machine learning, you'll get an idea, right? So how deep learning works, how to train a model, how to create machine learning models automatically. So there are quite a few applications here, right? When you talk about AWS, it gives you a plethora of projects that have different timelines. You can learn them from scratch and do quite a few things. Say for example, bots just got better. So this again uses .NET Core and uses Lex to create a bot. And in 1.5 hours, you'll be having a bot, a .NET bot that can be integrated with your Facebook or other accounts as well, where you can sit and chat with the demo application that you've created. So there are quite a few applications, not just machine learning. There are other domains as well. What I would suggest is you come here and try out these things. Okay. Going back to the console again. Let's go back to our machine learning part that we wanted to discuss. So as you can see, if I scroll down here, right, there should be machine learning somewhere. It has that brain kind of a sign. There you go. And see guys, the services are so many. I mean, I haven't even listed all of these. I talked about some 7 to 8, but there are a lot of services. And to be very honest, I haven't used many of those, because what Amazon does is it keeps on adding these services like regularly. So if you want to, you might come here and explore some of the other services as well. Let's first talk about Amazon SageMaker to start with. So when you talk about Amazon SageMaker, it lets you build, train and deploy machine learning models at scale, right? So you can read as in whatever you want to hear. So AWS gives you specific instructions, what you can do and what you can't. So see, you can literally label your data, build it, train it, right? Tune, deploy, and even discover your data, right? So, I mean, you have all these options here, whether you want to deploy your existing application onto an instance or on a PaaS or on a particular application that you built somewhere else on premise, right? So you can do that. So this is more or less an end-to-end solution, right? Right from building a machine learning model. I mean, it's not just about doing machine learning. It's about actually creating applications that support machine learning as well, and even giving you the freedom of actually deploying those to the application that you want to deploy it to. So how does it work? Again, as I've mentioned, I'm not going to go ahead and show you how to create machine learning models, but I'll give you a gist as in how do these things work here. Okay. So you can see you have a dashboard here. So all the information would come in here, right? If you want to label jobs, you want to label your data sets, you can do it here, get information on that. Notebook instances, if there are any particular notebook instances that you configured, you can save it on AWS. You can also use the predefined notebook instances that AWS provides you with. Okay. So since there are so many machine learning algorithms, AWS has created templates for you to actually go ahead and use those. You can even pick up your code from Git repositories if you have any. Okay. You can train and test your data, right? Whatever you have. For inference too, there are options here. Model packages, models, compilation jobs, endpoints, right? Augmented AI. You have some data on that as well here. If you want to do that, you can do that. And there are some, there's a marketplace that AWS offers quite a few applications, quite a few other things that concern AWS services. So you can explore those as well if you want to. Okay. If I go to AWS SageMaker Studio, Studio is currently not available in your region. Okay. So guys, AWS SageMaker, if I'm not wrong, it is free for some duration. So when you create an account, it would be free for you for a few months, initial few months. Once that is done, you'll be charged. Okay. So make sure you use it very carefully. So the first time you launch your AWS SageMaker, you can use it for like some 2 to 3 months if I'm not wrong. I do not remember the exact time, but this is what the standard time is. So let's stick to North Virginia, right? So all the services AWS has, I think those are active here because this is the primary region. Let's just say launch Amazon SageMaker Studio, and there you go. What do you want to do? If you want to learn more about it, you can open all these. Right? So you'll get information on all these pages. What can you do here? Okay. The detailed document is what I'm referring to. Okay. Yeah, so all the information is given here. See, let Amazon SageMaker handle configuration, right? So it will take care of all your configuration thing. What you need is you need to give in some details. Say default username, this is the one that is there. It will say choose an IAM role. I would say create a custom IAM role. Do I have one with me? Let's see if we can use this. Okay. And I have an option of standard setup. So there's a quick setup as well. So if I say quick start, yeah, it would set up everything for me by default. So I can use this. If I go to standard setup, I will have to decide all these things. A single sign-on, what kind of access I want. Do I want to create another IAM roles and stuff like that? So it would ask me details about the authentication method, about the other details that I want to enter. So this is giving me more customization options if I have. But as I mentioned, we are not going to get into the details. So let's stick to a quick start guide and say submit. So what AWS will do is it will go ahead and create a notebook for me on its own. Not notebook. It would create an environment for me. Okay. So preparing Amazon SageMaker Studio, we are configuring quick start user for you. Okay. This might take a few minutes. So, what will happen here is I would be getting access to quite a few things here once my SageMaker Studio is up and running for me. Okay. So let's wait for a minute and see where this takes us henceforth. Okay. Normally it does not take a long while for all this to fall in place, but there could be some loading that is happening here and that is taking time. So let's quickly just wait. We'll wait for like a minute. If it does not happen, we'll go ahead and do something else so that we do not have to spend too much time waiting for it, right? So let's just refresh this once more. Okay, there you go. So it is ready to use, right? What can be done with it, right? So this is the execution role that is there, that is available for me to use, right? And what are the other things I can do with my studio? Okay, so let's just go back to the dashboard for a minute. In recent activities, it says there's no recent activity. That's surprising. So let's go back to our studio. Okay, so it says it is already in use. Let's just open Studio here. The artwork is nice here, whatever is happening. This is the best thing about companies like AWS. They focus on all these minor details, right? So it's launching a Jupyter server for me, but still it is taking like a lot of time to load. What I'm going to do is I'm going to just go ahead and do something else meanwhile, right? We'll come back to this thing because it's taking umpteen time to actually go ahead and load. We should not wait this long for this thing to work. So let's just go ahead and take a look at something else. Let's see what else we can do with it. Okay, so going back to the services, the machine learning services that we have, let's take a look at some of the cognitive services that we have in our hand, right? So the first one that we'll talk about is AWS Comprehend. So guys, when you say AWS Comprehend, I've already mentioned it is an NLP service that is there in our hand. So in this demo, we'll have to actually Google quite a few things because we'll be needing images, reviews and stuff like that to see how do these things work. So let's do that one by one. Okay. Okay. So first and foremost, what I need is I need to launch Amazon Comprehend. So guys, let's see. See, it gives an option for you to actually go ahead and put in your input text. So this is the inbuilt text that I have with me. Let's see whether it gives me analysis on it or not. There you go. You see, it tells me that, see guys, this is the text that was there by default. So it says Amazon.com Inc. is located in Seattle and was founded in so and so date by Jeff Bezos. Okay. If you've not read about Jeff Bezos use case, as in how AWS came into picture and what all did they do, I would suggest you read it. It's nice. Okay. So allowing customers to buy everything from books to vendors. Seattle in north of Portland and south of something. So basically this is what are the keywords that it has noticed from it, right? So when you say text analysis, it would pick up the words that are there and try to analyze what kind of emotions are there, what kind of words are we talking about. So some part of text mining also happens here. Say for example, Amazon.inc, it knows it's an organization, right? It is confident 84%. So it uses machine learning as well here. Okay. A text analysis or text mining, to be very simple. Seattle, it's a location and it's 98% sure. 5th of July is a date plus 99% sure. Jeff Bezos is a person, right? So it's collecting information like this about all the keywords. If I click on application integration, right? So you'll get to see all the code that is here, right? So, I mean, this is the code that is calculating all the data for the entities. You see, this was the first one, organization. So 84% of the criterion met for it. So this is the text it has analyzed and this is the piece of code it has used to do that for us, right? So this was about one thing, right? If I come here and if I say sentiment, so it's 99% sure that it is neutral. Okay. No positive, no negative here. So, I mean, this is not the best of data that I would want to take a look at. Syntax wise, it gives me information as well. What is verb, what is noun, what is punctuation. So basically it classifies the data into ways that you would not even think about. Right? Language, English, 99% sure, right? So let's try and do one thing. Let's just go ahead and pick up some reviews from somewhere, right? Let's do sentiment analysis or see how it does sentiment analysis for us in a better manner. So let's see. Let's see if we can get some sample reviews. Let's just say book review for some popular books, right? The Alchemist. So there would be some reviews that people have given in here, right? Let's just go ahead and take a look at those reviews. 92% of Google users liked it. Where are the reviews? When I normally see stuff, I get reviews so quickly. So let's just quickly see where we can get reviews. Okay. I was just being blind to stuff that is here, right? So this is the review I have in hand. Let me just copy it and come back here. Where did that thing go? Here. So guys, what I want you to do is read the review yourself first, right? So this looks like a positive review, right? Inspirational story of Santiago, Dulce, the boys, his parents. It's not okay. Here too, we do not have a lot of clear review, but let's see how it analyzes it, right? So again, I'll get information as in it's the title of the book, name of the person, right? So basically all the details are here, right? So if I go to sentiment, let's see whether it figures out something here. It's positive. 95% it is sure that the thing is positive, right? Let's just go ahead and try to figure out a negative review, right? Is there somebody who's given? I don't think we'll get a negative review for Alchemist, right? So it's very difficult to figure out. Let's just search for negative reviews in general. Of Alchemist only. So that keeps us uniform here. Okay, so my Quora banned me. The English translation is crap. Okay, so probably it's not a bad review for the book. Probably they're talking about the translation that it has. Let me just copy it and paste it here. So I'm gonna just go ahead and clear this text for now, or probably I'll have to go up and paste it here. Okay, and I say analyze. So you can see, if we go to sentiment, it would say it's 99% negative. So it's basically figured out that there are keywords here, right? There are negative keywords, and based on that, it says that the review for this book is negative, or the text that I've entered is negative, and it is 99% sure. So it does good amount of sentiment analysis for you, figures out entities if it can find some good entities, right? And even lets you get text information as well, whether what kind of syntax is being used here, right? What is what in a particular sentence, and with the confidence value as well. And all this can be tracked, right? I mean, if I just come here and scroll down, right, I'll get all the information that I want in this piece of code, and I can even copy this code and probably analyze it a little more if I want to, right? So this is what one service is, that is Amazon Comprehend. Let us go ahead and take a look at some other services as well, right? So I'm gonna just go ahead and first see what's happening in our Jupyter Amazon Studio, right? So I say create a notebook, right? So if I click on it, it will give me an option, right? If I want to choose a kernel, see, I told you, you can choose a platform for it, right? So I can decide if I want to use a particular type of Python notebook that I want, right? So it gives me options, right? Whether it's MXNet, CPU optimized, right? Base Python, TensorFlow optimized, right? So I can choose one of these. So even if I see, say, base Python and I say select, it will create a notebook for me, right? I can give a name to this notebook, right? So how do we change it? There should be some option. You can change the name of it and save it as a particular notebook basically. Okay. So this is how you actually go ahead and use what you have on your plate. Okay. So there are options here. What kind of kernel you want to use? How do you want to save your documents, right? What experiments are you running, right? Are there any particular endpoints? Do you want to connect to your Git if you have your existing code, right? And there was an option where you could actually select the notebooks. I cannot find it here because I've launched the studio. You can do it in the console as well. So this is where you'll get more options, but the gist is clear to you, right? I mean, what all can we do with it? So the possibilities are good, right? You can launch these kind of notebooks as well. What do you want to do, right? And decide all these things here. So from a machine learning perspective, I'm sure there are a lot of things that you can do. And the notebook that I opened, right, as I mentioned, you can also get template codes. So all you have to do is change a couple of lines there. Say for example, a template machine learning model would be built for you. You have to change the train and test data that you put in there. You can make some changes to the type of model that you're running and enter some values, and you can run that piece of code there and there. So the options are plenty when you talk about AWS SageMaker, right? So if I come here and I go to my SageMaker, I would want to delete all the environment that I've created. It is a paid service, as I've already mentioned, right? So make sure you go ahead and get rid of all the resources that you've created, right? How do I delete a studio that I've created? Okay, this is the problem of not getting a lot of hands-on on this resource. I will have to see how to delete it. So I'll get this done later. I should not be focusing or wasting your time on these things. So I'll get my resource deleted, my studio deleted later. If you want to, you can do that as well. Figure out how to do it and do not spend your time doing these things. Something that I'm doing right now. Okay. So let's go back, right? Talk about other services. So we've seen how Comprehend works. We have some idea about how AWS SageMaker works. Some idea, as I mentioned. I haven't gone into the details of it. Let's talk about some other services that are also there with us. Okay. So where did that machine learning thing go? Okay, this is the problem of having many services, right? Comprehend is done. Let's talk about Poly. So when you click on Amazon Poly, right, it, as I mentioned, it converts your text to speech here. So let's just go ahead and pick the review that we had, right? I'll say copy. I'll come back here and paste it, right? So you have an option of SSML as well, okay, but we'll be sticking to plain text, and let's just go ahead and listen to it.
The English translation is crap. I don't know if the fault lies in Coelho or the translator, but it's a very...
Okay, so right now guys, the problem is, the reason you cannot hear this thing is, I am recording this session with a recording mic that is attached, right? So I don't think you will be able to hear whatever is being said here. To be very simple enough, clear enough, the problem for that is, see, basically when you record using a mic, so this mic does not support hearing content out of it. This is a one-way mic, so I won't be able to display that to people, but what you have to do is just go ahead and click on listen to speech, and it will read all this text here for you. What are the other options that you have, right? Engine is neutral, and the voice that I've chosen is female here by default.
I think most people who were in my high school English class...
I can actually go ahead and change it to something else as well, right? English, I can even have an option in it. Now there are other options, right? You have Welsh, you have French, Canadian, Hindi as well. So this would be more of an Indian accent. I mean, this English would sound like how Indians speak. I mean, how people who are fluent with Hindi, they have a particular accent when they speak in English, right? So it would be in that sort of an accent, more of an Indian accent. If you go and like click on French, it would be English in a French accent. So you can choose that. I mean, what accent do you want to do? As I've mentioned, just try this. If I remove the mic now, I would be able to hear it, but that would spoil the recording that I'm doing for you people. So ensure that you try it on yourself, and I'm very certain that this will work for you without any problem. So try out different voices, try out different sources, and try to pick in data from different places to get a better output out of it. Okay. Yeah. So let's go ahead and search for Textract and see what it does, right? So easily extract text and data from your documents. Okay. So can we try that? Let's see. I haven't tried Textract till time, right? So let's upload a particular document here. There are articles, and I'm sure, okay, there's no article here. This is surprising. I think it picks in a particular format. How can that be possible? Okay, so let's not do that. I think it is some document specific based on which you can decide what kind of document that you want to upload, but I think it should have had an option. Let's just pick an image and see what it does for us. There you go. So it has picked up whatever data that was there, and probably it has extracted data. I mean, this is very difficult to understand this data. So these are some of the things that it has come across on the screen, right? So some of the text says or talks about these things, right? So Rohan Jadhav, Raj Mondre, these are some of the people that are, the names are being displayed on the image. So it has picked up all those things, right? So it can extract data from an image, right? So you can try out other documents as well here and play with it. So that gives you some idea what Textract does. Now let us go ahead and explore some of the services like Amazon Rekognition. Now this is an important service. Okay, so it says try demo. The interface of AWS has changed in recent times. So that is why everything looks so different here. But this is a very interesting service and I like it a lot. So there are a lot of things that you can do with this service, right? So let's try and see these things one by one. What all can we do with it, right? How do we do with it? So object and scene detection, right? So this is an image here. It says upload your own image. So let me just go ahead and download a particular image. Let's search for Amsterdam. Okay. And when I look for images, let's see what all information it gives me. I'm sure the image or the information would be on surface, but this is a JPEG image, so let's just go ahead and put it on the desktop, right? AMS is what I will save it with, so that we find it earlier or quicker rather. So we don't need these. Okay, come here and let's upload that image. So when I say upload, I go back to my desktop and I pick this AMS image. You see buildings, right? And it's giving me all the information that it concerns transportation, because it sees all these cycles here, right? If I click on show more, it will give me more information. Bicycles, it has recognized there are bicycles. 92% says there are bikes as well. I don't see any, but bicycles are there for sure, right? If I open this image, it will give me information about this particular image, right? There you go, right? So town, urban, city, all the information that concerns this image, it can give you that. So what are the other things that we do? Let's see facial analysis. So it tells how happy this person is, right? You can see that the person appears to be female, age range is particular, all those things. Let's do it more realistically. Let's go ahead and see some of the images that I may have with me. For that, I'll have to get into Great Learning, live sessions, profile pictures. I may have some. Yep. So people, I'm 29 years of age. Let's see what okay, so it has given that range, right? So it thinks it's 29 to 45, so it's hoping that I'm elder. So I'm like roughly 30 years of age now. So that gives you some ideas, and it predicts these things correctly, right? Looks like a face, appears to be male, age range, smiling. 72% it is certain that I'm smiling, right? So these are the pointers it is focusing on. If I open custom images, it will give me this information. Appears to be male. Okay, so this is not very correct because there are females here as well, but it has focused on this particular face, right? Now in this case, it looks to be a female, right? You can see. So looks like a female. So this is very accurate. It knows what to scan, how to scan, right? So if I select a particular image, it will give me information about that only. Let's say we download an image of some angry person here. There you go. Let's try this out. So let me just upload this image here, and I go back to my desktop again. This was the image, if I'm not wrong. There you go. Appears to be male, age range 26 to 42, younger than me. Not smiling, appears to be angry, 93% it is certain, not wearing glasses. So there you go. It understands these things very nicely, right? It also does celebrity recognition for you, right? So Jeff Bezos, famous personality, right? I mean, we all know, if you know AWS, you should know Jeff Bezos. If not, read about it. Okay, let's look for some celebrity. So let's search for Salman Khan. In India, Salman Khan is very popular. He's an actor. Okay, let's see whether this image is recognizable. Let's see whether it figures out Salman Khan, or as they call him, Bhai in the country, right? Okay, no, so it wasn't an image that I wanted it to download. Yeah, this one is in JPG format, so this should be we should be able to read this. Let's just drag and drop it. Salman Khan, it is 100% sure. Similarly, if you look for Tom Cruise, I'm sure it will recognize Tom Cruise as well. So the reason I'm doing this is it also helps you compare faces if you want to. Right now it knows both of them are Salman Khan and Tom Cruise, right? Let's do face comparison. So I'm gonna put in two different images here, right? Let's put in Tom Cruise here. So now it says it does not match in any possible way. Let's compare him with Salman Khan. Nope. And if I just put in Tom Cruise with Tom Cruise, similarity 100%. Let's try it with some other Tom Cruise image, right? When he used to look a little different. Okay, let's try this out. If this is an image, we'll download this. Here's JPEG. And let's now compare him with this image. 99.9% it is sure that these are same people. Right? So there are possibilities or there are things that you can do here, right? Video analysis is something that you can do. I've not done it, to be very frank, myself. But you can do video analysis as well here. So you may try that out, explore this a lot. I don't think there's a lot that needs to be talked about in this particular piece of demo. So I'm gonna just go ahead and meanwhile skip this. I'm gonna talk about some other service. Let me go back and let's search for Lex now. Okay, the chatbot service that I talked about. So when you open Lex, right, this is where you can actually go ahead and create your bot. So I had created a demo here, order flowers. I think I never deleted it. So let me do that now. Okay, it says you cannot delete it right now. So let it be here. Let me create some other chatbot. Let's say book trip. So guys, these are the things that you need to know. Intent, right? A particular goal that the user wants to achieve. In this case, book a hotel. Utterances, spoken or typed phrases that invoke your intent, right? Slots, data the user must enter. Prompts, questions that could be asked by a bot. So this is what you would write by yourself. This is what the bot should reply, something like that. So you have these things, right? Intents, utterances, slots, prompts, and fulfillment. So some of these things are controlled by your bot. Okay, so let's just go ahead and create one bot. Okay, so we'll call it book trip. Sentiment analysis, no, not required. Create an IAM role, use a basic one. Coppa, don't need it. So please indicate if your use of this bot is subject to children. No. I mean, it can be, but that's not a problem for us. We are not getting into the details of that right now. The sample utterances. What does it say? Say, book a hotel. Hotel it was, right? Book a hotel for me. Book trip built was successful. Let's just test it. Do we have any specific responses with us? Can we try these sample utterances here? I'm not sure. What city are you staying in? Pune. What day do you want to check in? 15th August. How many nights would you be staying here? 2 nights. Let's say 2 again. What type of room do you want? I want a king room. Okay, so I have you down for a 2-night stay in Pune. Starting this date, shall I book the reservation? Yes. Okay, so all the information has been saved here. Okay, so this is how a basic chatbot would reply to your queries. So this was a template bot that I used. I mean, you can create your own chatbot as well. So when you create your own chatbot, you'd be entering information in a different manner, right? So first of all, you would be needing a knowledge base. Knowledge base is nothing but a source where you store all this data. Okay. Say for example, if I am using, or I have an application that works on for food delivery, right? So I'd be having a database that gives me answers to the questions that are related to that. My questions would be, where is my order? Why is the delivery boy late? Why am I being charged extra? Stuff like that, right? So there would be a database that I can create, and I can pass in this database to that chat. So some general queries would be replied normally. Okay. And in case if those queries are not answered, then you can connect to a customer agent, right? Who can actually, or customer representative who would actually give you information on these pointers. So what this does is that helps you reduce your manual work. So basically what that would mean is, if there are queries that can be attended by a machine, I may not have to pay a lot for all the employees who are working, right? Their life would also be easy. So that is what chatbots do for you. So this was a sample chatbot. As I mentioned, you can deploy it to different applications. I had shown you that there's a project there for 1.5 hours. It lets you create a template like this and then create a .NET application as well, and then publish it to different platforms. So you may want to try that out as well. Okay. But as far as the basic bot goes, I think this is good. I can even publish it if I want to, but I don't want to do that right now. So yep, we've actually gone ahead and explored basic machine learning services and other services that AWS offers that concerns analytics, natural language processing, text mining and stuff like that, right? There's one more service called as Amazon QuickSight. Okay, which is not free, else I would have given you a demo of it as well. So this service is a paid service. Okay, you have to upgrade to a paid version. And if you do that, then you can actually go ahead and use the service. So this is more of your Power BI or Tableau kind of a service where you can visualize your data, just giving your data sets and start creating visualizations using this particular service. Okay. So I believe we've talked about quite a few pointers. Let me quickly just go ahead and stop for now. We'll go ahead and talk about some other things going ahead. Okay. So guys, let us now go ahead and understand AWS Security Services. As I've already mentioned, when you talk about security, AWS gives you a special importance. Now, I had mentioned that, or I do mention that in many of my sessions, that if you've not read the use case of Jeff Bezos, okay, do go through it. What it tells is how Jeff Bezos, or what came to the AWS founders' mind to actually go ahead and bring AWS to life. What are the struggles? What are the challenges that they had faced while doing that? One of the challenges was the security part. Now, if you talk about myths of AWS, one of the major concerns that people will put forth is that cloud is not secure enough, or AWS is not secure enough, which is not true. I mean, if you talk about the way security is dealt with these days, it is very good. But if you go back to like 2010, 2011, 12, there were a lot of outages that used to happen, and the ones that happened in the time frame that I mentioned, there were some major ones where there was a lot of data loss, and that caused a lot of problems. But after that, the way security is handled has changed a lot. As you can see on the screen, right, what it says that AWS offers shared security model to its consumers, right, or customers is what you can say. That means AWS controls few security aspects, and some are controlled by you as a consumer. As a consumer, you get to control identity and access management of a security. So rest is not important. So basically what this point says is it gives you shared security model. Now that is one way of looking at the security perspective. So when you say shared security model, what it means is you get to control certain aspects of security as a consumer, and AWS as the owner controls some aspects from a vending perspective or a vendor perspective. Okay. So apart from that, what AWS also does is it takes care of both your physical and network security. So when you say physical security, we are talking about the data centers, right? One, as I mentioned, there are multiple data centers across the globe. You can always back up your data at different data centers. These data centers are like conditionally located at 60 kilometers, 40 kilometers apart from each other. That means even if one of the regions is struck by some natural calamity, it reaching the other region is very rare, the calamity. Okay. And if you backed up your data in the other region, there are more chances of your applications being available always. And it is like 99.99999% available. So that means in a year, an outage could be maximum to half an hour, right? So if you've been using the service for like 365 days, 24 hours, it could be half hour to the max that you might experience outage in total. So that also will not happen on a continuous basis. And this is an estimation that it could go to that level. Now, and anything you do across the globe is not 100% accurate, right? So that is a very good amount of availability, right? If you talk about these regions, physical security also means that these data centers are physically manned by people. They are guarded and governed by people physically 24/7. Not many know where do these data centers are located. So it's not that you know that there's a data center in Mumbai. You just move to Mumbai and you say to a taxi driver, take me to AWS data center. No, they can't do that. The locations are not known to everyone. There are few officials who know those locations, and only few operators actually know where these data centers actually are. Even if you know the name of the region, you do not know where in that region those data centers are located. So talking about it from a physical security perspective, it is actually taken care of by AWS to a very great extent. What are the other aspects? Now, when you talk about network security, right? So you need firewalls that govern your resources when the data moves through network, right? So if it starts from a particular point, it should reach the other point, and there should be a guarding that happens at both points, right? So there are services that let you build firewalls and ensure that the data moves between the network securely. There are services that let you encrypt your data as well to ensure that your data is safe and secure. There are also services that ensure the health checks, management of resources, deciding which resources or which area of the network is healthy for you to actually deploy your data there. So all these things are taken care by AWS. And then you have IAM as well. We'll talk about IAM in detail. Do not worry about that. This is one of those services which is very important when you take a look at it from an AWS perspective. So we'll discuss IAM in detail, and we'll also understand what are these other services that you see on the screen, right? So let's just go ahead and talk about them one by one. Yeah, so the first service on our plate is IAM. It is a security web service offered by AWS to ensure that users get access to resources at appropriate level of permissions, and it offers shared access, deals with user and group level accesses, and it also controls centralized and granular level accesses. Okay, let's just go ahead and understand these pointers a little more, right? So when you talk about IAM, okay, let me just write it down somewhere so that I can explain it better to you. So what do we do here? Let's just go ahead and open a notepad. So the pointers that we need to focus on are users, security groups, then you have roles, you also have policies. Okay, so let's try and talk about these a little, right, one by one. So let's assume that we have a server with us. Okay, so when you talk about a server, right, so basically when you say AWS, you have your application resting. So basically it is resting on one of the servers, right? One of the data centers that AWS has to offer to you. So when you talk about your data being put, so there is a virtual wall that has been built for you, right? Inside which you put in your data, right? So who gets to cross that wall and get access to this data, right? There would be users. Even when you talk about users, there are types in it, right? You have your administrators, right? You have your root user. You have your consumers. Your consumers can be anything, right? Administrators is one example. Other example of consumers can be your business analyst who needs some analytic access to your data, right? Business analyst. It could be your a web developer or a person who is more interested in GUI access, who gets to access only the GUI part of it. A developer who is more interested in programmatic access, right? So when you talk about a user is somebody who gets to access your resources, right? Let me take you to IAM to talk about these pointers a little more. So I'm going to open my console, AWS Management Console. It says sign into the console. I'm not logging back in. I'm saying sign into the. Okay, it has signed in by default. Let me log out. Now let me sign into my console. Please don't get me signed in right away. Okay, so guys, it says root user, right? I can also have an IAM user using which I can sign in. Okay, so for now, let's just go to root user. So root user is your main user for which you've created an account, right? So I have an account here. Let me just sign into my root user. So I've signed into my root user. Preferably you should not use your root users if you are talking about an organizational level application, right? There would be multiple users in it. Root user should be used in cases where there are no other options left. You want to reset your passwords, you've lost your passwords, then you use your root user. What you do is you create an admin account, an admin account who has many accesses to the resources that you want to use, or the major accesses to the resources that you want to use. So let's just go ahead and open IAM here. Now IAM is nothing but your identity and access management service, right? You see, there are options here. Users, there's one that is created already. Visual Studio. Okay, so this was for one of the demos I had created. So let me go ahead and add one more user. Let's call it Vishal, right? My name. What kind of access? See guys, you get to choose the kind of access do you want to give to your user, right? It can be your programmatic access. It can be your AWS Management Console access as well, right? Or you can give him both. So enables an access key ID and secret access for the API. Okay, I'll talk about this. Do not worry about that. And enables a password that allows the user to sign in, right? So I'm going to select programmatic. I need both accesses. So let these be there. Okay. Auto generated password. Do I want to generate one? No, let's use a custom one, right? And let's just say require user to reset. No. What this does is if I try to log in again, right, it would ask me to reset the password. I don't want that to happen. Let's say next. Okay, let's close this for now. Create a group. We'll do that later. Okay, next tags. Next. Previous. What kind of access do I want to have this person to have? Let's say administrator access. Next. And I say create a user. So guys, copy this data. This is very important. I'll tell you why this is important. Do not worry about that. So I'm gonna copy this and keep it with me. Okay, let me just paste it here. Okay. And let me just go back and copy. When you say show, it will show this thing to you only once. Okay. So make sure you copy this and paste it somewhere. There you go. So I have it with me. So I say hide again. Okay, it shows again. No, that's not the thing that you get to see it only once. You can even ask somebody to mail it as well for your access. And I say close. Okay. So I have, this is MFA, that is multi-factor authentication. What multi-factor authentication does is when I try to log into my account, it would ask me to log in with more than one ingredient or more than one criteria, right? Say for example, I'll have to give in 2 deliverables to it. One would be my password, one can be an OTP that is generated to ensure double layer of security. So you can activate MFA as well if you want. Okay. So let's just come here to Vishal, right? Let's copy this user ARN, right? If I come to the dashboard, this is how I can sign in now as a user. Let me copy it here and let me paste it here. I'll show you what to do with it. Okay. Now I'll log out from here. Okay. There you go. And I click on this icon. So this is a user console through which I can sign in with a different user that I have. Okay. Okay. So this is the user ID. What was the name? It was Vishal. Okay. And what was the password? So guys, I've logged in as an administrator here, okay, with the account Vishal. Never. You see, it hasn't signed in as the main ID, that is tutorial, something that I use right for the demo. It has signed in from this ID, which is different. Okay. So you might have wondered that I've been displaying all the passwords and stuff. You do not worry. I'm going to delete those user credentials once the demo is done. So there won't be any harm caused. You too make sure that you do not display your passwords to anyone. Okay. So let's go back to IAM. So we've created a user, right? So this way you can create different users who have different accesses to different resources, right? Then there's one more thing called as groups, right? So I've put forth groups here as well, right? So when you say a security group, now you've created a user who can do different things, right? Whether it can be a management console access or a programmatic access. So when I say a programmatic access, they can work with the data using APIs as well. Okay. Console access is something that keeps you limited to the AWS console. As a user, right, I might also be put into certain security groups. So when you say a group, you group similar people together. Say developers can be put into one group and they have similar kind of access to a particular resource, right? So that is what groups does. To do that, let me create one more user here. Let's call it demo user. Okay. And this time I give it just AWS Management Console access. So this is the password, right? This time it did not give me that key that I wanted, right? So I can just log into this demo user. Let's do that. Let's sign out. Let's say demo user. And this was the password. Let's see if I can sign in here, right? Oh, I will have to change the password here. See, that is why I do not click on that option which says that do you want to reset it, because then you have to remember your passwords and go through all this mess. Something that I'm going through right now. I hope it changes this time around. Yes, it has changed. And if I go to IAM, welcome. See, I'm not authorized to do any one of these. Why? Because this is a root user that I've created, right? So if I were to sign in here, let's say I log out from here for now. Okay. Now I sign in with my Vishal account, that is my administrator account. So I've signed into this account, right? So if I go to IAM now, I have access to quite a few things that I can do here, right? If I come here in groups, let's say I group actions. Okay, no group was created. So let's call it sample group. Okay. And I say create. In this group, I want to give somebody particular set of access. So what is the set of access that I can give to people? So I can give access to people based to the services that you see, right? So Codepipeline is one that is here, S3 demo. So I think these are the buckets that I have, right? So let me just say next, create a group. So whoever is in this bucket or in this group will have access to the buckets that I've mentioned. Okay. If I select this and add users to the group, I can add this demo user here, right? So demo user was the one who had limited access. Okay. So I add this user here. There you go. So the user has been added here. I know this has been a lot of to and fro where I log out, then sign in, but I want you to see something, right? Okay. There you go. So I've signed into this user now, right? So if I just come here, okay, and if I just open S3, okay, so no access was given here, so I did something wrong there, right? So basically what I was trying to say is this is a plain user who has no access to anything. But if I just go ahead and give this user some IAM access, he should be able to do it. But for that, I'll have to again log into my admin account because right now this user is not authorized to do anything. Okay. You see, absolutely nothing to do. So even if I sign into EC2, right? Okay, I can launch some instances here. So by default, maybe it has that access. So basically you can control this, right? As an admin, I can decide what access goes to whom, right? Who controls what part of the resources and how do they work around it. So basically this is what my IAM does. So we've talked about what groups does. In groups, I can decide who gets to access what. Unfortunately, we did not give that user proper accesses, else we could have worked around it a little better. And these are the other things that we need to discuss. But before that, let's quickly, for one last time, sign out from here. Okay. And then log back in from our root account. The reason I want to do that is I want to delete all the resources that I've created. Okay. No, this is taking me to the AWS Management Console, normal console, log back in. So I'm signing into my root account now. The reason I'm doing that is I've already told you people why that is happening. So there you go. I'm just gonna go ahead to IAM and remove these resources for now. I don't want them to be around. So I'm gonna just go ahead and say delete these users for me. Yes, delete. Okay, and I'm gonna go to groups and delete the group as well. So there you go. So we've actually gone ahead and see how do these things work. Now there are other pointers that you need to know, right? Roles and policies, right? So roles are something that basically concern applications. So when you talk about users, right? we talked about how users can have access to resources, but what about applications? How do they communicate with each other? So I can set in certain rules that decide how do these applications interact with other applications and users that are there. So controlling their access is something that comes under roles. Okay. And policies are something where you can actually code certain things. Okay. So when I say you can code certain things, I'm referring to the fact that as a user, you can actually go ahead and basically control as to what resources you can access using a particular piece of code. Say for example, I'm writing a bucket policy. So I can write a bucket policy that says that after a particular duration, back up this data or replicate this data in some other bucket in some other region, right? So that is a bucket policy. So I can write such bucket policies. I can write such policies that tell me how do my applications interact with each other and what triggers to pull when I'm actually going ahead and using these applications, right? So this was about IAM and how to use them. Let us go back and talk about some other services that are there in our hand. Okay. Okay. So now let us go ahead and understand the other services that are there in your hands, right? So as I've mentioned, AWS gives you more access. So all we've discussed till time is who gets to access what are the users, what are security groups, what are policies, right? I believe I've also mentioned what multi-factor authentication is. If not, let me reiterate that for you, right? So when you say multi-factor authentication, right? To give you an example, these days what Google does is it gives you two-step authentication process. So when you say two-step authentication process, so basically one, you'll have to enter in your password as well, right? So your Gmail ID and your password is something that you enter. Once you log in, it would ask you for an OTP and it would connect you to your mobile phone. So if you've entered your mobile phone number, your SIM card number there, right? So it would throw in an OTP on your registered mobile number. Now that is where you actually go ahead and get information about, or you get an additional login to your so-called account, right? So that is what your multi-factor authentication does. It gives you more than one option to log into your resources that are there at your disposal. Okay. The other thing now we are going to go ahead and explore is what is WAF. Okay. So WAF is basically a firewall service that AWS offers, right? So as you can see on the screen, when you say WAF, this is some explanation that is given here. I'm not good with reading all these things, but if you are a technical person, you would know that basically what firewalls are, right? These help you protect your applications over a network from cyber threats, right? Network cyber threats. So WAF does exactly that for you. Okay. What it does is it helps you configure certain set of rules to allow, monitor, or even block web applications access request as per rules defined. Okay. So when you say WAF, it is also known as your web application firewall. Okay. What are the benefits it gives you? It basically lets you have agile protection against web attacks. So that means you have rule propagation and updates that take less than a minute actually to actually go ahead and let you update the security principle across your environment. So if there is any issue that arrives, that can be resolved within a minute, right? Since you have managed rules with you, it also helps you save a lot of time for you. Okay. Another important point that you need to know is it gives you more visibility in terms of traffic. And why does this happen? Because what it does is it gives you real-time visibility into web traffic that you can use to create new rules as well, and even for alerts. Now there's a service called as Amazon Cloudwatch. Using it, you can create alerts or triggers. So if you meet a particular limit or if you set a particular threshold in AWS Cloudwatch, and if that threshold is met, an alert would be thrown in right away, so that it ensures that if such alerts are thrown in, your network security is taken to a next level. Okay. So this was about AWS WAF, which basically stands for Web Application Firewalls. Next is your AWS KMS. Now KMS is basically a data encryption service. Okay. So if you are again a computer engineer or a networking student, you might have heard about data encryption, which is very crucial, right? I mean, if you talk about any source of data, basically, it is very important that you encrypt it before you move it over the network. Why is that? Because when your data moves over the network, that is where there is the largest chance for it being corrupted or it being caught up by someone and putting it under the corruption that you're not wanting it to go through. I talked about firewalls just right. So what firewalls do is they preserve your end-to-end networks, right? I mean, when I say end-to-end, not end-to-end, the ends of the network. To give you an example, let's assume that your data moves from network A to network B, or a point A in a network to point B. So point A and point B can be secured by firewalls. Those are like the entry gates. But what about the data that moves over the network between these two entry points, right? So this is where encrypting your data ensures that even if your data is caught up over the network, not anybody can just go ahead and make changes to it. You'd be needing your public and private key to encrypt this data and then get access to all the data that is there. So that is what KMS does for you, right? I mean, it ensures that your data is secure by encryption. So as you can read in the definition, it is a common practice to preserve your data on networks. With Amazon KMS, you can safely encrypt your data that moves over the AWS Cloud Platform network, and your keys are also kept safe by using hardware security modules. So this is an added layer of security to ensure even your keys are secured when you talk about your AWS platform. What are the benefits that you have in your hand? These services are fully managed, right? I mean, whether you talk about the access, that is the only thing that you control to your encrypted data, right? You can control certain parameters, but whether you talk about defining permissions or doing other things, AWS can enforce these things for you. Now there's something called as central key management. What it does is it gives you a center point of control where you can control all these pointers. What kind of access do you want to give it? How do you want to give that access to it and stuff like that? Okay. And this happens from a central point. So you have this central point of management that ensures that there is one place where you can control all these things. You can even manage the encryption for your services, right? So there are quite a few integrations that AWS offers, and it simplifies the process how you use these keys to encrypt your data and also manage the AWS workloads. The other thing that you need to know is you can encrypt data in your applications as well. So what this does is it also supports encryption for SDKs to enable that, or basically to actually go ahead and enable the use of KMS protected data encryption keys to encrypt your data locally. Okay. You can digitally sign in as well, and it ensures that all these things happen at a very low cost. So this was about your KMS, right? Next you have your AWS Shield in hand. So when you say AWS Shield, again, it is something that helps you control DDoS attack. Let me tell you what a DDoS attack is. Okay. To give you an example, let's assume that you are trying to log into a particular website, but you just cannot log in. I'll give you more specific example to this. Let's assume that there's a live session happening on a particular channel. Okay. Say for example, it is happening on GoToWebinar or something like Zoom. So this will have a limit of somewhere around 500 users or 1000 users. Okay. What I've done is I've actually gone ahead and sent in a link to the users who I want them to attend my session. So in this case, let's assume that there are like 1000 people that I've shared the link to, and the limit for the software offers is like 500 users. So once I have 500 users trying to access that resource, and after that, if somebody else tries to log in, that person will not get ability or would not be allowed to log into that system or that session. Why is that? Because I've reached the maximum limit. Now, when you talk about DDoS attack, it works in similar fashion. Let's assume that you want to log into some website or something, or do something that is on priority for you. But what some users do is, people who want to fail a particular application from working, they'll throw in a DDoS attack. Now, a DDoS attack, what it does is, it throws in some pseudo requests, and it throws in those pseudo requests at such a pace that you will just not be able to log in, because there would always be a pseudo request there, forcing you to get denial or basically denied of that service. That is why it is called as distributed denial of service access. That means you won't be able to access into resources. What AWS Shield does is it basically ensures that your system is free from DDoS attacks. So it comes with 2 levels of protection and multi-level authentication. So unless and until you are a fraud user, unless and until you are a genuine user, you won't be able to log in. Fraud users would be filtered there and there in the network itself, and you won't face distributed denial of service issues. Okay. So this was about AWS Shield. Then we have our Trusted Advisor. So when you talk about Trusted Advisor, it acts as an inspector. Okay. So when I say an inspector, basically a Trusted Advisor is something that monitors your applications on top of cloud, in this case, AWS. So this individual service is basically responsible for inspecting your AWS environment to make recommendations that help save money, improve system performance, and even clear security gaps. So it analyzes your security that is there in your hand, right? And basically actually goes ahead and even makes suggestions as in how can you improve the security of your applications. So that is what Trusted Advisor does for you. So guys, this was about different AWS security services. I hope the idea of how AWS security services work is clear to you people. So guys, now let us go ahead and talk about AWS Management Tools. Okay. So when you say management or monitoring tools or governance tools, right now, these fall under one of the important service domains that AWS has to offer. Okay. So when you talk about management tools, these are very important. The reason management tools are important is because you have your applications that you build using cloud platforms, right? You move your applications to cloud. But it is highly important that you manage these applications. As I've mentioned, having resources to do these things, it can be a costly process, right? Also, you'd be involved in ensuring that these resources get rid of all these tasks or they do all these tasks. Now, occasionally what happens is it's not always that you are in a position where you can always go ahead and physically look after these people to get all these jobs done. And even if you ask people to get it done for you, the problem with this approach is these people might not be as diligent enough in order to wanting to do these tasks, because some of these tasks are repetitive, boring, right? So what if we had tools or services that let us actually keep track of all the logs that we had, trigger all the alarms for us, and do all such kind of events for us? Wouldn't that be nice, right? So when you talk about AWS offers plenty of such services for you to use. So we are going to go ahead and talk about these services one by one, right? To start with, we have some of these services here, like we have AWS Config, we have AWS CloudTrail, we have AWS Cloudwatch, and we also have AWS OpsWorks. So let us go ahead and try and understand these services one by one. So when you say AWS Cloudwatch, what AWS Cloudwatch does is it basically lets you go ahead and keep a watch on all the resources that are there in your AWS. Okay. So when I say all the resources, not all the resources, but major resources that you would want to keep track of. Okay. So with AWS Cloudwatch, you can do that. Okay. Other things that you can do with AWS Cloudwatch is, as I've already mentioned, basically, let's assume that you have certain instances that are working for you, right? So you can keep track of those instances, as in whether they are starting or stopping, whether the health is good or not. All those kind of activities can be controlled by your AWS Cloudwatch. So there are other services as well. You have AWS OpsWorks, right? AWS OpsWorks is more towards the what you would say DevOps side of things. So when you say DevOps side of things, when you run DevOps applications, when you actually go ahead and deploy these applications, right, there are a lot of things that happen in these applications. So the major ones that happen here is basically you are dealing with a lot of configuration codes that you have on your plate, right? You're dealing with a lot of applications that are there, right? You're dealing with a lot of data that moves to and fro. So when you deploy an application, right, there are certain activities that happen in parallel. So when you talk about OpsWorks, what it does is it lets you create cookbooks or recipes, or it gives you scripts that helps you automate these processes for you, create an environment that helps you automate whole of the process that I've just mentioned. Okay. So, we would be talking about all of these services. To some extent, we'll explore what do these services have to offer and try and understand what is there on a plate one by one. Do not worry about that. We'd also discuss what AWS config is, what AWS CloudTrail is, but let's wait for it. First, let's continue with AWS Cloudwatch and see what all can we do with AWS Cloudwatch. Okay. So what we'll understand is, first we know what it is now, right? We'll explore some of its core concepts, that is AWS Cloudwatch. Okay. Moving on, we'll talk about what are its events, and then going ahead, I'll give you a simple demo, right? As in, how does AWS Cloudwatch works? What are its logs and stuff like that? Okay. So, to give you a clearer picture, right? Let us consider certain scenarios. I'm gonna go ahead and use my simple notepad here. When you talk about the applications that AWS Cloudwatch has to offer to us, I'll consider certain scenarios, right? Let us consider scenario 1. I hope the screen is visible to you people. Okay, I'm gonna use a bigger font if that could be a problem. So when you talk about scenario 1, right? So let's consider the situation. Let's assume you have an application A. Or let's just go ahead and use Paint instead. Okay, so it's been a while I've used Paint actually. So let's try and do that. Let's assume that you have an application with you. Okay, so this is your application A. Okay, so the thing with your application A here is, guys, what it does is basically it is keeping, or it is experiencing certain amount of traffic, right? So the problem with this approach would be, there could be a situation where I do not have right monitoring tools. So in that case, let's assume that the traffic experienced by my application A has gone down. And I do not know the reason why that is happening, right? The reason for that could be, I might lack monitoring tools, because if that is the case, I am not able to figure out why is there a drop in this particular traffic. Why? Because I do not have any logs, or if I do, they're going unlisted. So as I mentioned, I need manpower to take care of all these things. But with AWS, you have Cloudwatch. What Cloudwatch does is, Cloudwatch ensures that all the data that comes to your application A, this data, one, it is getting monitored, right? All the logs are being maintained. If there is a situation where you feel that the health of your instance is going down, okay, in that case, you probably have resources that ensure that a right alarm is thrown in to you, to make sure that you work on the capacity, or you get to know why is this capacity for your particular instance down, and you can act on it and probably move your traffic to some other instance. So when you talk about monitoring, it takes care of these kind of activities. When you talk about, okay, what is this happening? Am I still using my old thing? Okay. So the other thing that basically happens here is, let's assume that if I have something like Cloudwatch, my traffic would again go back to being normal. If I have something that can help me figure out what had happened. Okay. This is not a very good example. Let's just go ahead and create some other thing, or consider some other example. Let's assume that I have an application with me. Okay. Now in this application, let's call it A, for instance. Okay. Now in this application, let's assume that my boss tells me that, Vishal, go ahead and figure out why are we paying so much for these applications? Can you cost optimize this particular application? So in this scenario, what I can do is, with my Cloudwatch, I can keep track of the spend that is happening here, right? Let's assume that my instance or my application is getting used more during the daytime. It's getting used lesser during the night time. Now, in that case, it is clear that all the traffic that is being experienced by my instances, that could be mostly during the daytime, and that is why it is costing me more. Okay. So this could be an important information for me, right? So there could be another scenario. Let's assume that you are being charged for certain services more during the daytime because that is when your traffic is active. So instead, maybe I can have my instances working in the other duration, or maybe I can optimize my instances in such a way that I do not get charged that much, right? So when you talk about Cloudwatch, it basically lets you keep track of information like this. Okay. The third scenario could be there's a particular customer that is visiting my website. There's an information about that customer, and probably that information is being tracked, but I'm not able to keep track of that information manually, and I lose that information and lose that particular customer. In that case, something like Cloudwatch would help, right? I would be able to keep track of all these things. So that is what Cloudwatch does for you in a nutshell, right? So basically, this is what your Cloudwatch does for you, right? I mean, it collects and tracks your key metrics that might impact your business, right? What it also does for you is it collects, monitors, and even stores some of the log files that concern your business, right? Sends system invites for AWS resources to AWS Lambda, SNS, etc., right? So these are some of the things it does. And another important thing that you need to know about AWS Cloudwatch is basically it works for quite a few applications, right? I mean, when you say quite a few applications, what are the applications that basically AWS Cloudwatch supports, right? You also need to know that. So what AWS Cloudwatch also does is it supports a plenty of services or resources that might support your business or your cloud applications, right? So some of the common services that you use when you are hosting an application can be your instances, right? Your IaaS services like EC2. Even if you use Elastic, Beanstalk or something like that, it will still have your EC2 instances as their core, right? Then you have databases where you put forth your data, something like Amazon RDS, right? You could even store your data in your S3, right? Elastic load balancers are something that help you distribute your traffic across the instances that you have. And finally, you have other AWS resources that you would use. So some of these resources that I just mentioned, or all of the resources that I just mentioned, can be monitored by your Cloudwatch. Okay. So that is what Cloudwatch does for you. So it basically monitors resources like EC2, databases, data stored in your S3, right? Elastic load balancers, and even your AWS resources in hand. Okay. So when you talk about Cloudwatch, what are the concepts that you should know when you're talking about this particular term? So the two things that we focus mostly on are a metric and a dimension. So when you say a metric, it is nothing but it's a time ordered set of data points, right? I mean, that you basically publish to your Cloudwatch. You can think of a metric as a variable that basically lets you monitor the data points that represent the value of that variable over time. Okay. And then you have a dimension. So basically dimension is nothing but a value pair, or a name value pair rather, for you, that uniquely identifies a particular metric. So metric is nothing but a set of data points that we're talking about, right? And when you talk about a dimension, it basically let you identifies your metric or puts a label on top of it. So that is what a dimension is. Something you can call it as an attribute rather. Okay. So when you talk about Amazon CloudWatch, these are the two things that you need to know. That is your metric and your dimension. And based on this data, you can actually go ahead and generate some statistics as well. So when you talk about AWS CloudWatch, there are two options that are in your plate or you can have with you. One of them is your basic monitoring capabilities it offers, right? So when you say basic monitoring capabilities, here, this is something that falls under your free tier limit. Okay. So with basic monitoring, what you can do is you can basically have free polls every 5 minutes for every metric that you generate. And when you talk about detailed monitoring, it's a paid service, right? It does not fall under your free tier and it polls every 1 minute with a wide range of metrics. So these are the two important bifurcations that you need to know, right? So one is your basic metric or monitoring rather, and the other one is your detailed monitoring. The pointers you need to know here is, this one is free tier eligible. And it gives you polls every 5 minutes, right? And when you talk about detailed monitoring, this is a paid service. So you'll have to pay for it, right? Does not fall under free tier. You'll be charged for it. And it polls every 2 minutes or 1 minute, sorry. Okay. So this is what your AWS Cloudwatch does. This is the facilities, or these are the options it provides you with. Let us go ahead and try and implement this using AWS. So guys, let's try and monitor CPU utilization using AWS Cloudwatch. So when you open your Cloudwatch, right, you'll see that there are quite a few options that we have on our plate. Okay, let's not first get started with Cloudwatch. The reason I'm telling you this is we would be needing an EC2 instance to monitor CPU utilization, right? We need some computing resource that is running. So let us launch one first. Let's launch a basic Windows instance to start with. I'm gonna pick the free tier eligible one, and there you go. So I'm gonna launch the basic version that is there. Review and launch. Guys, make sure that you keep your key safe with you. Okay, if you lose your key, then it could be a problem. Demo today 321. Okay, download the key pair and just go ahead and launch your instance. Okay, so the instance should be up and running. So by the time our instance gets ready, right, I'll tell you what we are going to do. So what we'll do is, one, we'll open our AWS Cloudwatch. Let me do it in different consoles so we can keep a track of it better. Okay. Let me open one more console again. So we have 3 consoles on a plate that are open and up and running. Okay. In one console, I'll open the Cloudwatch. There you go. And in the next console, I'll open, what do we need? We would be needing SNS if I'm not wrong. Okay. So guys, it's a simple notification service, right? It is a messaging service that AWS offers. Now, why do I need it? Okay. So basically you can subscribe to the messages that you need. Okay. So you can subscribe to a particular topic, and you can actually go ahead and get email notifications using these topics. So how do you do that? Okay, first say create a topic. So let's call it, what should I call my topic? Let's call it my topic. Okay, display name, my topic. Encryption optional, as in I've talked about the security part. So this tells you how secure AWS is, right? Let's create a topic. Your topic was created successfully. Okay. So when you create a topic, so under this topic, I can actually go ahead. Okay. I select this and so basically under a topic, what you can do is you can actually go ahead and send notifications to your email IDs, right? So you can have your email ID added and you can basically go ahead and get notifications here, right? So what we are going to do is we've created a topic already. I'll tell you how to configure your email ID here. And then what we'll do is we'll go to Cloudwatch, and this is where we'll create an alarm. Okay. So in your Cloudwatch, we can actually go ahead and create our alarms as well. As in, the alarms that we want our resources to be a part of, right? I mean, if I want to throw a low CPU utilization alarm, right? And what I would be doing here is, first I'd be creating an alarm to start with, right? So in this alarm, what I would do is, if there's a low CPU utilization, I want an email to go to my particular email ID. For that, I've created a topic here, right? But in that topic, we've actually not gone ahead and added a subscription yet, right? So this is the topic we have, right? So if I go to subscription, I can say create one. Okay. So I want to subscribe to this topic, my topic, right? Protocol should be email here, and I should be entering an email ID here. So let's just go ahead and let me add an email ID here. So this is a sample email ID I have with me. Okay, and I say create a subscription. So if anything happens here, the email would go to my email ID. Okay, so we have a subscription, we have an instance that is up and running for us, right? Let's just come here now and go to alarms. Okay, let me create an alarm. Let me select a metric to create an alarm, maybe EC2 instance. Okay, what metric I want is CPU utilization, right? CPU utilization, do I get it here in the option? It says there are 68 metrics. Let's see what are those. Status check failed. Yeah, I just saw CPU utilization. Okay, this is a painful thing to do. There you go. I'll select this. Okay, I'll say select metric. So instance ID, I think it has picked it up by default. I have an instance already that is up and running, right? Statistics, average, period, 5 minutes. I told you, right? For free tier, it is, we get a rollout every 5 minutes. Static anomaly detection, whenever it is greater than a particular threshold or whenever it is less than a particular threshold, right? So let's select maybe if it is lower, right? So what should this threshold value be? Okay, we need to define a particular threshold value for it. So let's just say we assume a value to be around 25. Do I need to add additional configurations? No, I just say next for now. Next. Okay, I need to add an email list here. No matching SNS topics found. Okay. Use the topic ARN instead. Or if I just type my topic, maybe we'll find it. Let's see if we find it. Nope. In alarm, this should not be a problem here. Let's just come here. Okay. Oh, okay. This is the problem. So this happened in Mumbai region. That was the problem. So the Cloudwatch that I'm trying to create here is in North Virginia. Let's see if we can go ahead and select Mumbai here. We do not have an option yet. So let's just come back here, right? Go to North Virginia. This is the region that is selected here, right? No problem. So what we'll do is we'll just come here and create one more topic. Let's create one, call it my new topic. My new topic again. Let's just say create. US East, so I think this should be good. I'm gonna go back to my topics, subscriptions. I'm gonna say create one for my new topic this time. Protocol should be email, and I'm gonna go ahead and add my email ID. Okay, let's just go ahead and say create. So this time we should have a topic here. Okay, so if I come back here now, my ARN is okay, and this should hopefully be supported here. Let's just create one on our own so that this does not cause a problem. Let's just say create a topic. There you go. So we've actually gone ahead and added this thing. Let's just say next. Alarm name, low CPU use. Description, let's skip this for now and say next. So there you go. So there would be an update that would be happening here, right? This alarm will trigger when the blue line goes below the red line. So if I have a CPU utilization performance that is below this line, it will trigger an alarm. So we have an instance that is running right now, right? So after 5 minutes, we'll get a track of it, whether it's below it or not, right? So we'll take a look at it later, right? For now, we've created an alarm here, right? So if you even turn off the instance, right? So its performance is gonna go below it. So if you like stop it, this performance should drop here considerably and you'll get the update here. So this is one of the metrics that you can control. There are other metrics as well that are there under your control, which you can control using AWS Cloudwatch, right? And there are quite a few things that you can actually go ahead and do with it. So this is AWS Cloudwatch. We'll come back to it. Okay. For now, let's go ahead and talk about something else, right? So another service that is there on our plates is AWS OpsWorks. Okay, so let's try and understand what AWS OpsWorks does, right? See, basically what it says is it's a configuration management service that helps you build, operate highly dynamic applications and propagate changes instantly, right? So as I've mentioned, right, when you talk about Chef and Puppet, these are basically a configuration tools that fall under DevOps. So when you talk about DevOps in general, right? So when you say DevOps, what DevOps does is it brings in your developers and operations team together. That means there would be a lot of configuration and integration that is happening constantly at a continuous manner. So that means you'll be picking up your pieces of code, right? You'd be putting it on a particular machine or an application or basically a build tool where you'd be building these applications, right? So when you build these applications, then they go through your testing phase, and then you finally go ahead and deploy your applications. What AWS OpsWorks basically does for you is it helps you configure or manage these operations, right? So when you have Chef and Puppet, right? These are automation tools that let you configure or basically allow you to use code to automate configurations of your servers, right? What OpsWorks does is it lets you use Chef and Puppet to automate how servers are configured, deployed, and managed across your Amazon EC2 instances. Okay. Now, when you talk about these instances, these are on your cloud, but if you have resources that are on-premise as well, or some compute environments, even those can be automated by using Chef and Puppet, which are automation DevOps tools. And this is something that is controlled by your OpsWorks. Okay. So when you talk about OpsWorks, what OpsWorks does is it gives you certain set of options. Okay. One is you have stacks with you, which contain layers. So when you say stacks are nothing but containers that hold certain set of files that you have with you. Okay. So these stacks basically will hold those files for you. And these files are nothing but your configuration files. Okay. Then you have instances with you, right? Instances where your data would reside. Okay. Or basically your applications would reside. Then you have your applications, right? That reside on your instance. And then you have your cookbooks here. This is an important part. So when you say cookbooks are nothing but collection of recipes. Recipes are nothing but scripts that make certain things happen. Okay. Basically they help you automate certain processes, right? So just like recipes in cooking, where they are nothing but a script that tell you how to cook a particular dish. Recipes here are nothing but certain scripts that let you automate certain processes or basically configure certain processes. And a collection of recipes is called as your cookbook. So basically your OpsWorks provides you with such cookbooks that help you automate these processes. So let's just go ahead and create a stack and see how it works, right? That would give you a better picture of what I'm trying to say. Okay, so you see, OpsWorks Stack is a configuration management service that helps you build and operate highly dynamic applications and propagate changes instantly. Okay, so register instances. Let's just say add your first stack. So guys, you see you have options, right? You have your Explore AWS OpsWorks Stack with a sample Node.js application. So we can create a sample application if you want. We can use Chef 12 stack as well. Bring your own cookbook. So basically cookbooks is a concept from Chef itself, right? So Chef, by the name itself, we can understand that it is an automation tool, but Chef that relates cooking. So when you talk about cookbooks and recipes, it is the term that came through it. So you can actually, if you have your own recipes or cookbooks or certain set of scripts that you want to bring in, you can bring in from your Chef as well and Chef 11 as well. So Puppet was something that, Chef is something that is very popularly used, and that is why I did not see Puppet being mentioned here. So that is why we have Chef that is being mentioned, and we'll discuss Chef only, or we are not going to discuss Chef either. We are just going to go ahead and use or explore basically AWS stacks that are there in our hand. So let's create one. Basically it will create a Node.js application, okay, that will help you explore the features of configuration options of OpsWorks, right? So what operating system do you want? We can just go ahead and pick a Linux operating system. So create stack. Since we are not going to get into the details of any of the instance, so it does not matter to us. Okay, so these are the things that would happen, guys, here. One, it would create a stack named my sample stack Linux, right? Then it would go ahead and create or basically set up the Chef cookbook for you. Then it would actually go ahead and create a layer or basically your application in simple words. Assign a recipe to deploy lifecycle event into the layer, and then actually it would go ahead and add the instance to the layer. So as you can see, what a stack is, it is a set of layers, instances, and related AWS resources whose configuration you want to manage together. Okay. So all this is getting managed inside this particular stack that we are trying to create. Okay. So let's see if our stack is up and ready. We may start the instance if we want to. So it is going ahead and getting my Node.js server in place. So this might take a minute, guys. Let's wait for it to happen. Okay, so meanwhile this happens, let's not waste our time. Let's talk about something else as well, right? So guys, there are other options that we have on our plate. We've discussed stacks to some extent, right? What a stack is, right? And then we have our layers here. In this case, we have our Node.js application. So as I mentioned, a stack will consider or contain a set of configuration files or your applications that you have. So those can be multiple. In this case, we have this Node.js server that we are actually deploying and it is in progress. If I go to start the instance, it will show that it is booting right now, right? My instance is getting booted. Let it boot. So in the instances that I have, I can choose the type of instance that I want, right? It can be time-based in nature. When I say time-based, basically I'm talking about OpsWorks that, here what I'm talking about is instance that you can schedule basically, right? For a specified duration when you wanted to actually go ahead and perform a particular action, right? You can use this time-based instance to control how many instances should be online at a certain time and day of the week. Load-based, so basically this would decide the kind of traffic that you're experiencing, right? See, this basically gives you load optimized or load based instances, right? So where your memory and application load changes across all the instances in a layer. When a metric needs it, or when a metric exceeds basically, its threshold goes up. So what happens is, OpsWorks basically goes ahead and launches multiple instances. So this is like load balancing, guys. That means let's assume that you have one instance that is running and then it experiences more traffic, right? So what AWS does is it goes ahead and launches more instances, or OpsWorks actually goes ahead and launches more instances for you to go ahead and use. Okay. Then you have certain deployment, monitoring and other features as well that are controlled by OpsWorks. But let's just go ahead and see if our stack is in place. Is it running? It's still booting. So let's just wait, right? Meanwhile, let's see what's happening in our Cloudwatch. Okay, this is new. So this is CPU utilization it is showing. Okay, so my sample stack Node.js server. So we've also launched a Node.js server, right? So it is showing data for that as well, right? I'm not sure where did our previous instance go that I had created. So let's just check whether it has thrown any alarm for us. I'm gonna go ahead and get into my incognito mode and try to log into my Gmail. So let's see what has happened there. I think I had used this demo email ID that I have with me. Let's see if we get any notifications there as to we have subscribed to something or not. There you go. I see you have chosen to subscribe to this particular topic. You can configure your subscription here if you want. Okay, so I have subscribed here. Maybe now I'll start getting notifications. Okay, so my new topic was the other one that I created, confirm subscription, and then the final one was this one. So now I should get notifications every 5 minutes as to what is happening with the instances that I have, right? you see, this is the detail that I have with me. So if something happens to my instances, I'll be getting notified here in my email ID. Okay. Let's see if our instance is up and running. The stack is taking longer than expected. It is running setup now. So let's just wait a minute more. So once this is up and ready, the color should turn to green, right? Giving me a notification saying that my application is up and running. It is functioning smoothly. The other things that we have on our plate, right? We have our region details here, our public IP as to the one that is assigned to my instance. Okay. So we'll understand what all we can do with it, but let's wait for it to first go ahead and launch. Okay, now that it is online, let's just go to our deployments for now. Okay. Say deploy an app. My sample Node.js app, deploy, and do I need to do anything else? I'm just gonna go ahead and say deploy. We've spent a lot of time waiting, so let's not do that. Okay, so there's another thing that is happening here. So guys, basically my OpsWorks is helping me communicate with my application and my server here, right? It has set up a sample Node.js server for me, and now I'm deploying my application on top of this Node.js server. So all the configuration and all the management part is something that is being controlled by my OpsWorks here. Okay. Okay, these things are taking like a lot of time. Let's just wait for this thing to happen quickly. Okay. So if I go to show log, it will show me all the log as to what has happened here, right? So all the actions that were performed here, those are visible to us as in what all happened here, right? You can see that we forked a particular instance and stuff like that. So these are all DevOps terms, forking and all. Basically, they come associated with your Git, right? So now that we have our log in place, now that we have all the data in place, right, whatever that we needed here, right? So what we can do is we can just go ahead and test our instance. How is it performing? How is it functioning to general, right? Stack, Node.js server. Let me go back to my instance here. Okay. They click on the IP address. So you've just deployed your first app with AWS OpsWorks, right? And there you go. This was made in Berlin. So this is something I did not know. They've actually played with the OpsWorks logo. It is similar. So when you combine all this or string this into one part, you'll get the green part I'm referring to. You'll get the logo. So guys, this is how the OpsWorks works, right? I mean, basically we've gotten some idea as to what AWS OpsWorks is, what all can you do with it, right? And how actually to go ahead and configure certain resources there. What we need to do now is we need to get rid of some of the resources that we've created, right? Okay. If I go to dashboard, you have no Cloudwatch dashboards. That's unfortunate. We spent so much time doing these things here and we don't have anything here. Let's just go back to our simple notification service, right? And delete the topics that we have. Delete. So these things are deleted. I'm sure the subscriptions also don't need to be deleted separately. I thought if you delete the topic, it would be taken care of, but no, we have to delete them separately. I've deleted these as well. Okay, Cloudwatch, I'll take care of it. I need to go back to my OpsWorks and ensure I delete all that is there. So guys, you can't delete my sample stack. Please stop and delete all the instances and apps in this stack first. Okay. So guys, basically you'll have to go back and delete all those instances that are there on your plate. Let's just go back, login, EC2. There should be 2 instances here. There you go, and I'm going to terminate both of them. So guys, the reason we are doing this is these instances, I mean, when you talk about a server being launched, you're going to be charged for it, right? So make sure you delete the instances and also the servers that are there on your plate. So when you say terminate, it's equivalent to getting deleted. Yes, terminate it, please. So I think it will shut these one by one, right? So if I terminate this again, yes, terminate. So once this is terminated, the other one would also get terminated. Okay, so this looks fine here. Now that this is terminated, let's just refresh it and try this again. Okay. Yeah, the reason we cannot delete it is because we have to go ahead and set up the termination policies straight for it. So guys, this is pretty much it. I mean, we've understood how AWS OpsWorks works, how AWS Cloudwatch works. Next, we'll go ahead and understand how AWS config also works. So guys, let us go ahead now and take a look at AWS config. I mean, what it is and how does it help, right? So we've been discussing AWS Management Tools till time, right? So we've discussed what config is. Sorry, we've discussed what Cloudwatch is, right? We've understood OpsWorks a little, right? We've taken a look at some of the other services that are there, but config is something that we haven't had touched upon, right? So let's just quickly go ahead and understand what AWS config is and what all does it offer, right? So when you talk about AWS config, yes, it is another management tool, right? But what it lets you do is it lets you do all that you see here on the screen, right? Whether you talk about ability to assess, audit, and even evaluate your configurations that AWS has to offer to you. Okay. It lets you continuously monitor, automate, and even record some of the configurations against the desired configurations that are there on your plate. Okay. So you can even automate some of the processes that are here, right? What are its benefits? It gives you benefits like, again, cost. When you talk about AWS, it is very cost effective. What it also does is you can even review the changes that are there in your configuration and find out relationships between your AWS resources, and then you can dive deeper into various resource configurations, whether you talk about dealing with historical data, whether you talk about determining your overall compliance against the configuration. You can take care of all those things, right? What are its benefits? One is continuous monitoring. Okay. So when you talk about AWS config, it enables you to continuously monitor the record configuration that are there, and even the changes that follow in these records or in these configurations rather. Okay. What it does is it also enables an inventory to you. Okay. So AWS has its management inventory. You can actually go ahead and connect to this inventory once you have your configuration service in place, and then you can get updates using that as well. Okay. What it also does is it gives you features like continuous assessment. So it allows you to continuously audit. We put forth a point here that says audit, right? So what it does is it lets you continuously audit and assess the overall compliance of your AWS resource configurations with your organization's policies, right? Whatever policies you have, whatever guidelines you have, it basically lets you comply with all those policies, or it basically complies with all those policies and then ensures that you get continuous assessment and audit of all these configurations. Okay. What it also does is it gives you an ability to define rules for provisioning and configuring your AWS services. When you talk about these rules, now these rules can be provisioned independently, right? Or you can even pack them together, rules that basically control similar factors. That is where you can have packaged set of rules for basically if you wish to remediate a particular kind of solution. This is where these packaged rules will help you, right? Now, apart from that, it also supports change management. Now guys, when you talk about ITIL processes, right? Change management is very important. You should be able to track all those changes. So if you talk about AWS config, it lets you manage those changes as well. Okay. Gives you operational troubleshooting. The fact that you are tracking so much data, it means that it becomes easier for you to actually go ahead and basically audit and even troubleshoot some of the issues that are there. Okay. When you talk about monitoring, now what it does is it gives you enterprise wide level of monitoring. Okay. How does it work? If you ask me, okay, basically what it does is, let's assume that you have your configuration that basically has occurred in your AWS resources, right? You move it to AWS config. What AWS config does is it basically records and normalizes all those changes into a consistent format. Okay. It also automatically evaluates some of these recorded configurations against the configuration that you specify. And then once this is done, it is passed on to other services you have. These can be your SNS, Cloudwatch, S3, even your config and other consoles that you have in nature. Okay. So this is where you can track all these resources from a history perspective, right? So basically what you are doing is all the logs that you have, right? So those logs get to be or need to be stored somewhere, right? Your configuration details, those get stored in your S3 bucket. Okay, and that is where a copy of it is maintained, and you can track it using your AWS config service. Basically, you can send in notifications to people using SNS service as well. So this was about how AWS config works, right? On a surface level, it is a monitoring and management tool that we have on our plate. Okay. So let's try and understand this tool a little more, right? Let's see what are the core terminologies that it has. Now you have AWS resources that it monitors to start with. So when you say AWS resources, we are talking about resources that can be tracked. Let's assume you're talking about an EC2 instance that you're trying to track, right? What happens when an instance is stopped? How does it work? All those things, right? How do I get the tracking details and all those things? Basically, those details would come, or you can track those using AWS config. Configuration items and snapshots. Configuration items are nothing but the data that the configurations that you generate, right? The logs and all those things. So you'll be having those. What snapshots means is you can actually make a copy of it for your reference later on if you wish to store it. Okay. Resource relationship. Now, when you're talking about all these resources, they are connected to each other. You can even study their relationships, as in what is happening, where is this data coming from, and all those things. And then you have your configuration stream and configuration recorder. Configuration stream is nothing but you'd be receiving data in batches, right? In patches. So these patches or these batches are nothing but your streams in which you receive your data. And then you have your configuration recorder as well. Something that lets you record this information that you're receiving in the form of stream, right? So these are some of the terminologies that fall under AWS config. And this is what AWS config is all about. Let us go ahead and take a look at a simpler demo that we can put forth, the demo that is there in our hands, right? Okay, so let us quickly sign into AWS Management Console as we always do to get our demo in place. So guys, when you actually try and get into the console, the first thing that we would do now is launch an EC2 instance, something that we'd be tracking, right? For that, I'll have to sign in first, root user. And there you go. I should be able to sign in successfully. Okay. So now the next step is to actually go ahead and launch our EC2 service. Okay. This should be nice. Let's say run. And let me launch an instance. Be it any instance, should not be important, but I'm going to launch a Windows instance. I always launch Windows instances. I have a thing for them. In simple words, those are easier to manage compared to other instances. That is why I always launch my Windows instances. If you talk about your Linux instances, right? Your Linux instances, basically what they do is you have to sign into it through an SSH mode of sign up, right? You have to generate putty generator is something that you have to use, and using that you have to generate your key, convert your PEM file into some other key, and that is a tedious process. The other thing that you have to do is you have to actually go ahead and basically sign into it using your command prompt. So why not use a GUI interface instead, right? That is why a Windows instance. Now all these pointers have been discussed with you people earlier as well, so I'm not gonna elaborate on these things. You know by now how to create an instance. So let me just go ahead and say pem.321. Let's download the key pair. pem.321 is downloaded for us, and let's just now say launch an EC2 instance. So it will take a couple of minutes for me to get this instance in place. Let it get launched first up. Once that is done, then we'll move further. The reason I want this instance to be up and running is no sooner it is up and running, we are gonna stop this instance, because I want to monitor its log, want to monitor some of the data that comes with it. Normally it takes like 15 to 20 minutes for this data to reflect, right? So let's just go ahead and let this instance launch first, so we can stop it like right away. There you go. You see one instance in progress being developed. Okay. It's always wise to let these initial checks happen. You see it's initializing for now, right? Once this initialization is done, we can move further. Okay. Okay, so the status checks are complete. Let us go ahead and let's not do anything. Just when we have to enable monitoring, say yes, monitoring enabled, and the other thing that we do is we stop this instance. Let's just say stop. There you go. So this is in place now. Now let us go back and say AWS config. So the name has changed. Now they call it AWS app config. Dynamic application configuration management. You can create, manage, and safely deploy application configuration data to your target runtime. No, the name hasn't changed. Probably we were into wrong service. That is why I wondered where did we get all this deployment and all those things coming in, right? So that is not a concern. It's a monitoring tool. We do not deal with deployments here. So if I click here, you will see settings, rules, and reviews, right? So in settings, record all the resources supported in this region, include global resources as well. Okay, select types for what? Okay, create a bucket here. Okay, so we'll have to create a new bucket, guys, right? So once we create a bucket, this is where all our configuration details would be stored. So I say stream configuration changes and notifications to my Amazon SNS topic. Create a topic, please do that. Config topic, let it be the name. So guys, basically whatever changes that happen, your configuration data would be stored here in this bucket. That is your S3 bucket. S3 bucket, as we know, is a object bucket kind of a storage where your data is in the form of objects and the container that holds it is your bucket. Topic. So when you say SNS, it is your simple notification service where you basically can subscribe to topics and subscriptions, or channels rather. If any changes happen there, you're notified in the form of subscriptions, just like we get emails, right? So topic name, let it be config. Create AWS config linked service role. Please do that and say next. Filter the rule. Okay, this is new. skip this for now. I'm gonna say confirm. So guys, this will take several seconds. Seconds is fine. I mean, seconds should not be a problem. All this while you've realized that we've been waiting for minutes for certain things to happen. Few seconds won't cause us problems. So let's just see what happens, right? Okay. There you go. So a dashboard has been created, right? So your resources are being discovered is what it says here. Should we add rules and stuff for now? Let's not do that. Let's just come here, see other things meanwhile. Okay, this is taking very long. For some reason, my internet is tremendously slow today. Let's wait at the dashboard. Complaint rules, complaint resource 00 right now. Okay. And let's just go back to our services meanwhile. Go to S3. Let's see if we have anything in the config part here. Config bucket, I have it here. There you go. My AWS logs will be maintained here, right? So you can open it if you want to. So this opens in a separate page. Right now, I don't think we have any data in here. Okay, there's a config check file. You see, you have data about the configuration that is happening here. Object URL. Yeah, error. That's gonna be an error right now. I'll tell you why. So our EC2 instance, it's here. 0 instances because we've stopped it already, right? And the other thing that I wanted to show to you people is, let's go back to config. So guys, what we've done is we've actually gone ahead and seen we've actually gone ahead and kind of had an instance that was stopped, right? After that, we created or changed some settings in our AWS config and for SNS as well, right? So let's first just go back to SNS once. Simple notification service. And there I want to see what are the topics that we have, right? Do I have the desired topics there? Config topic is here, right? What do I need to do now? Can I just open this topic? Yes. Okay. Or I can rather go to subscriptions. Create a subscription. My topic should be AWS SNS user East config topic. Okay. Protocol should be email. And what is the email ID that I need to add here? Let me just go ahead and add my personal email ID, which I do not use regularly. Okay. So I say, there you go. And I say create subscription. So guys, no sooner I subscribe here, if I go to incognito and log into my Gmail, I should be able to see all the data that is needed here. Okay. At least the subscription data that I'm looking for. There you go. AWS subscription. Confirm the subscription. Please do that. It will throw in a small patch up. You subscribe to this thing. Okay. So the subscription is in place. Now, how do I track some of the data that I have, right? So let's just go back to our service, that is config. And in config, I basically have to go ahead and where do I look? Resources, is it? Yep. So in resources, my data should be, or the data that I'm looking for is my EC2 instance, is it? So I say EC2. See, these are the services that you can monitor, right? The names that you see here. There you go. So instance is what I want to look up to. I say lookup, there's an instance, I open it. And here too, I have quite a few things, right? I get details about the instance that I've launched, right? Compliance timeline is something that I can do. I can even go to manage resource. If I click on it, it will take me to the instance, right? It has been stopped. So it's giving me data about this instance as well. If I go to compliance timeline not found. Why is that? This should not happen. You should have a compliance timeline. Let's go back to resource. Let's search for EC2 to start with. Instance. Okay, you cannot search it like this. So let's just scroll back again quickly as we were doing a while back. And I'm gonna look for the EC2 instance that is there on my plate. Did I like just, what is wrong with this thing? Okay, this is irritating now. This is where I want to be in. Yeah. Okay, there you go. Look up. The instance is in place. Just click on it. You should have your, okay, you should have a configuration timeline at least. There you go. You have it here, right? So probably this was the time when I did actually go ahead and had my configuration in place, right? So this is where it will start tracking all that is happening here. And I would get instance or even the notifications about what has happened. So probably I should be getting a notification in like 15-20 minutes saying that my instance has stopped as well. Okay. So you get all these notifications when you subscribe to your config, right? And this is what it does for you. So this is what AWS config is in a nutshell. As I've mentioned, you can even go ahead and look for inventory as well. So there should be inventory management somewhere. Systems manager. I think this is the one that lets you do that. You can get started with systems manager. You can gain operational insights and take actions on your AWS resources as well. So basically you can do that as well, right? You can connect some of your services here and then get insights on that as well by using AWS systems manager as well. Okay. But this is how AWS config works in a nutshell. I don't want to get into a lot of details. Okay. So the reason I had stopped that instance was because I wanted to see if there is any change that I would get right away. But right now I'm not getting any change. Okay. Because as I mentioned, it takes time normally for your resources to respond, somewhere around 25 minutes. So unfortunately, I don't think that this demo would last that long for us to actually go ahead and look at it. But if you do this with me, right, what you can do is you can meanwhile just go ahead and ensure that you also follow these steps. And once you do that, you'll get information about all the data. You see, my configuration dashboard has been updated. There are these many security groups here, network interfaces, subnets as well. You see, so all the information would be tracked here. If I open any one of these, I can check for configuration timeline for everything that has happened. Okay. So right now I've actually launched in this service now, right? So that is why I'm getting the recent information only. So whatever changes happen to these resources, all these would be reflected in your inventory. So make sure you observe those changes as well, right? And handle your resources accordingly. Okay. So do that. Meanwhile, I'm gonna just delete my instance. I do not want my instance to be there, or maybe we can keep it running, right? Let it be. It's not very important. Okay, guys. So this was about AWS management tools, right? So let's end the management tools part here and here. So guys, now when you talk about AWS services, AWS offers storage services, compute services, management services, monitoring services, right? It provides machine learning, DevOps, and a number of other services. One important service that it offers is your database services, right? So when you talk about databases, guys, there are a lot of pointers that we need to explore. Okay. So talking about databases in general, right? So what databases do is they basically let you hold your data, right? Storage services let you store your data. Databases is something that lets you, when you talk about databases, right, they let you hold data that can be processed, right? They give you processing capabilities as well. So databases are very important, right? Because you can process your data there, something that is very important. Your databases can be relational in nature, non-relational in nature, right? I mean, whether you talk about structured databases, unstructured databases, the types are plenty. On AWS, there are quite a few services that let you spawn or manage these databases. Now, when you talk about AWS services, they are not databases. Those are services that lets you create or support or manage databases. Okay. So there are two important pointers, two important things that you see on the screen. One is your AWS managed database. The other one is your self-managed database, right? So if you talk about an on-premise infrastructure, this is where you have your self-managed databases. So an important point about AWS is it does not force you to actually go ahead and configure your resources, right? It's not always that you have to go ahead and manage your own resources, right? That is the plus point of using AWS. And when you talk about databases, it is no different. So if you talk about your self-managed databases, there are a lot of things that you'd be doing on your own. You can see on the screen, right? You have to manage, backup your databases, right? Take care of replications, security, OS, and server. So just like if you talk about different service models, right? When you talk about service models, there is a part of things that you control and part of things that your vendor controls. Say, for example, when you talk about platform as a service, right? So the entire platform is managed by a vendor. All you manage is your data and your applications, right? But if you talk about your infrastructure as a service, only the infrastructure is managed by your vendor. Say, for example, he or she or the vendor basically manages your security concerns, your networking concerns, right? It takes care of all those things, right? Even the middleware that is being provided to you. What you are concerned with is deciding what kind of operating system you want to launch and what kind of applications you would be running on top of it, right? The other configuration part is managed by your instance provider or your vendor, in this case, vendor, right? So when you talk about databases, it is similar, right? If you are to do it on yourself, first you'll have to take care of everything. You'll have to put your servers in place, right? You'd have to put forth your patches, your operating system on top of it. Then you'll have to actually go ahead and have your servers being set up. Those servers, you'll have to manage it, take care of everything that is there for the servers and also for the databases. Have database backed up properly, get proper application of all the data, take care of all the security concerns and operating systems as well, right? And then, as I've mentioned, you have to manage your servers as well. So this can be a tricky task. With AWS, you can decide how do you want to manage these instances. Do you want to set up the infrastructure by yourself? Do you want to control some of these factors? Or do you want to lend all of these to your vendor, right? So when you say shared security model, AWS basically supports security principles as well. It gives you control over what security parameters you want to take control of and what do you want the vendor to handle for you. So when you say that your vendor is handling a certain set of services for you, right? So in that case, he's keeping those services secure for sure. Okay. So when you talk about security as well, even the security part can be decided as in, do you want the vendor to control it or do you want you to control it yourself? So when you talk about managed databases, AWS gives you this freedom as in, do you want to control the infrastructure or do you want everything to be controlled by your vendor itself, even from the platform perspective as well? And you just want to go ahead and put forth your data there. So if you want that, you can actually go ahead and just spawn your database instances and just manage your data on top of it. So you have that much amount of freedom here when you talk about AWS Database Services, right? So when you talk about AWS Database Services, there are quite a few database services that are offered. Now these database services aren't databases. They are basically something that let you control these databases, unlike your actual database. So you have an option of spawning or choosing certain sets of databases that you want to launch, but these services are not databases. They are services that manage it. Okay. What are the services that AWS has on your plate, right? So this is what the slide says, right? Basically, when you talk about databases, these are critical to dealing with data. And these days with data that comes in different formats, what we have to do is we need databases that can handle this data. Amazon Web Services provides reliable, relational and non-relational database instances that are managed by AWS. So what are these database services that you have? It says that relational database, right? So when you talk about relational database service, the most popular one that you see on the screen is your relational database service, RDS, right? So basically it helps you deal with relational databases where your data is structured data, right? Then you have your other database services as well. You have your Redshift. You have your Amazon DynamoDB, which scales like anything. I mean, people say that DynamoDB does not have an upper limit. I mean, it can scale as much as you want. And this is something that has been quoted by people who actually spoke in AWS reInvent. So you can understand how severe the statement is, right? So when you know that it can scale as much as you want, it gives you a lot of freedom, right? Then there are other database services like you have your Kinesis, you have Aurora, right? You have your Elastic Cache. So all of these, they have their own features, like whether you want to control data warehousing, whether you want to do data analysis, right? Do you want to have simple relational databases? They have their different capabilities and they support different sorts of storages, right? So let us go ahead and understand these databases a little more before we jump into the demo part. Okay. So first on our plates, we have Amazon Relational Database Service, right? Amazon RDS or Relational Database Service. It is easy to set up, scale and operate database service, right? It is cost effective in nature. It is resizable and it can automate basically your administrative tasks, right? So when you say Amazon RDS, right? Yes, all these factors that we read about it are true. Basically what it does is it lets you set up, operate and scale a relational database in a cloud. And this you can do in just few clicks. When you say few, there are more than few. So there are two options that it offers. One is an easy setup where you don't have to worry about anything. And there's a normal setup where it takes longer for you to set it up, but there you can choose a lot more options that you want to do, right? What are the database engines your RDS supports? I mean, now when you talk about RDS, it supports different database engines as well, right? Because there's no one particular type of database that you handle. It can be your, whether you talk about Amazon's Aurora, right? It supports that as well. Whether you talk about PostgreSQL, MySQL, MariaDB, Oracle, SQL Server, all of these are handled by it. What are the features it offers? It's really easy to administer, right? It basically can operate with it using the management console, which is nothing but your GUI, right? So with GUI, it is always easier to handle these databases. You can do it through your command line interface as well if you want to. This one scales very easily, right? I mean, whether you talk about compute or storage resources, again, spend like a couple of minutes and it should scale right away. Highly available, highly durable, and it supports multi-AZ deployment as well. So you can deploy your resources in multiple availability zones too. It is very fast, secure, and also it is very inexpensive, right? So this was about RDS, right? We also have Amazon Redshift. So when you say Amazon Redshift, this is another database service that AWS offers, right? So basically I was mentioning a pointer here saying that if you talk about Amazon or if you talk about AWS databases, they also support your data warehousing requirements as well. And when you talk about database or data warehouse requirements, you have your Amazon Redshift on your plate. Okay. So when you talk about Amazon Redshift, basically it is a fully managed database service. Again, all these databases, the plus point they give you is most of them, they scale up in petabyte scale, right? And they are easy to upscale and downscale. So increasing amount of traffic is not a problem here. Okay. So that is one plus point, right? And the other thing is, you can think of it as a web service, right? As you can see in the definition itself, it is easy to set up, manage, and scale a distributed and cached environment of AWS cloud platforms. You can also connect your Redshift to Amazon QuickSight. Now, when you say Amazon QuickSight, it is a service that lets you do a business intelligence or basically data visualization, just like your Tableau and Power BI. So whatever data you have in your Redshift, you can actually go ahead and move it to Amazon QuickSight as well. That is where you would be able to query or question your data that is there in your hand, right? You can even actually go ahead and connect it to your Amazon Aurora or RDS, right? And you can actually acquire your Redshift database as well. So it is more or less something that lets you have a database in place. Data warehouse in place, So it is a data warehouse service to which you can connect different database services and even your BI tools to process this data, just like we do in our data warehouse services. So what are the other benefits it gives you? It also connects to your machine learning services like your Amazon SageMaker. Whether you talk about EMR, Amazon Athena, you can connect to all these services, right? And basically do analytics using it as well. Now, if you compare it with other data warehouses or data warehouse services provided by other cloud platforms, right? So AWS confirms or basically makes a claim that it is 3 times faster than any other cloud data warehouse that is there. They believe that the performance is important when you talk about cloud platforms, and that is why they have ensured that it works at that faster paces. And for that, they use a typical kind of instance called as your RA3 instance. Okay. Again, we talked about its speed, and another important point that is supported here is costing wise also it is cheaper compared to other data warehouse cloud services. And if I were to make a claim, it is like they claim at least that it is 50% cheaper. Okay. So this was about Amazon Redshift. Let us go ahead and talk about Amazon Aurora, right? So when you say Amazon Aurora again is a database similar to your RDS, but here it is compatible with your MySQL, right? And apart from MySQL, it supports your PostgRE SQL databases as well. Where would you use your Amazon Aurora databases in case if you require high performance and high availability? In simple words, if you're dealing with enterprise-wide data, this is where your Amazon Aurora would come into picture. Again, it is simple in nature, and the best part about it is very cost effective. Okay. So again, it has those standard benefits, like it will give you high performance, right? So when you talk about its throughput, it is like 5x of any standard MySQL database. And if you compare it with PostgRE SQL, it is 3 times faster than any other normal PostgRE SQL databases. Availability, now you have the option of doing multi-AZ activities here as well, 99.99% available. What this means is in a year's time, even if your databases go down to the max, they will go down for like half hour. That is if they go down, which is rare to happen. Okay. So in a year's time, that is a very big achievement to have. Apart from that, you can actually continuously back up your data to your EC2 instances, not EC2, sorry, to your S3 storage services. You cannot back up your data on instances. That is a compute service, but you can actually back up your data in your storage service. That is your S3 service, right? You can actually encrypt this data as well to ensure that it is secure. So it supports KMS services as well, right? And these databases are fully managed. It is a fully managed service, so you don't have to worry about anything. You can even migrate your data because AWS provides migration support for your Amazon Aurora databases. Okay. So guys, now when you talk about DynamoDB, it is very important because now what DynamoDB does is it basically lets you handle your structured and unstructured data, right? So when you talk about DynamoDB, what it does is it ensures that it handles or provides managed services that deal with NoSQL databases as well. So what is NoSQL? NoSQL stands for not only SQL or SQL, right? So NoSQL is nothing but that kind of databases that handle unstructured data as well. Because your SQL databases will handle your structured data, as simple as that, right? So when you talk about unstructured data, how do you deal with it? For your unstructured data, you would be needing services that basically support data in different formats, and we do not have all those relational principles applied to it. Even if those are applied to those in a different form. Now these databases basically support big data applications, right? So if you have unstructured data, you can do that. Important point here is, guys, when you talk about big data, you're talking about a huge amount of data. So latency becomes very important here. You do not want latency lags. Who takes care of your latency lags here? It is taken care by your Amazon DynamoDB. Okay. This again can scale at a very good level, right? And it is a key value and document database. So when you say key value database and document database, we are talking about unstructured databases here. So if you worked on big data, these terms would make a lot more sense to you, right? What it also does is it supports low latency, as I mentioned. How does it do that? How does it support your low latency services? Say, for example, if you have certain distributed applications and you require faster access, talk about microsecond latency, which is very less. Second itself is very small, right? So when you talk about microsecond latency, this can be handled by a DynamoDB accelerator. It is called as DAX. Do not mistake it for the Power BI expressions. This is different. This is DynamoDB accelerator, right? It again is a cache, memory cache that lets you ensure that you have microsecond latency as well, right? You do not have to worry about managing your servers here. Why? Because it is serverless in nature. So that is one plus point. So your installations, maintenance, operations of your software, everything is taken care by this serverless service here at your hand. Okay. And it automatically scales to meet your requirements if there are any. So this was about DynamoDB, right? Let us go ahead and understand some other pointers as well. So we have Amazon Kinesis. Now, when you talk about Amazon Kinesis, it is a data analysis service. Okay. Everything happens here, right? You can collect the data, process the data, and do real-time analysis on your streaming data as well. So when you say your streaming data, right, we are talking about that data that is flowing, that is continuous, right? And that can be handled by your Amazon Kinesis. Now, if you ask me, as in how does it handle real-time data, right? So if you've talked about real-time data and you know big data applications, right? You know that there are processes like ingesting your data, buffering your data, and processing streaming data in real time, right? So if you talk about Kinesis, it takes care of all these activities. Okay. And it again is a fully managed service. What is it capable of? It is capable of handling video streams. It can help you handle your data streams as well, and you can connect to ML services to basically process and analyze this data that is there in your hand. Okay. If your job is to do ETL activities like load your data, you can do that by using Kinesis Firehose. Now, these are sub components of your AWS Kinesis. Okay. And then you have a separate component called as your data analytics. That is Kinesis data analytics, which lets you analyze streams of data with SQL or even with Java if you want to. How it works? Basically, you have to consider 3 pointers here. One is your Kinesis data streams, Kinesis Firehose, and your Kinesis data analytics. So assume that you have a camera through which you are capturing certain streams of data, right? And now this stream of data, basically what you have to do is you have to move to your video streams, that is Kinesis video streams. Here you can ingest this data, right? Store it, encrypt it, and even add indexes to it for batch analytics. Once that happens, then you can move it to your machine learning or cognitive services that AWS offers. Amazon Rekognition is one service that lets you process your video streams, and these streams can be processed by your Rekognition service. Amazon SageMaker is something that gives you your machine learning insights on this data, and even that can be controlled by using these services. Okay. So this was about AWS Kinesis. But wait, what is the output that you can expect when you talk about all the process that I just mentioned, right? Whether you talk about your real-time operations or whether you talk about your batch-driven machine learning applications, even video processing, all these things can be processed or given result to you by using your Kinesis service. And then we have our AWS Elastic Cache. Now this is probably the last of databases that we'd be discussing today. Okay. So let's try and understand what it is. So as the name suggests, it's a cache, right? So when you say cache, what it does is if you have in-memory data requirements on your cloud, right, which are open source in nature, your Elastic Cache takes care of it. This again lets you run and scale the data stores with ease so that you do not have to worry about the data that you're moving in. When do we use Elastic Cache? Elastic Cache is used in places where you need high performance, right? So when you say high performance or extreme performance, we are referring to quick latency again, right? And you have applications that require like sub-milliseconds of response, right? And you want end-to-end optimized stacks running on your customer dedicated nodes. Amazon Elastic Cache is something that would actually let you do these things, and it does that at a blazing speed. This again is a fully managed service that you have in your hand, right? And you can scale at will to ensure that you do not have to worry about the traffic issues that are there. It has certain set of engines, whether you talk about Elastic Cache, which can be for your Redis, for your Memcached, and probably these are the two it supports, right? So this was the final set of database service that we have. let us get into the demo part, and probably then we can see what we can do there. I'm not going to go ahead and launch or spawn a full-fledged database service, but let me walk you through it, how the process works. Okay, so let's just go back to the demo part and discuss how you can actually go ahead and launch a relational database using AWS, right? Okay, so in this case, what I'm going to do is I'm going to go ahead and get into my RDS service. That is my relational database service that is there in my hand. Okay, so guys, let's just go ahead and create a database here, right? So I have two options, right? I have my Amazon cloud where I can create it. This is in-house is what I would call it. And the other option obviously would be on my on-premises, right? So what are these two options? This is where you create a cloud store on top of your instance of RDS. So probably this would be, if I'm not wrong, this would again be your EC2 instance, because that is the service that gives you your virtual machines here. And then you can do it your on-premise version as well. You can have your VMware data centers. You can choose that. Since we are using AWS free tier, let's stick to the EC2 version that we have, right? Now there are two options. This is an important point that you should know. Okay, so you have one, your standard create, and the other one is your easy create, something that I mentioned while we were discussing databases, right? So when you talk about your standard create, right, you will set up all the configuration options. Now these could include your availability, security, backups, and maintenance. We'll use the standard one so that we can go through all this process. Easy create, what it does is whatever is the best that AWS feels that would suit in the requirements, it would by default create that and roll it out. Okay, so what are the engines that we have on our hand? We have engines like your Amazon Aurora, right? Amazon Aurora, and this next one is MySQL, which is a simple type of database that we have on our hands, in our plates, right? Next is your MariaDB, right? You have your PostgreSQL, Oracle, and even your Microsoft SQL Server. So these are the databases that I can choose from, right? And when I choose these databases, I also have an option of selecting its subversion. For now, let me just go ahead and select MySQL. So when you say MySQL, right, you have these versions that are there on your plate. So depending upon the kind of application that you want to launch, right, you can choose any one of these versions that is there, right? So by default, it has selected MySQL 8.17. Let's just go for a lower version. We are gonna launch it, but we are not gonna go ahead and use it any which way. So let this version be selected here for now. Okay. What are the templates, right? So guys, these are three important points, right? You have your production, you have your dev test, and you have your free tier. So what is a production environment? So guys, when you talk about production environment, it is something that your end customer would be using it, right? So in that case, your availability becomes very important. You cannot let your data go down for a while as well, right? So in that case, high availability data centers are advisable. You want to spawn it on resources that are always available. So when you choose production, that is what you'll get. But again, this does not fall under your free tier. You'll be charged for it. And this is where you'll actually spawn up a server for yourself, right? Dev test is somewhere, basically it is similar to your free tier, right? But it is intended for people where you want to actually go ahead and test this database or whatever data you put on top of it in the development environment, right? So it is for the testing phase. Now, if you talk about your free tier, it's understandable that this would be with meager and minimal resources. What you read here is it says use RDS free tier to develop new applications, to test existing applications and gain hands-on. So this is for your practice sake, guys, right? I mean, this would be with the minimal resources and you won't be charged anything for it. Let's stick to the free tier one for now, right? What are the settings, right? Guys, what is the identifier? What is the name of the database that I want? Database, what I want. I'm sorry for that, okay? So this is basically will tell you what is the name of a database should be like. What are the credentials required? Try to log in for the master user of your database. So you would be wanting an admin access here, right? What is the password that I should set up? Let me just go ahead and type something here. Maybe something like great learning. Let me try it again. So something like great learning @ So guys, what is the DB instance that you want? Do you want it burstable, right? Do you want it in memory or standard optimized? By default, I'm getting it burstable. These are my general purpose instances that give optimized performance to you. But if you want, you can burst it up to a greater extent for a limited amount of time. Standard and memory ones would be costlier. Don't fall under the free tier option that I have. What is the kind of storage I want? It can be provisioned IOPS or even general purpose, right? Allocated storage, I can choose something that I want. I can go for like 20. I can even go for 10. It does not matter really right now. Okay. And now multi-DZ deployment, right? Multi-AZ deployment. Why is this option here? Say for example, if I were to move it into production, I would be requiring more availability, right? Under free tier, I do not have an option to choose this. But if I want to create a standard backup in some particular region, in that case, I can use multi-AZ deployment as well. Okay. So that is what we can do here if you want to, but we are not going to go ahead and do that. And the reason is very simple. Right now, we are not concerned about that larger scale application that we have on our mind, right? So default VPC, yes, I can create my own VPC if I want to. VPC is nothing but your virtual private cloud, right? So basically when you try to spawn any resource, it has to fall under particular subnet, particular network in hand, right? Where do I get that network from? How do I get that network? I get that network by creating VPC. It is nothing but a virtual private cloud, a networking service. So it creates a subnet for me or a virtual network for me. Okay. So let it create a default VPC, right? Password authentication, authenticate using database password. So whatever password I've entered, I can authenticate using that password. I can even set up an IAM database authentication. So when you say IAM, right, identity and access management, basically you can create a role, right, or create a user that can access this particular resource. So you can do that as well. But we have already given in password, so let's stick to that. Do I need to add in additional configuration details if I want to? So you have these options. You can go ahead and add these. Let's not do that. And now I'm going to just go ahead and say create. Okay, so the passwords do not match. I was expecting that to happen. Now let's see if I can match these. And I'm just going to go ahead and say create. Let's just say auto-generated password. I'm gonna just go ahead and say create. So there you go. Just like that, my instance would be up and running. It might take a few minutes for this instance to launch or this database instance to launch. And once it's done, it's up and ready for you to use. As I mentioned, I'm not going to go ahead and connect to this instance. For that, you'll have to SSH into it. And I don't want to SSH because for that, I'll have to again go ahead and download a putty generator and then actually go ahead and convert my PIM file into a more usable password that is understood by my putty and putty generator, right? So let's not do that, but I believe the part that I wanted to explain here is clear to you people. So let's just quickly go ahead and delete this later. I'm not going to do that because I'll have to wait for it to get created first. And after that I can delete it now as well. I'm just going to go ahead and say delete. We have to type delete me. Okay. So this would be deleted even before it gets created. But I believe the gist is clear to you people and you understand what was expected out of it, right? Okay. So this is pretty much it, right? Let us now move further and take up a certain set of questions that I feel we need to answer, right? So normally when I do take live sessions, I normally get quite a few questions that people put forth. And I felt that we should discuss some of those questions here. so that we can close this thing properly, right? So what are the questions that people normally ask? So when you talk about Q&As or questions, right, what questions people normally have is people ask questions like, okay, as a fresher, do I have hope of getting a career into AWS, right? See, nowadays, cloud industry is growing at a pace which no industry is growing. If you talk about times, like if you go like 5 years, 7 years, 10 years back from now, the topics that people expected you to learn was something like Java, right? A programming language. Now what people expect you to learn is something like Python, right? Give a couple of years and we would see that cloud computing being taught in colleges itself, because it is something that is here to stay. And then we'll see a lot of people getting hired as a fresher only. And we still have companies like Accenture. What they do is they hire, like they go to a particular college and pick up like 200, 300 people at a time. And nowadays there are so many projects that are on cloud that I've seen people even as freshers working on these platforms like AWS and Azure. So they are being trained as well and taken further as well. Now your question would be, as a fresher, not through campus, would I get placed? As a fresher, yes, the chances are more. The reason is, as a fresher, a company would not expect you to know a lot about AWS, right? What they would expect you to know is, can you work on basic fundamentals? Say, for example, if you talk about AWS, there are like tons of projects. If you visit their website, you can do so many things. There are like 10 minutes projects, 15 minutes projects, and even 2 hours projects that have been defined. There are projects that take you a day or two as well if you want to implement. So if you can take up those projects, most of them fall under free tier, right? You can build a resume for yourself and you can probably have a career here. So there are people who also ask questions like, as a database administrator, can I get a job on cloud? Yep, you can move to AWS or even Azure, take the DevOps, not the DevOps, the SysOps certification for AWS, right? And if you talk about Azure, there are certifications that certify you in administrative practices. So you can take those certifications and probably implement what knowledge you have on your administrative level on cloud platforms, right? So these would require you to implement cloud computing, not cloud computing, but your administrative skills on top of AWS cloud. So when you talk about questions, some people also ask questions like, I'm from a testing background, can I get a job here, right? So for you do not have any specific certifications that cloud platforms provide to you. But if you have like right set of testing skills, maybe you can get or opt for DevOps certifications, learn a little bit of development as well. And in process, you would be given an option to test applications on top of cloud, right? Then people who have knowledge about mainframes and stuff, they can also get into virtualization technologies and stuff like that. So the opportunities for people on cloud are plenty, right? I mean, it's all about how do you explore those. So I believe I've answered the major questions that normally people have, which are important from a career's perspective. As far as this session goes, I would be resting it here. So there you go, guys. This brings us to the end of this discussion. We have successfully discussed quite a few pointers to a lot of depth. Let us now go ahead and summarize these pointers. So first and foremost, we understood cloud computing fundamentals like service models and deployment models. Then we did go ahead and understand AWS, what it is and what are the career opportunities it has to offer to us. Then we talked about the global infrastructure that is there when you talk about AWS. What are some of the core domains it offers and what are compute services in specific? What are AWS storage services and how networking works on top of AWS? Then we did go ahead and understand implementation of DevOps on top of AWS, implementation of machine learning on top of AWS. We understood what security services AWS supports. What are some of the cool and important monitoring services that AWS has to offer to us? How databases work on top of AWS. And finally, we finish things off by answering some of the important career questions. So that is it. Now, if you like this video, ensure you leave a like for this video. And we would also like to inform you that at Great Learning, we have come up with Great Learning Academy initiative where there are 80 plus free courses that you can register to. And on completion of these courses, you can actually avail a certification that you can add to your LinkedIn profile or to your resume. And that would hold a lot of value for you. That's it from my end. Thank you and have a nice time ahead.